Right. So good morning, everyone. Welcome to this 147th edition of the ZAC World of Facade Conference Series. My name is Ahad Ahmad. I'm part of the organizing team here at ZAC. I quickly want to introduce the ZAC World of Facade Conference Series. It's not new to India, but it's new to Pune. But I just thought I'll take a couple of minutes to talk about the conference series. We've been organizing this event since 2012, back in Bangalore on the 27th of June. We started this event. We started it as a small networking event to talk about facade design and engineering. There was not much happening on facades that time around, but then what happened is the event turned out to be something which was interesting for everyone. We were able to take it to different cities across India, and then by end of 2014 we were able to take this globally. Currently we are organizing this event in 39 countries around the globe, and by end of this year we should touch 44 countries. So it's an event which has been designed, engineered and executed from India across the globe. It's not done only in English, it's done in multiple languages. In whichever country there's a requirement of a non-English language requirement. So facades are becoming complex as we progress. There's also a growing need of sustainability, safety, structural performance. Climate change is not helping either. So your facades need to be airtight, weathertight, waterproof, all that stuff. So there's a lot of excitement in facade engineering nowadays. So people are taking facade engineering much more serious than what they were a few years ago. In India, we've obviously been doing these events in different cities. We predominantly repeat these events in Bangalore, in Hyderabad. Mumbai is a yearly event. In Delhi, we've done a couple of editions in Ahmedabad, in Chennai. I think we're a little late to the party in Pune, but I think the time is right. There's a lot of activity happening over here, not only in Pune, all across India. And I think today would be a good starting point for all of you to see what's happening in the world of facades from architects who are locally based here, from national based architects, from facade engineers, which are predominantly in other larger metro cities of India, and of course a couple of key building material manufacturers without whom we wouldn't be able to do these events globally. I'll start with thanking our event partners. So I'll start with our presenting partner for today's event is Schüco. So Schüco is a German company. They are an aluminum door, window, curtain wall system company. They provide systems which are then fabricated by their partners, which are then used on all kinds of buildings. So Schüco has been a strong supporter of these events globally. Aluplex is a facade contractor doing projects all across India. They are powered by partners. Blix System, who are represented by their local distributor partner, Diamond Engineering Corporation. They've got stone fixing systems, they've got some podium glazing solutions and other innovative solutions. You've got Cotswold Architectural Products, which is basically a British company which has friction trays and other hardware and accessories for doors, windows and facades. Dow, formerly Dow Corning, was known. Dow is a sealant brand. They were formerly known as Dow Corning. They've rebranded a couple of years ago as Dow, which is the mother company. They provide sealing and bonding solutions. Future FG Glass, which are one of the leading value-added glass processors out of Mumbai, Maharashtra. Fundamax, one of the world leaders in high-pressure laminate cladding. So they've been able to reinvent high-pressure laminates in a high-pressure format, which can be used on the external cladding. Diamond Engineering Corporation is also participating with GE Silicons. They also have sealing and bonding solutions. Glazium Facade, one of the fast-growing Pune-based facade contractors with a growing national portfolio. Hasten Extrusions, again one of the faster growing aluminum extrusions company. Aluminum extrusion profiles can be used for various applications. They also focus on the architectural segment. Kinlong, one of the leading Chinese companies which have accessories for glass, doors, windows, hardware, railings, LED lightings, gaskets. They've got almost all the gamut of accessories which are required to build a building envelope. Panasonic KMEW, so they are a recent partner with us. They've got an interesting ceramic cladding solution, a non-combustible solution which can be used on external facades as a cladding material. You've got Olac, which are basically distributing side rise. So side rise is a pacifier protection product which is used in rear ventilated cladding and in curtain wall perimeter protection. It basically prevents smoke from moving from floor to floor and compartmentalization of the building envelope. We were one of the leading aluminum composite, metal composite panel manufacturer based out of Maharashtra with a big national and international portfolio. And of course, the basis of these events have been the exhibitions which we've been doing since 2003 on glass processing, on doors, windows, fenestration, aluminum extrusions. We were able to bring the exhibition format into a more interactive one-day format here with presentations, with panel discussions back in 2012. And on this basis, we were then able to scale the event globally. Our next event is next week, next Thursday in Manchester in the UK. We've got one followed the following week in Miami in the US, Toronto in Canada, Zurich in Switzerland, Paris in France, Lisbon, Austin in the US. We've got Delhi in August. And of course, the largest event in the Indian series is obviously Mumbai. So our next Mumbai edition is on the 4th of October. So this is what we do with the events. We bring together architects, consultants, contractors. We have a mix of people sharing their stories. This is all about storytelling. Everyone has a different story to say. Either it's a project or it's a concept or it's a product. We get people together and then the magic happens. We won't take any Q&As today. We will go straight into all the presentations. Our presenters will be around in the networking breaks. All our sponsors have their exhibiting booths outside. Please visit them in the networking breaks or whenever you can. Would be very interesting for all of you to see what solutions they have that could be useful in your projects. We've recorded today's events, so we'll send a YouTube link of the presentations a week from now of all the recording which we've got permission to share with. Some are confidential presentations, so we would not be able to share that with, but the rest we will send a YouTube link which will have all the details. So that's it from me. I hope you'll enjoy this first debut edition of this conference in Pune. We've got an interesting agenda today, packed 4 sessions, wide range of topics from, again, local architects, from national, international consultants, and from a global supplier pool. To start off today's session, I'd like to call upon Rohan Keswani. He is the director of Aluplex, one of our partners for today. Rohan will be taking stage. Thank you.
Well, good morning, ladies and gentlemen, and welcome to the first edition of the ZAC World of Facades here in Pune. It's the 147th edition globally, and this is the first one here in Pune, which only tells us about what is happening to the facade market here in Pune. We have thank you, Ahad, for setting the tone for the day. As he said, we won't be taking any questions after each presentation, and you can find everyone in the networking break. If I can please ask all of you to put your phones on silent so we don't have anybody disturbing us during the presentations, that would be lovely. And we have with us a long list of very, very interesting presenters today. We have facade consultants, we have architects, we have developers, we have product specialists. So we have a long list of people. We were just waiting to see whether we're going to start off with Mr. Abhishek Arora from Morphogenesis, who's here, who's going to start the first session. followed by somebody who's going to speak from Fundamax, and then followed by a prestigious facade consultant over here, Mr. Ritesh Jindal. So, right. So sorry about that, a little change in the schedule. We're going to start off with Mr. Ashwini Khanna from Fundamax, who's going to talk about double skin facades. Ashwini Khanna, ladies and gentlemen.
Where beauty touches the surface, it is art making itself useful, touching the heart all the while. Individuality is what we want to offer. Uniqueness is what you make it. We see ourselves as co-designers of your design wishes. That's how we become partners in your success. Our origin is the book in which we turn the pages to read the future. Since we know where we come from, we also know where we want to go. Our products know it too. They want to find their way to you. Perfection is more than a claim to our skills. It is our way of showing respect for natural raw materials. Our way of bringing production and processing to perfection. Change has been our constant for 130 years, and we're doing it again. We change, we think ahead. We are open for new things, for inspiration, for innovation, and collaboration. Open for you, and open for you to create.
Good morning, Namaskar Pune. So since there is no Q&A session, but we would definitely like to interact with the audience, lovely audience. This is the first edition in Pune and we would not miss the opportunity of interacting with you. So before we get into thick of things, I would request my colleague to start the Menti. While your phones are on silent mode, but I would still request you to take out your phone and open menti.com on your phones. We will do a small interaction and I will take some of your inputs about facade. So once you have opened menti.com, this is the code 6910001. Menti is MENTI.com. Yeah. 3 people have logged in, 4, yeah, super. Super is getting bolder, so many people are saying their mood is super today. Fresh energy, exciting. Still people are logging in, 27 people have logged in. Yeah, in interest of time, we'll move to the next question. Thanks for this input. Now, the next question is how important the facade is while designing the building. It should always look fresh because it is the identity of the building, it is the face of the building. Yeah, we agree. Very important, crucial, critical. Most important and very important is getting bolder here. Yeah, it's a very important part of the building. Critical is becoming bigger now. Interesting to know this. Wow, many people are talking about looks, functionality, critical importance of the facade. Thank you for this very interesting input for us. Next question, please. What is your expectation from facade material while making the unique design? We call it as unique because, face of a building has to be unique. All the buildings may or should not look same. Sustainable quality, they can also be linked. Long lasting, durable, unique again. Thank you once again. Next question, please. What role facade material plays in ensuring the fire safety of the building? Yeah, this topic was also touched upon by Ahad in the introduction. It's also important, yes? We know some of the fire accidents which have happened, the biggest one like Grenfell Tower. Most important again, priority. Interesting to know that we are talking about this topic as a priority today. From my childhood, I actually remember Uphar Cinema tragedy, which was basically because of combustible material being used inside the cinema hall. Yeah, so this is very important. And that's why we talk about class A and class B material. Yeah, next question, please. So yeah, this is the question actually. How has been, I didn't want to know just the weather today. The audience from Pune, if they can, give this input, hot. Oh my God, too hot. Dry. Yeah. Extremely hot. But this was never the weather in Pune. I have studied in Pune actually. Almost 2 decades back. This was never the weather. Dry, warm. Yeah, so lovely audience, fresh mood, fresh energy. Weather is really spoiling it, isn't it? Yeah, thank you for your input. Thank you for participation. Now I will get into thick of our topic, which is about rear ventilated facades, double skin facade, and some of the unique applications we would like to show. So rear ventilated facade is nothing but a skin of a building which has a gap between the wall and the facade. So this will allow air circulation to happen. So this is not trapping any hot air inside the cavity, thereby giving energy efficiency, thermal insulation. Even it acts as a rain screen facade system, giving a protection from the rain, sound insulation. Yeah, so these are some of the benefits of rear ventilated facade system. This helps in making buildings more sustainable and buildings will breathe. Now, why double skin facade? So double skin facade will further help in enhancing the energy efficiency of a building. It will help in thermal efficiency as well. It will give a comfort to the occupants of the building, thereby having a right shading effect. Yeah, so it will also provide natural cross ventilation. So these are some of the projects which we have executed, actually, keeping double skin facade. This is a project in Lucknow. This is like a clubhouse. So our panels have been used in front of a glass facade. So these panels, you can, as you see in the picture, these panels are CNC cut panels. So this helps in, reducing the loads on HVAC. Your loads on HVAC has been reduced. You have to use less air condition there. Similarly, it is also helping to cut down the excess glare inside the building, thereby giving thermal and visual comfort to the occupants of the building owners. Yeah. So another project, this is slightly different. This is like a louvre application. This is horizontal louvers. So these louvers can be designed keeping sun path analysis in mind. The angle of the louvre can be decided based on that. Again, the same principle, it will help in reducing the excess glare inside the building, giving thermal and visual comfort to the occupants of the building. This project is in Raichur, And GNA is the architect for this project from Bangalore. These are a couple of projects which we have executed, which are, earlier was the horizontal lure application, this is like vertical lures. So extreme right building is basically a project in Kerala. This is semicircular building having tropical sun throughout the day. So the angle of lure has been again decided in a way that, the excess heat and excess light is cut down. Same principle, giving heat insulation, cutting down the excess glare, and also reducing the loads on HVAC. This is another interesting application wherein you can use this as a screen. And these screens could be movable as well as fixed or fixed. You can move the screen as per your convenience. This is one project in Kerala. This is basically a higher thickness panel, because to achieve this kind of CNC, we have used a higher thickness panel. This application is basically a corridor. Our panel itself is having a NRC of 0.15, which means 15% sound will get absorbed. Now in the corridor, when students are making a lot of noise, this is very effective solution to absorb the noise as well as provide a natural ventilation. Again, this is Ahmedabad University project where luvers have been used. When the luvers are not open, it is looking like a plain facade, which you see on the left side of the building. Left side, this one. Yeah, on the right side, it is shown how luvers can be opened and it acts as a shading system as well as a movable luvers. Depending upon the sun, you can change basically the angle of the lure. And the similar application has also been done in the new building of IIM Ahmedabad, new campus of IIM Ahmedabad. Screens. Yeah, this is again a shading device. These are some of the international projects. These are some of the WOW projects we have executed in India. We have executed more than 15,000 projects in past 15 years. And the oldest project in Pune is almost 18-year-old in Lakshmi Road, which is basically a Jai Hind store. Since we acknowledge that, the weather in Pune is changing, it is becoming hot, it is a shift. So these kind of applications are enhancing the functionality of the building. Buildings cooler in the summertime. Yeah, these kind of applications are also possible wherein we can curve the panel if the radius of curvature is more than 2 meters. Yeah, this is authentic panel. Authentic panel changes its color with the change in, weather or a humidity level in the environment. It's very interesting to use this panel on soffits because it's a class B material and in case of fire there are no droplets or the smoke index is also very less. The classification is BS to D0 in this particular case, and we also have A2 class material where the fire property is A2S1 D0. So high-rise buildings, large soffits, canopy areas, it's really not a problem. We have also used, we have recently executed FOB bridges in Pune for the metro stations. There are 3 FOBs have been executed. Yeah, that's it from my side. Thank you for your time and thank you for your engagement. Yeah.
Thank you, Ashwini. So moving on, we have Mr. Abhishek Arora of Morphogenesis, who's Associate Director, leading the Pune office with a team of 25 people and growing with a lot of work. He's here to talk about his process in terms of design of the facades. Abhishek.
Hi, good morning, everyone. That was a great presentation, Ashwini. Thank you so much. First of all, I'd actually like to thank Zach for inviting me and having me over to, kind of lead everyone or run everyone through one particular topic which I actually chose, which is beyond the surface, the multiple facets of a building facade. Before I reach there, actually, I want to talk about Ashwini's presentation. It was very good, actually. It kind of gave me this background about how, a building facade is, how crucial or how important it is, and what are the various facets to that facade. A lot of these, the first exercise, a lot of these words were used: important, crucial, sustainable, crucial again. So I believe everyone kind of thought that the building facade is apparently quite crucial when it comes to design. Okay, so I'm going to start with this now, based on these 3 aspects that I want to talk about. What are these 3 aspects that I want to touch base on, which are the main actual facets of a building facade beyond the facade? These are microclimate and thermal comfort, facade as a cultural element, and designing high-performance skins. All of these 3 kind of combined together or individually taken up beyond the facade design helps in designing the 5th element. I would like to explain all of this through 3 of our case studies of our completed projects. When I talk about thermal, microclimate and thermal comfort, I am talking about in Surat, there's this very recently completed project, one of ours, which is called the Surat Diamond Bourse, recently coined as the world's largest office building as well, surpassing the Pentagon in the United States. That's the building. However, right now, this building is spanning across 35 acres, about 7 million square feet. Now, what did we do out here? We tried to achieve affordability and sustainability through a metric-driven design. Okay, and when we say a metric-driven design, it's about design that we can start measuring. And how do I start using these metrics to build my facade as well? Now, we know Surat, as a climate, it's very, very hot. Also, there's a lot of humidity around that zone. So what we tried to do around in this particular project is we had these green lungs which were embedded within the building itself, which cools the entire space of the spine area that you see in the center, which spans across about 500 meters. But what's very, very, I would say, prevalent over here is that we tried, in Surat, specifically, the prevailing wind directions is from the northwest, and those are the low velocity winds. So the entire curvature that you see up front and at the back, which is the north and the south, allows for that to draw us those winds inside the building, all right, and then allows through that Venturi effect. We kind of allow for those low velocity winds to come in and then come into the building, and through these green lungs that we have created across multiple levels of about 16 floors, allows for that air to come in and then go out through the stack effect. This is just basic principles of physics we all must have learned in school. Now, climate responsive design. How is this important? Being the spine on the west facade of the building and also learning from our past or from the 4,000-year-old architecture, the Indian architecture that we have. The west facade, generally also in Gujarat as an architectural element, needs to be kind of blocked to avoid a lot of thermal heat gain inside the building. So our east and west facades should always be kind of, blocked or have a lot of shading devices that we need to do, which I'll come to on the third part, which is the high performance skins as well. So what we did was we took this very small concept of a jali and we ran it through the entire building wall of the project. So instead of using jalis, we designed the whole wall as a Jali. So we see all of these, what you see out here, are naturally ventilated spine, which is spanning across 500 meters, completely naturally ventilated, and these are these punchers which allows for that wind or the air to start coming in. And by doing that, we've been also able to achieve a reduction in the ambient temperatures by about, I would say, 5 to 7 degrees. So all of these things kind of combined together allows us to create a facade which is responsive to the climate and also functional, which helps the building in reducing the thermal, I would say the heating loads or the heating load, yeah. So green lungs, radiant cooling, and punctured walls, completely naturally ventilated, traditional architecture and basic physics of green lungs and the stack effect. So because of that, we were able to achieve, through these passive design strategies, a reduced energy performance in the building. So the facade is not just about the skin of the building, but facade is also about how we create every other corner or junction of the building as well, which then eventually helps in reduce or helps in the function of the building as well, or even the occupants. Radiant cooling, these are some facts of Surat Diamond Boss. There's about 300 kilometers of cumulative length of radiant cooling, which was laid out across the entire spine. And that's how the green lungs look like. So the corridors that you see on the far west side are completely naturally ventilated, open. We have offices out here. So throughout the year, we've been actually able to reduce from a 32 degrees in Surat to about 27 degrees without any air conditioning. So that, everyone, was that west wall that I wanted to talk about, which from a very small concept kind of got converted on a larger, broader scale as a Jali. Second, facade as a cultural element. Now, this is the second facet that I wanted to talk about today, that what is it beyond the facade that we can do? Now, this, what you see out here, everyone, is Sanskriti campus that is there in Kolkata, in Rajarhat. What we're able to do out here is, so basically just to give you some fair idea or a brief on the project, this is spanning across 16 acres with a total built-up area of about 2.6 million square feet. What you see up front is the hotel development. We have some IT development, and there's corporate offices. There's a residential tower at the back of about 100 meters. And then we have a convention center, which is sitting right in the middle. Okay, so what this allowed us is now understanding the region and the context again. Now this is Kolkata, the eastern region. The prevailing wind directions out here are mostly north and south, so which allowed us to kind of create a central spine which is completely pedestrianized and allowed for us to gather that wind across the spine, which breaks the two buildings between the entire site. So this helped us in creating microclimate again at the site level. However, that spine gave us the opportunity to kind of celebrate the local culture of Bengal as well. So it was kind of spanning from each zone that you see out here is subdivided into different seasons of Kolkata. So what you see out here, the Grishma Drive, that is called the Bengali New Year. So from the New Year to the harvest to the rainy season, each particular zone is kind of celebrating that particular season, and how seamlessly that gets integrated into the facade and onto the functional aspect of the facade, which is the east and the west zones again, by blocking the harsh sun on those two particular facets. So that is the urban art facade that we have been talking about, that how the landscape seamlessly now gets converted into the facade. That, ladies and gentlemen, is the urban art facade of 1 lakh square feet across the entire master plan. So we had about 80 skilled craftsmen that we kind of got them on board to make this happen, and we just saw the side images as well of that. That's IDC. That's the knowledge center, the convention center that we are talking about. Because of the convention center and the hall over being there, and because it's a dead facade, and we wanted to again celebrate, the culture, or even the culture of Bengal or Kolkata for that matter, what we also did is all that screens that you see is a stone facade, which are scripts of Rabindranath Tagore. So when a person is driving or let's say walking past that particular building, he can also read those scripts as and when he walks around the building as well. Designing high-performance facades, that is through sustainability and optimization. This particular project that you guys, everyone sees out here, is that we're doing for the Malpani Group. We've been able to achieve about 100% daylight on every floor plate and thereby also minimizing. The one first challenge that we actually faced on that site, that the site was not north-south oriented, it was east-west oriented. However, so through I will come back to my first point that I was just about to mention. So sustainability and optimization. What exactly are we doing here? In sustainability, we are trying to reduce the energy performance index, which is the EPI of a building. What is EPI, guys? EPI is basically the amount of energy that a building is consuming. And how do we reduce that? By using passive design strategies or even through building orientation. So what we've been able to do is the baseline of the Bureau of Energy Efficiency, which is BEE, right? That is about 90 kilowatt hour per square meter per year. However, for this particular building, even though it's east-west oriented, the longer face of the building, we've been able to reduce the energy efficiency by 40%, and we are targeting a 60. Now, these values are targeted values, and we also have energy simulation reports supporting the same documents. Then we come to the MEP efficiency, which basically talks about the thermal comfort of the end user or the target user. Okay, whenever the person is occupying that particular building, what is it that we do and how can we actually reduce the cost or the capex of the conditioning or the air conditioning load? We all know out here, air conditioning load takes the maximum capex value of the building. So for this particular project, we have been able to, on a baseline, which is about 200 to 275, we've been able to increase the efficiency to about 450 square feet per ton on the overall design. Now, with the help of our very esteemed consultants, VKE, we've been able to kind of get this analysis on daylight and also thermal gain. So on daylight, we kind of had this to and fro exercise with our consultants, and we kind of reached to a conclusion. And that's how our flow plates were also eventually designed at. So if you see on the screen out here, there are multiple flow plates that you see, 60 by 60, 50 by 75, 40 by 95, 30 by 125, 17 by 120. So what we actually inferred from each of these, as and when we start making our flow plate thicker on a commercial building or a commercial office building, essentially the daylight penetration into that particular flow plate kind of starts reducing out. So how do we achieve 100% daylight, or let's say about a 90% daylight on a 330 lux, or I would say 100% daylight on a 110 lux. Okay, so this is what we did. Eventually, that's the reason when you see that floor plate, we have two grids planned at 8.5, 8.5 on either side, which allows for that daylight to come into the entire building across the year. The second criteria which helps us is sustainability. There are actually two of them, is one which I was just talking about, daylight. The second, which I'm going to talk about now, is the solar load. Now, this basically talks about the envelope load of the building. Now, this is where the high-performance skin starts coming into the picture, wherein when we do a DGU, and that's the baseline of IGBC, wherein you can do a 2.7. However, right now, this is 1.5 with an SHGC of 0.27, which if we start reducing the solar SHGC, everyone is solar heat gain coefficient. If we start reducing that SHGC and still maintain our U values, we are kind of allowing not for that heat to come in, rather get reflected out, which essentially reduces the envelope load of the building, which is from a 1.2 to a 0.8 watt per square feet. And how does that help us? That essentially now helps us in reducing the heating load of the building, which then kind of starts proportionally offsetting the cooling load as well. in terms of the building morphology, this is what we had done. The east and the west facades, you can see we had placed some shading devices, and that too in a very staggered format. The reason why we had done it is that at the east and the south, the solar angle is actually on the south heading towards the west, the solar angle is high. So what we did is we placed those staggers by reducing the overall length of the louver, but still having each face kind of, the sun rays kind of falling onto each of those faces. So we see two kind of skins out here. One, which is a 300 vertical fin that goes in along with the 450. Now the 450, when the solar angle is on the southern face, when it goes up, we see those deeper fins allow for that glare to cut in onto the glazing facade, or the glazed facade. Coming to the second aspect, now again, how does landscape, or how do we start making this additional buffer a part of our facade as well? On this particular project, we have these what you see, which is highlighted here, are the parking floors, everyone. And however, we've been able to kind of treat it with a breathable facade all around it, with multiple facets going in and out, creating double height spaces, so that when a person is actually coming into the building, for two aspects. The experience of that person at the parking level is that he's driving through a forest on the periphery. The second reason for that also is when we design buildings nowadays at all parking levels, let's say basements or podiums, there is a lot of emission that comes in. There's carbon dioxide, there's nitrogen oxide. A lot of these emissions start coming in. But who is talking about how do these emissions step out? Our plan, or Mr. Modi's plan, is to reach net zero and reduce the carbon footprint by 2070, right? So how do we do that? So this is where landscape actually starts playing a very crucial role, and this particular process is actually called psychoremediation. Okay, now what that does actually, it allows for these pollutants from the cars to get absorbed either through soil, or these plants then, kind of absorb that CO2 and release that oxygen. Allows for a breathable air within the complex itself, or rather the parking facade. So this is what we've been able to do out here across the entire periphery, across 4 floors. So this is how landscape, or as a green buffer, becomes a part of the facade. That, everyone, is the main entrance lobby. That is the entire facade that we have designed. We can see the east and the west. So now there was another one challenge that we faced on this project. The entire flow plate length was about 118 meters. So we had to kind of divide that out, create those horizontal shading devices across the periphery, vertical shading devices that we had done for the high solar angles. So that eventually how we came to a high performance facade for this particular project. Thank you, everyone. But I would end this particular presentation as a continuation to the project that I was just talking about. Can we please play the video? It's just to show you of what we had done for this particular project and what does it comprise of and what are the multiple facets of facade that went into it.
us through your entire process of design for your multiple projects and case studies. Well, next up is a presentation that we've all been waiting for. We have our local boy over here, our local Pune lad, Ritesh Jindal from Arup, who is, who's worked, he's the local Pune lad, but has worked, in many sort of international consultancies, worked in Singapore, and then currently he's leading the Arup team, the Arup Facade team in India. And he is a geometric genius, as what I call him, a parametric genius. And I give the mic to him to take us through his presentation today.
Thank you. Wow, the last slide is the first one. Wonderful. I'll just try to move the slides. Well, good morning, Pune. Thank you, Zach, World of Facades, for actually doing the first session in Pune. Being a Punekar myself, I'm glad to be part of this presentation today. Quickly jumping onto the company first. So Arup was founded by our founder, Sir Ove Nyquist Arup, and the company was founded in 1946. So our founder was himself a philosopher and engineer, and he basically started giving the first principles of total architecture back then, and in the firm we try to still live up to his values together. We finished about 78 years right now and still going on. In terms of our spread across globally, we are present in 34 countries, have 94 offices, and we have more than 18,000 plus professionals across. In India, we basically function under 4 different verticals. The first one basically is all the services that we offer from our Indian offices. The second vertical is basically a combination of Indian and offshore offices. The third one is services that completely comes from our overseas offices. And the fourth column is basically very specialist skills that we have within the firm that we give to our clients only on special request. Now in India, we have been present for more than 40 years, but our first office got established in Mumbai in 2008. We are currently present in Mumbai, Delhi, Bangalore, Hyderabad, and we have almost finalized a place in Pune. So that will be our first office in Pune. Proud to say that we have finished more than 200 plus projects. Globally, as a facade team, we are about 300 plus professionals, and the team is quite diverse, having backgrounds of engineers, architecture, building physicists, material specialists, geometry specialists. So this is a project very close to me. This is at Changi Airport. It's called the Jewel. And I was part of this project, resolving the whole domeless structure and resolving all the glasses and rationalizing the panel to actually fit in on the site. Quickly, some of the projects that we have worked on. So this is Bangalore Airport Terminal 1 extension, where we had offered multiple services, which included facade, MEP, baggage handling, etc. And on the Terminal 2, we offered MEP services. Everyone is aware of this one, Statue of Unity, world's tallest statue. And I mean, glad to be part of this project again, offering various services, facades, MEP, structures, seismic, wind, vertical transport. Recently finished up GeoWorld Center, a mega scale project having combinations of convention centers, exhibitions, retail, mall, and residentials as well. Mumbai's first drive-in theater, GeoWorld Drive, which also hosts the new Apple store right now at BKC. And people who have seen the movie 3 Idiots, the school that you see at the end of the movie is that Brooke White Local School. Proud to say that we are part of this project since a very long time. As we speak, there are actually 2 engineers still continuing to develop the school further. And we have won multiple awards for this project. In fact, the architecture also was done from Arup Associates London. So now, jumping quickly onto the topic. So the presentation is split into 2 parts. The first one will be talking about something that we do on very specialist skills on complex geometries. And the second part of the presentation is mainly the tools that we use, the automation tools that we use within our firm that we develop, which has helped us increase our efficiency and increasing the productivity of the whole services that we offer. Just wanted to show a trailer on the right. So this is something that we are currently developing within the firm. It's an optimization tool, actually going through various combinations using a brute force method. And you can see all the results getting plotted out within that graph. And you can input actually various parameters happening, and it creates basically different combinations, and you can choose the most optimized based on your different parameters. Now, talking about parameters, there is a very fundamental thing about a script is that whatever inputs you give in, is actually what you get out. I mean, if you put a garbage into a whole script, you will just basically be getting garbage out of it. So this project is a very classic project where we have actually defined the whole script in which we had defined a few parameters, and then it basically gives us various outputs from which we can make an informed decision about how the panels should go in. A museum project in India where a classic example of why facade consultants should come early on the board, because we had massing here, about 6 pyramids connecting by sky bridges and a tower at the end. But the architect was a little exploratory in terms of what materials do they want. They just came up with this nice concept and said, we need something earthy. And we said, oh, hold on. Let's go back. Let's analyze how are we going to actually define these whole panels, how this whole pyramid will actually look like at the end. So 4 parameters is where we started. The first one is the panel sizes that are available in the Indian market. The second one is how much are we utilizing these panels when we are actually cutting them into different shapes. The third one is the repetition that happens because it just makes the fabrication installation much easier. And the fourth one is, of course, the fabrication. We wanted to make it as easy as fabrication friendly. We started with quadrilaterals, squares, rectangles, diamonds, everything possible. But the challenge with these type of complex geometries is whenever you go with these kind of shapes, the edges where the two surfaces meet becomes quite crucial. And we were having lots of unique panels. Then we went around to triangle. We said, let's explore triangles. So we took various combinations. We took a square, cut it half into 2 triangles. We took a hexagon combination of 6, took again another rectangle square, cut it into 4 triangles, and see just how things explore. Plotted out in the whole geometry. And then finally came up with just 6 unique panels per pyramid. And that's the efficiency you get when you have the right algorithm running behind the whole scripting. The tower at the end also had like 3 different surfaces, which were inclined and 2 vertical ones. Again, 95% by just 3 panels and almost 90% by just 2 unique panels. A tool that has recently been quite coming up in the market is Speckle, and Arup has been part of the initial development of this tool. Now, why I'm calling it a tool is basically it's only a communication platform between different softwares. Being in the BIM world and working on different softwares, it's always has been challenge because there is always loss of data when we transmit from one platform to the other. And Speckle was an answer. So I'm just going to show a quick demo of how a Rhino model gets actually through the Speckle platform into a GSA software. So GSA is another structural software that comes under a brand called Oasis, which is owned by Arup. Arup has a software division itself where we develop softwares and then sell it out to the clients. So either use GSA or the most popular software called ETABS. And quickly jumping onto this video where it shows a tower getting all its center line exported through a script. You just run a few clicks, and it basically throws all the data back into this Speckle tool. So once the Speckle tool comes up, it basically imports all the data from your Rhino model, and then you can export all of this data back into GSA or ETABS or whichever structural software that you use. Once it comes into ETABS as a structural center line model, you can basically run your structural analysis, and now the two are connected. So one side you have your Rhino, SketchUp, Revit model. The other side, you have your structural model, and they are now talking to each other through this platform called Speckle. We have used this extensively on this HS2 interchange station in UK, where you can see so many different disciplines that Arup was actually working around. Just using Speckle, we could communicate between different offices. So we had people sitting in Hong Kong, in India, in UK, in America is also supporting us on this job. So coming to digitalization, we have kind of identified the various tools that we can produce and that can help increase our productivity, some of which will be shown as part of this presentation. And we're just creating this whole life cycle where we want to support our clients throughout the complete life cycle of the project and not just during the design phase. Now, a very interesting thing about digitalization and data. So earlier in the presentation of Ashwani, we kind of made it very interactive where we were putting all the data in. And you know, it's so critical to actually make sense of the data because data is everywhere. We are just surrounded by so much of discrete facts. But it only becomes something useful, something like an information when all these data come together. Once you have this information gathered up for a certain period of time, that becomes your knowledge, and how you use your knowledge is basically your wisdom. So for data, it's very critical how you manage them, how you use them. And I think great example again shown by Ashwani earlier as to how people think facade varies differently. Yeah, for each one of them in a different eye, and then we collate all the data and we see how can we make sense of it. So 4 tools today. Last time I'd shown 5, but I got feedback that it was a little faster, so I thought maybe I'll reduce one of them this time and only go with 4. The first one, we developed something so we could explore more possibilities when we are actually in the concept stage of a project. Now what this facade canvas is, so the word canvas is coming in from a canvas board which has infinite possibilities. You can draw whatever you need. And I've shown multiple versions of this, but this is the most advanced version that we have recently created for a project in Mumbai. So what the script is doing, firstly, is it has all these parameters on the left and the 3D model running on the right. Now you can change your floor-to-floor slabs, you can change your mullion depths, widths, the setting out, the differences in actually your slabs. And one important thing that we did for this particular project is we integrated the angles as well. And as soon as you put all these combinations into this structure, you basically just run that C# script, and it tells you how your facade is going to behave once your structural loads and deflection starts to come to play. Now, very unique way of actually using digital tools is we were sitting in a room with the structural engineer, the client, the architect, and us together, and we were trying to figure out what is that L by distance between the columns that we require to actually design the structure. And we were doing these permutations, combinations for this project. And we could come out with the result in like half an hour or so. The second one is Arup Solar. Again, something that was shown in the earlier presentation at Morphogenesis. So this is a tool, again, we made to cater down some of the principles of solar and how solar affects our facade. We'll go with the project example of Google headquarters in London. Similar challenges of the longest elevation facing east and west. And what this tool is doing is basically telling you when do you actually need your shades up or down, at what time of the year, what day, what hour, with what G value do you have on the ground. So this was the fundamental challenge of this project, and then the idea was to actually resolve this. And the first idea we came up with is why don't we use the facade to actually shadow each other, and we came out with a shingle idea in modules of 9 meters. So you see these 4 options where we have 9-meter modules into different combinations. And then we started plotting them back into the whole 3D model. So this whole Arup Solar tool, again, tells us which of the splits are workable into the whole of facade. And then when we were discussing, there was this interesting point with the architect. And then they said, okay, why don't we use combinations of each one of them? So what we did is, at the end of the project, we gave this whole tool to the architect, and we said, okay, you play around with it, you manage what combinations do you need, and the tool will tell you whether it works or not. And that's how the whole elevation of this Google headquarters came into play. This is just a work in progress construction photo of the project. The third tool, okay. So something that gets quite ignored in the Indian market is actually the maintenance. And this tool is basically just going to flash some of the ideas that we have used for maintaining our building or designing the maintenance strategies. So what is the traditional way of doing maintenance strategy? We usually get like SketchUp models or 3D models from the client, the plan sections, and we try to cut down each and see whether our maintenance system is working or not, where the parking spaces are. But what happens in case of complex projects is it becomes challenging as this. So what we did is we created a lot of families. We did a whole market research with all the suppliers sitting. And then, we created all these different libraries, which systems are there in the market, and we uploaded all of them into our Revit template. And then we resolved this whole GeoWorld Centers maintenance strategy in just this one diagram, in just one 3D that you see. So all the various systems, you can just imagine the complexities happening in the different colors of this huge mega project. Not only that, since I told you earlier that we have a software development team within Arup, we have created smaller tools which increase our productivity every now and then. So once this whole maintenance strategy was designed, just with a few click of buttons, we could convert them into a proper sheet with all the templates coming in depending upon which project you're working on. And then just again, by another few clicks, you can actually export the whole set into a proper document that can be submitted to our clients. So just a matter of fact that once you've designed it, click a few buttons, go get a grab a coffee, and then all your documentation is already done in a few clicks. Now, the biggest advantage of such kind of tools is I can cut sections anywhere. So I know that my whole geometry, my whole building is actually resolved, and each area has been taken care of across the whole thing. So what do we gain? Increase in productivity, increase in efficiency, change becomes easy. You know, we are in a world where the client keeps changing some of the items to either make it more nice or either make it more economical, so depending upon the project requirements. So once a change comes in, you just have to replace your links in Revit, run a clash detection, and you know which areas there are problems with the systems happening. There's, of course, overall time saving, man hours are reducing, and you have lots of documentation. You tell me where to cut a section, I'll cut it, and I'll tell you which system is actually applicable and which is working or not. So that's the efficiency. Now, again, I'm coming back to data again, because we had this huge, massive data that we had in this platform, and said, okay, why don't we use this and start making more sense of it? And then we knew, okay, this system, this elevation, these many hours, okay, if I probably hire a person or rent a machine, it's going to take this much of hours, this much of cost. Whereas, if I actually want to buy a machine, this might be my cost. So we created an Excel sheet, used a Dynamo script to extract the areas, plotted back into the Excel sheet, and now the client has a better informed decision-making process where he knows whether rental is going to work or actually purchasing the machine is going to work. The last one, okay, very interesting, okay. I'll probably start with smaller bits of it because it's actually quite a big process that we have developed eventually. So the first part is about inspections. What we usually used to do previously in inspections is we used to just go on site, take some drawings, study them beforehand, take a pen and paper and start marking them on site itself. And then we converted the whole thing into a digital platform. Now this is purely just using your iPad. You upload all your model and you start inputting the data. An example of a project that we have used this tool quite massively. So what this tool is basically doing is at each of these facade elevation points, you can go and create a data point for yourself. Yeah? And you can also do an assessment when you're actually on site. You don't have to grab like all these drawings and the whole butter sheet sets and everything. Just take this iPad, start clicking photographs, start entering data. And the whole data is actually placed into one. The best part about this is you can filter the data. You can see which ones are more critical elements where you want to focus first and then following on the rest of them. Now, once we had all of this data in place, again, not all are tech savvy, you know, especially on sites where we have laborers and everyone working together. So our clients requested, you know, why don't we create reports, traditional reports? And we said, okay, we have data. What do? We export everything into a CSV file. So this is just an InDesign template, which we have just created a base of it. And we've created a C# script, which basically reads all that data from your previously iPad, your inspection done in iPad. And then whole thing is plotted just in a few seconds right in front of you. So this is just data structured and then reformatted into a more report and presentable format. And then again, in a few clicks, your report is ready to be shared with the client. Now, we had inspections. We had this thing, automated reporting. So one day after the inspection, I was just sitting with my boss, and we were having a sip of coffee. And then we were just uploading some photographs, and suddenly, in the Facebook portal, it just popped out, oh, is this Paul? And I said, interesting. Why don't we do that with defects? And then the whole idea of actually automating the process and defining those defects came into picture. And we started thinking about, why don't we use drones? Use drones, take pictures. It can be done much faster. It can be done much more efficiently. And then we just try and use this data, create an AI actually running behind to develop the whole algorithm. So the whole process, the drone basically just goes onto the site using a flight path, starts taking picture, collects a lot of data, puts the data back into this defect analysis algorithm, and then the whole data, the AI database basically runs each of these individual images, and then gives you an exported model and plots that defect into a 3D platform. So this 3D platform is again something that you can actually create using your own Revit files. So what we have done is, the previous inspection tool, we integrated that into the process itself. So your Revit or 3D model gets converted into that Unity space. You get all your data, again, mapping back to this 3D space and to defects. And then we, again, do like a physical inspection after that. So once your inspection is repaired or anything that happens on site, the guy just goes, checks, done, takes a photograph, again, records the data point that it's done. And then that gets reported into an automated report procedure, and then gets you the final report, final output. Now, let me just put some light on how this whole defect algorithm works, okay? So we have all of these photos which comes into the cloud database, and then this whole data is getting read in a very different way. The reason for this is the drone is actually taking a photograph which is 5 meters away from your building. Yeah, so these are like huge images, which gets quite difficult. So what we had done is basically we'd split this images, each of these images into like 250 sub-photos. So this is a project in Singapore that we had tried the first time about this defect algorithm. And then each of these becomes like a smaller photographs, smaller pixels, like sub-photos. And the defect algorithm just runs behind it and tries to identify what are these data points which actually creates those defects within this whole space. And then if you zoom out, again, the same image repeats itself, and it tells you within the 3D platform, okay, there is a defect here that you need to take care of. We use this application in one of the projects, UOB Alexandra in Singapore again, and just the output of it shown as to how the actual data comes out as a result. So, I mean, that's basically the 4 tools that I had earlier planned to share with all of you guys. And just wanted to share something, about digitalization and how it helps is, as part of Arup, we have this global platform where we share each other information to make ourselves better every day. There's a lot of research fund, there's lots of research that goes into it. Arup being a private company, we have our own decision-making power where we keep investing our research. And this is just one short example of how many tools we have within just in our internal Arup portal. That's 2,256 tools. And in fact, we have filtered these tools to make it just easier for our own people to use them. So on the left, you see the different disciplines. On the middle one, you see the applications of these tools. And on the right is actually basically those tools. So no matter whether you belong to electrical team, no matter you belong to a mechanical team, a structural team, or a facade team for that matter, you can just tick on a few buttons. You know which tools are already there within the system. And just by clicking the function that you want, you can basically go to that Python script or that tool or the Revit extended tool, whichever it is. Yeah, so that's basically the summary. Like our founder said, we shape a better world, and again, we are trying to live up to his expectations till today. Following sustainability, we have stopped printing cards. So that's my contact information in that barcode. You can scan and store my information, or you can drop us an email on afe.india. It's arupfasadeengineering.india@arup.com. Thank you. That's all for today.
Ritesh, excellent presentation. So ladies and gentlemen, I think that's time for our break right now. And, Srinivas is there right next. Sorry. We have Mr. Srinivas Narayan from SideRise, who's going to talk to you about fire safety and the SideRise products, which is very, very interesting in today's day and age. And he's going to show you some very interesting visuals and different test parameters regarding SideRise. Srinivas.
I think Rohan was trying to send people away from my presentation. I'm going to ask Ritesh if for the... Oh, it's behind your secret book. Yeah. Okay. Ritesh, fantastic presentation. We shape future. I think one of my favorite projects is what you showed is the Google headquarters. We had the opportunity to work with Arup, and it's the largest timber building in London. And Arup really made a tough life out of us to do some project-specific testing because it had timber floors and lots of timber in it and how it works as an interface with the facade. So while we get this sorted, as Rohan said, the presentation is going to focus in relation to facades, compartmentation in facades, something that I'm very proud that the Indian standards have come out with, the Bureau of Indian Standard have come out with a regulation, and that's something that I'm going to share today. They have sorted it out, but it has to come on the screen. It's coming on the screen. Yeah, thank you. So I'm 1 minute, 30 seconds down already, okay? I just wanted to put this slide from NBS. It's just to give how the life cycle and the stakeholders involved and important phases which are involved for us in a project. We start with the discovery of the project where the client comes and says, we go into design, specification, construction. But all these 4 stages or 5 stages is very important for the 5th point where in end use, when there is an occupant who is coming into a building, he needs to have a safer place. He needs to feel like home. He needs to spend, he or she is going to be spending around 8 to 10 hours a day working. So it has to be as good as we can do it and as long as as safer and as sustainable we can build it. So one of the challenges we are having in the industry is, or we were having in the industry is, people were saying, oh, Srini, I have a sprinkler in my building and I do not need any passive fire protection because the sprinkler will work. Or people have always said, oh, there is no cost, it's expensive. And the last thing which I've also heard is people have said, Srini, I have always done it this way and I don't want to change. But the cost of when there is an incident or a fire reported, it's very big. And the cost of implementing safer buildings or strategies for future buildings is very negligible cost. And if you do it right the first time, it's going to be easy. 2 terminologies which again I wanted to share with us as an industry. We keep hearing the word fire rated. There is nothing as fire rated. You have only 2 terminologies, reaction to fire and resistance to fire. Reaction is very simple, how a product would react when it comes in contact with fire or exposed to fire. Or resistance to fire is basically how a system stops fire and smoke moving from if there is a fire, how does it protect fire not moving from the exposed area to a non-exposed area, as simple as that. So an example that I've shown here is a wood crib. When you put it or when you light it, it's going to catch fire. When you remove it from the fire, it can still continue to burn. But the same wood can be used as a fire-rated door. So when you go into that, as a door, it's a system. It's not only the door or the wood, it's the accessories that you use with that. So it works as a system. So that's very important. It's always a system approach and not a product-specific approach. What we use in an industry for compartmentation is stone wool. There are 5 different reasons that I've identified here why stone wool is best. We also hear about terminologies like glass mineral wool also. Glass is basically melted glass, which is made into fibers. Stone is melted stone made into fibers. So you get a good water repellency, noise controls. It's good with fire because the melting temperature is very, very, very high. Thermal and environmentally, it is very good. So stone wool has a very good property for when it comes to fire. So what we are going to speak is the compartmentation in curtain walls, the interface between the floor slab and the external facades. So how does a fire spread? So you have a fire which starts the spread of fire through the internal interface between the floor slab and the facade is the first area where a fire would spread. But importantly, when your vision glass breaks, there is chance for fire to come back inside. And the terminology used for that is something called as leapfrog effect. So a fire can break a vision glass and come back inside. So that is why that spandrel panel plays an important role. We all are aware of the National Building Code that we use on how we construct a building. We use it as a guide. The 2016 NBC has given clear directions in how we test a product or what we have to use the product for. So you have the 2016 version which says that you need to use a compartmentation and you have to test it to an ISO standard. But what is changing is we have been tested. The 2016 says that we need to test our products between 2 concrete floor slabs, but that is not how we install it on projects, right? You need a curtain wall and you have a curtain wall and you have a non-fire rated curtain wall. So now what the Bureau of Indian Standards has done I'm sorry. Yeah. So what the Bureau of Indian Standards has done is they have come out with a new standard called as IS 18190. And this particular standard was released in June, July last year, 2023. And it's not yet incorporated into the National Building Code, but that is the direction in which the market is going. It will be soon incorporated into the National Building Code. What the standard says is you need to now test it as a system. You need to test as how you're going to use it on the project, how you're going to install it on the project. So that is how you need to test it. And it is an adaptation of an ASTM standard. But BIS has gone a step ahead of other countries. What they have said is we don't want the products to be tested for fire, but we want to condition the product for various movement that a building can go through during the life cycle of the building. And then once the product is exposed to those kind of condition, you then do a fire test. So now it is important for us to do a cycling on the product where we need to make sure that we condition the product, say, for seismic movement and then do a test. So this is how the standard. So you need to cycle the product. You need to move the product. You need to move it at 30 cycles per minute for 400 cycles and 10 cycles per minute. There are different requirements that are there within the the standard, which is the IS 18190 standard itself, and then do a fire test on the product. So this has gone a step ahead of other countries. So they have moved, instead of moving 10 steps, they have moved 20, 30 steps ahead of other countries. This is how a test would be done. This is an equivalent test of ASTM E2307, but there is only one lab which is now being accredited to do the test. So it was accredited only earlier last month. So we will see lots of manufacturers now booking the test and doing the test before it becomes a standard. So the beauty of the test is, again, you install a full curtain wall and you test the spandrel and the interface. So this is an image inside the furnace of looking at a specimen of installed. You can see that a mullion is exposed here. So now with this particular condition of the test, you need to protect the mullions. You cannot expose those mullions to fire anymore because they would deform or they would lose its integrity at a very low temperature. So it's very important that we take care of the mullion. So how do we do it? We protect the mullion from being exposed to heat or fire. This is an image after the fire where we have removed the mullion protection, and you can see the insulation is still intact. While we were developing this, we also understood that there is an opportunity to improve a few installation guides for the spandrel insulation. So we have introduced a cup weld system. So you don't have to use, we have introduced a way that you do not have to use any glue or any kind of sealants to put a pin. It's just a weld pin that will hold the insulation in place. So it's around 50% faster than a conventional unitized system where you put it on the line to install a spandrel insulation. So that is something that we have introduced. An image of how the test is conducted, where you have a fire on the inside and outside, where we spoke about the leapfrog effect. So this stimulates and tests the product for leapfrog. So a system approach is very important. We have to now look at how to protect the mullions, what should be the spandrel height, how is the spandrel performing, and how are we protecting it. So then we go into the listings and third-party verification, UL, Intertek, etc. Currently, I've been showing you an ASTM E2307. I just wanted to clarify that an ASTM E2307 is not an IS 18190. So we cannot substitute that. We have to test to an IS 18190, and though the test methodology may be same, but the standards are different. So we need, a manufacturer will have to test for an IS standard instead of, and produce the documents. Zero spandrels will become a challenge now because there is no route on how you can test these products in the condition which is IS 18190. So zero spandrels are going to be very tough to pass these kind of tests. So as we all know, there are lots of systems in the market. All systems are tested. All systems have their movement and are compliant to installation. But the biggest challenge that we see in the industry is replacement of the components that are tested. So that's become an issue with an IS1, with the new standard that Bureau of Indian Standard has come out. We cannot replace products. It has to be tested as a system, and the same products have to be used on the projects. We have spoken so much about the perimeter barrier. Compliance is very important. Using it as a system is very important. So this is what happens, right? So when there is a fire, when you have a zero spandrel, the fire, once it starts developing, this is where you expect the sprinkler to activate, cool down the build, start the cooling down process, but then the vision glass breaks, and the fire has already breached that compartmentation line. So a spandrel panel would protect that leapfrog. So it will keep the spandrel in place. Once the vision glass breaks, you have that arch in which the fire goes where it will not come back inside. So you avoid the leapfrog, and the spandrel panel will keep your perimeter barrier in place for the 2 hours. That is what the standard which has developed the IS 18190 has now done. An image, when we are in Pune, we have to use one of the products from the Pune market. Tata has come out and they have launched their 5-star ratings, one of the first one. So when we all are going and buying a car, right, we see what is the best because we put our family in the car. We expect that to be the best and the safest one. So currently in the market, what we are doing is replacement of products. So if a car is crash tested, and if you change one component of the chassis, even a screw from the chassis, for example, the test doesn't be valid. You have to redo it, and you will not get the same rating. So if you are going to buy a car, and if the manufacturer says that you can change, I'll give you a lesser, change the component and give it to you at a lesser price, would we still buy it? So why do we do it on projects today? Why do we have to change components which is tested? And why do we have to replace it with something that is not tested? So I think we all collectively have to see how better we can build keep a future safe, the building safe. The time is ticking, but one of the other components is the cavity barriers, which is picking up pace. Bureau of Indian Standards is working on the next standard, which is basically to provide compartmentation in cladding, which is the next step the direct facade market is going to go. So we have seen so many fires where the fires have spread across the buildings very fast to the full height. So where we have used aluminum composites, solid aluminums, high pressure laminates, so there is a cavity behind, and that is the passage in which your fire will spread. So introducing a cavity barrier which stops the spread of fire within the cavity is very important. So what you see here is you will have the rain screen performance, but as soon as you have a fire, the cavity barrier would engage and close the gap. I'm not saying this will stop the fire from spreading. I'm saying that this will give you time, and it will reduce the time in which the fire is spreading to the full height of the building. Again, there are standards which is available, international standards, but IS standard is going to come for this particular configurations also. People think when we use stone, we don't need to use any compartmentation. This is the same product that is used with the cavity barrier and without a cavity barrier. You can see with the cavity barrier, even the first tile is still intact. But without a cavity barrier, because the system that is holding your stone is aluminum, and as soon as it's exposed to heat, it's going to lose its integrity and the tiles is going to fall. So as SideRise, I have my colleagues here who are out there. You can speak to them during the break. So we were the first one to develop a dry fit system for perimeter barrier. We have introduced a ventilated cavity barrier. We have used tools like what Ritesh have been saying for giving visibility to the owners of the building to say the product has been installed. Importantly, we have started to introduce QR codes. You scan the QR code, it will tell you when the product was manufactured, who QC'd it, what is the application, what is the test standard, how you install it, everything will come on the QR code. Last, again, digital tools is something that is very important. We are starting to introduce VR, AR technologies. So probably one day, within this year or next year, you will be able to scan a catalog from SideRise and picture how the facade is going to look, or how the compartmentation is going to look, how the spandrel is going to look. So it's going to give more visual approach and understanding for architects and consultants. So as a SideRise, we adopt the Go Beyond theme. So we have to go beyond the products, go beyond the testings and make sure we install what we have tested, go beyond the technical supports and make sure we do our inspections, and finally go beyond the product. And we have to look at it as how we would build our own home and make sure we build a safer future. Thank you.
Thank you, Srinivas, for that excellent presentation, and apologies once again. So now it is actually time for our break, but we have about 15 to 20 minutes for our break. So if you can all please come back here by, say, 11:30, by say 11:30, 11:35, that would be great. And if everyone can proceed for a coffee break, and we can get the speakers to stay back. So welcome back, ladies and gentlemen. We, on this side of the break, we're beginning our second session of the day. And to kickstart that, we have our keynote speaker, a facade consultant who I've worked with very closely over the past 15 years from my younger days and his younger days. When he was working with a different consultancy at the time, and we've both grown as individuals since then in knowledge and other experiences. But Gautam Bhasin is here to talk about bringing the craft back, and going to talk about various elements in his journey. He's an architect by education and a certain amount of practice, and then moved on to become a facade consultant, worked in Singapore for a consultancy, and then moved to Hong Kong, and now he's back here in India, leading Inhabit. Gautam Bhasin, everyone.
Hello. Thank you, Rohan. Generous introduction there. I am not sure what you were referring to when you said we'll be growing in other things as well. But yeah, I think it's good to see the audience and a lot of familiar faces. Congratulations, Zach, for the inaugural event, Zakisa. Amazing turnout, amazing presence. I think it only reinforces your brand presence and the brand value that Zach has. I will start with a shameless marketing plug. I think a lot of people know about us. For those who don't, we are facade consultants. What we like to call ourselves is architectural engineering consultants. We just don't do facades. We do facades, we do BMU, lighting, sight and sound, which is acoustics, audiovisual. We also deal a lot in transformative modeling, which is to do with computational design, BIM, and we also deal with diagnostic services, which is trying to see how your existing buildings are faring and what can be done to actually make them outlive their planned design life. We are present across 21 offices with about 400 people purely doing facades. In India, we are placed in Mumbai, that's our primary design office, and a satellite office in Bangalore that caters to that part of the region. From talls to super talls to not so tall but still very interesting projects, museums, galleries, opera houses, etc. We've done it all. Pune has a very special place, almost a place of pride in our portfolio. We have close to 14 ongoing, completed, or sort of under construction projects. That's ABL Boulevard. I see our client in the audience here. Polo Roche Business Avenue in Viman Nagar, Amar Tech Center in Viman Nagar in Panchsheel Wakad. That's nearing completion now. Potentially should be handed over in about another month or so. A lot of projects being nurtured on the drawing board or about to start construction. A lot of clients, a lot of collaborators, architects who've trusted us with the solutions are sitting in the audience, and it's really good to see them. Now, what I'm here to talk about is, we have a lineup of stellar speakers, people who will talk about curtain wall solutions, architecture, etc. But I'm here to talk about something slightly different of what architecture looks like today, and how have we evolved from the way we used to build and the way we are building now. And it all started with a question about a year ago where a colleague in France actually asked me a question. I was a tourist in the city for a day, and he said, which part of France would you like to see? And almost instantaneously, while being self-aware that I do curtain walls for a living, I said, I want to see the old Parisian Quarter. I want to go to the old city, Arc de Triomphe, not like, your La Défense and those fancy curtain wall buildings. And that sort of came from a very conscious part of your head where you want to see finesse in buildings. You want to see a little bit of craftsmanship. You want to see a little bit of love and care that goes into buildings. What has happened over the years is that buildings have become more functional, more efficient. We try and make them as quickly as possible, as efficiently as possible. And then I think being ornate or being gilded is almost like, this wasteful feature. We don't like decorative elements in our building anymore. But if we sort of deep dive and ask ourselves, I think we like having a little bit of human scale into our buildings, whether it comes to details, it comes to materiality, textures, so on and so forth. So from being crafted, we've become almost a manufactured architectural industry where everything comes from a factory. I'm not denying that it's not the right approach. It is the best approach to make sure you build to cater to the industry, you cater to the needs of the users. But I think somewhere the craft has gotten lost. I will be getting a little bit architectural in my approach to the presentation today, so pardon me for that. I have 3 projects which are recently completed, which I will talk about, where we started bringing a little bit of craft back into the manufactured approach. So we still looked at factory finished materials, manufactured materials, trying to maximize modularity, trying to maximize pre-engineered approach to a building facade, but we ended with some level of craftsmanship brought back to those buildings. The first project, which draws its inspiration from the Yellow Mountains of China, it's called the Thousand Trees. We collaborated with Thomas Heatherwick, Heatherwick Studio in London. And the entire building was designed with an inspiration taken from the Huashan, which is the Yellow Mountains. And it's not just the geometry of the building that was formed like a mountain, but the building actually looks like a mountain with tiny trees perched upon each of the columns. Building is quite interesting. It takes care of sustainability, it takes care of orientation, thermal gains in many ways. The left-hand side is north-facing. The right-hand side is south-facing. So obviously, anywhere in the northern hemisphere, you know that, and we saw that in Abhishek's presentation, that anything that's south is bad from a solar axis perspective. So you try and get more light, more indirect light from northern orientation. You try and create more open spaces which are northern orientation, so you can actually utilize them better. So the idea was to actually create more terracing on the north of the building and try and keep the facade relatively straight moving south. What was very interesting is instead of just providing planters with tiny bit of plants and shrubs to create some greenery on the facade, the architect decided, why don't we actually bring semi-mature mountain trees from China and then plug each of them on top of the columns, which is the ideal place to put a tree because it's heavy load, soil, everything else that sort of comes down axially onto the building. So the image on the left is the north-facing facade, lots of terracing, greenery, glass, which allows usable daylight to come in, but also creates spaces for people to spill out into. And the image on the right is a south facade. Now, obviously, you can't have all glass or you can't have all dead facade. This was almost an exercise in community building where they invited local artists to start collaborating with them and give them one little frame depending on the kind of artwork they have. And that becomes a public interface on the south side where people look at the building as a large art exhibition. One very clever trick, which was to actually pull the columns out. So this is almost an exercise in an exoskeleton design where the columns are pulled out. The beams still stay connected, and what you have, typically the approach is that you try and hide the columns of the facade. So the columns and structural grid are in line, and then you wrap the whole thing in a facade system or a facade element. But in this case, the columns were pulled out. Originally, the plan was to actually have phosphor bronze cladding onto the columns, but given the columns had a certain structural size, the architect said, let's just drop the cladding by itself and let's have off-form concrete. The rest of the facade has stone, which is exactly the same stone, it just has different surface finishes that gives it that subtle color variation. And what you see as this element here, that's a phosphor bronze element that was left from the cladding, original cladding proposal. That is not just a fancy element on the building, it actually carries all your electrical services going through on the facade as well, which covers all of your lighting, whether it's lightning arresters, etc. All systems get integrated within that. So devoid of a facade, it had to be made interesting. So special formworks were designed to actually arrive at this sort of column geometry. And it was all tested in a mock-up, and the building is up. It's a public building, so anytime you're in Shanghai, it's on Mongshan Road, and it has a large public interface for even somebody who doesn't want to step into the mall can get there and enjoy it. I have these images at the beginning, and this is where the inspiration came from. The second project is More Closer Home. This is in Mumbai. It's called the Morena House. And the architect we worked with almost described the building as a vase sort of gently sitting on a table. And it had to have that sort of fragile ceramic quality. Not that the cladding should break or anything, but then it should have that sort of soft quality about it that sort of screams residential pretty much. So the building is on a triangular plot with a slightly curved hypotenuse. So again, there are challenges. So in essence, your building footprint after leaving the setbacks would be a triangle. But then to make it interesting, there are these fingertips or toes, as you call them, to create balcony spaces, to create views, or to create rooms which necessarily just don't have one corner, but it almost projects out. Images on the right show what a standard extrusion would look like, but to give it more like a vase-like beauty, it was tapered down. So the lowest floor, which is the amenity 0 on top of the podium, has the shortest footprint that also allows you to have more outdoor spaces. And then it gradually grows upwards, where it flares out to actually generate more real estate, more space for the developer. What's interesting is that these buildings are now coming up in these older neighborhoods of Mumbai. Which I think in a way is a tragedy, but if we approach it sensibly, architecturally, they almost become off the place. This is Carmichael Road, somewhere from the early 1800s. And you see the building on the left has these tin awnings or chhajjas, which I think almost evolved over the years, where we now start putting concrete chhajjas. Ki haan, pani aayega, the building will leak or window will leak, let's put a chhajja. I think these elements were more, I think, sensitively architecturally integrated into the building back then. We obviously didn't want to copy it, making it look like a cheesy, pulled off solution from an old colonial building. So we started looking at how do you actually integrate a window into a much larger narrative of the design. A window can be a punched in solution into a wall, and then you do your cladding, and then you do some kind of trim around it, which becomes your coping, which becomes your interface between the cladding and the window. In this case, the chhajja or the awning was a part of the window system, so the entire system had a subsill, which has the projection, which is where your cladding comes and rests, comes and sits. And this chhajja had all of its framework built into it that sort of sat within the window picture frame, including cladding integration as well. Both these jobs were executed separately. I think Shyam and his team at Shuko did a stellar job supporting us on this project, developing this system, which is quite unique for a window systems manufacturer to get into. We started looking at scale, did some test models of what the interlock interface would look like. So the image on the right actually starts from the outside on the left to inside on the right. So you have a terracotta component, a cladding component on the outside with a nosing that covers it, followed by the window with a subsill and the railing on the internal upstand. So all sort of nicely integrated with all corners, with no visible masonry or concrete anywhere. Now coming to cladding, the architect had this intent where I don't want to have flat panels. I want to create some surface relief where there is a little bit of movement in the facade itself, and it's not just standard flat panels with color variations, etc. So the initial concept was to start with sinusoidal curves, which have the sinusoidal geometry, consistent cross-section, pulled across in a height. The only choices you have, you can't actually do thermoforming because it turns out to be very expensive. You can't do bending at that scale, at that finer scale. It becomes technically infeasible and also expensive. So the only options we were left with is that we look at extruded materials that have a standard cross section, and then you push them through a die, and then that's the kind of profile you get. Or you create a cast material. You can explore GFRC or materials which allow you to mold it to any shape. That sort of discovery and then going back to the vase narrative that the architect had took us to Yixing. It's a town or a pottery town about 400 kilometers west of Shanghai, where they still use these old 400 odd years old baking techniques or kilning techniques. And because of the availability of very special kind of clay there, we use that as a reference point for us to generate materials. That's one of the only places where you get white clay. Typically, when you talk about terracotta, the first thing that comes to mind is sort of brown and earthy colors, but you can only glaze over it. But in this case, we had a body color which was much lighter, and that sort of tied in with the design narrative. And this is where I think this is like a candy store for architects. So they literally went to the factory and they loved the idea and loved the possibilities, sat there for a couple of days, refined the profiles, refined the sinusoidal curves, looked at all the different finish possibilities that could be explored. And the final finish quality, again, going back to the vase narrative, we were all taking a stroll around town and we looked at a couple of these vase makers, and they had this sort of crackled glaze geometry. And the beauty of the building is it starts unfolding itself when you are afar. You look at it like a beige building with windows in it. You come further closer, you start seeing the finer details, the corrugation and the sinusoidal curves. When you are really up close, as close as that, you start realizing that there is more beauty in it. And then started the color tests, number of panels, mock-ups, etc., which sort of brought us down to finalizing a tonality, finalizing the texture. The image on the right with the vertical fluted panels is what happened in the vision areas, the one which are hammer tone. So when you're extruding it and the clay is still wet, you press it, that generates a sort of ripple kind of texture. That went on the clad bands between the windows. And that's the finished project. I think the client's pretty pleased. We all are, honestly. And the image on the right is a CGI. The image on the left is the final build product. And I think the final build product does a lot of justice to the architectural vision. The last project I have, and again, the upfront, the opening images are sort of where the inspiration came from. This is again with Hedevig Studio in Shanghai. This building completed last year. And the inspiration came from these moon bridges, which are built over canals in China. China has a system of canals where water is pulled in for agriculture, but then you need a way to cross it. You can do a very standard bridge, or you can sort of exemplify the bridge architecturally and then start creating these arches, which when lit in the night, create a half moon or like a crescent, which is where the name Moon Bridges comes from. The intent or the commission from Hong Kong Land was to actually create exhibition spaces. And the idea came that why just have an exhibition space there? Why can we not make the exhibition space access more publicly, generate and create interest? So the idea was to take a moon bridge and create like a three-dimensional labyrinth around it, almost these ribbons intercrossing. Everything that you see on the outside is publicly accessible. No tickets, no screening, nothing. When you walk up, it sort of generates that interest where people are peeping inside without bothering anyone what's happening on the inside, but then they start generating interest in attracting more crowd. That's the project in its finishing stages. Two of the elements, which is what the project is all about, one is glass. And one of the deliberate departures from doing segmentation was that it starts having some really odd reflections, instead providing a sawtooth geometry, which sort of creates a zigzag effect. And where we helped was that each mullion is a two-face mullion. So you can actually capture glass on the outside, plus capture glass on the inside. So you're literally creating a third face, which is by the mullion itself. So the mullion just doesn't have a structural interface. It also becomes a part of the facade, the visible element, which also deals with the weather. What also happens that's very interesting, during the day, the glass tends to be reflective, however clear you choose it to be. In the evenings, the lights come on in the night, and then you see there is some kind of marriage between the interiors approach and the exterior facade. And then you start seeing this sort of layering, which is very, really interestingly well lit. When it came to cladding materials, each of those ribbons that goes up is a 7-component cladding element. Started with GFRC because every element is not just consistent in its cross section, it actually tapers down very, very, very gently. But then that starts creating issues that you can't actually use an extruded material, you have to cast it. Now, this is where the genius comes into play, where you start talking about a building being touch and feel, where you go up close to it, you start realizing that there's a little more to that architecture. So this uses shells from the Shanghai River and the river wash pebbles for the first 12 millimeters of the GFRC. So GFRC is actually a bit thicker than what it usually is. And then that was integrated into this sort of terrazzo mix. And because of shells being used, you have that sort of depth when you're seeing it up close from a foot away almost. And that's the way the building is designed to be interacted with. That's the cladding material going up on site installed steel framework. The 2 images on the right, the image above is a render, the image below is the building actually under construction. I would like to close it. I mean, I don't have any QR codes, unfortunately, on my presentation. I'd like to close it with a short AV, which actually captures the essence of this project.
To bring me back to life. I told the world one day I would pay it back. Say it on tape and let it record it so that one day I can play it back. I don't even know if I believe it when I'm saying that. I'm starting to creep in every day. It's just so gray and black. Oh, I just need a ray of that. Cause no one sees my vision when I play it for them. They just say it's whack. But they don't know what dope is. And I don't know if I was awake or asleep when I wrote this. All I know is you came to me when I was at my lowest. You picked me up, bring life to me. I owe my life to you for the life of me. I don't see why you don't see like I do. But it just dawned on me, you lost the sun. Demons fighting you, it's dark. Let me turn on the lights and brighten it, enlighten you. I don't think you realize what you mean to me. Not the slightest clue. It's me and you were like a crew. I was like your sidekick. You won't even wanna fight when I get off this fucking mic, or you will haunt me. But I'm not an option, there's nothing else I can do. Come on.
Thank you.
For an excellent presentation, covering the elements, covering these different case studies where you talk about the architecture and as well as, your approach to how you went about executing and sort of realizing the architect's dream. Next, we have Mr. Pratik Doshi of Shuko, who's going to talk about sustainability in the Indian context.
Thank you, Karan. Hello, everyone. Namaskar, Pune. So I'm Pratik Doshi. I take care of the facade segment at Shuko India. So I'm responsible for it. And quite a few people also know me over here. And good morning and welcome, everyone. So our topic of the presentation today is sustainability in Indian context. So why it is Indian context, that I'll come soon to it, because there are too many things which we can handle at the time of design and at the time of operation. So I would like to start from a disclaimer over here. I am no expert into sustainability. So you could guess that I am approaching it from a facade system point of view, Shuko's point of view. Okay.
So largely we know, and a lot of places you would have read it, a lot of articles you would have read it, that buildings are responsible for the 40% energy consumption. Okay, so buildings use 40% of it, so of energy and material requirements worldwide. Okay, so like a building is actually constituted of a lot of parts, lot of various materials like cement, you can say insulation, say facade, tiles, lot of materials constituted to become a building, and everyone has their part to play in this 40% consumption. So, as I am approaching it from a system supplier point of view, I would like to point at focus on that how much the facade constitutes out of that 40%. So, out of that 40%, facades are responsible for 20%. Okay, so now if we have to influence into this, complete consumption, we would have to deep dive into what all parts of facade are responsible to actually constitute to this 20%. So I will come to it. Before that, I would like to focus on the life cycle of a whole life carbon of a facade. So you can say that there are products into facades like aluminum profile, the glass, the mineral wool, and a lot of products together makes a facade. So out of that, if we actually see, aluminum is 37%. So it is largely 37% of the 20% of the 40%. Looks like smaller, but if we try to focus on the right areas at the right time, the result would be exponential later on. So here I am showing you the whole life carbon cycle of aluminum product. So right from phase A1 to A5, which are the construction phase, right from fabrication to right from mining, then transportation, then extrusion, then fabrication, and then supplying to the building. And the phase B1 to B7 is an operational phase when it is in use. Phase C1 to C4 is a demolition phase. Okay, and the last phase in the credits is the D phase, whether you recycle or not recycle, that's a different case. So if we classify into gate, it's cradled, if you see that, it's cradle to gate, cradle to practical implementation, cradle to grave when it is demolished, and cradle to cradle when it is recycled. So Schuko has taken a responsibility to work on cradle to cradle, okay, and to provide efficient solutions to people, to our customers, and we are trying to help in many ways to design a product which is having the best cradle to cradle things. Now we understand that we do not have much recycle possibilities, because when we design a building for 50 years, we get the aluminum, we demolish it after 50 years, and we get the aluminum later. Do we have those buildings? No. So recycling and such kind of things, we can park it aside for now. But what we can pay attention on, the phase A1 to B7, which is the construction phase, when the aluminum is being manufactured, and the operational phase. So how we approach this? We can actually we can support you in designing the right systems, designing the right facade. We can support you in actually the implementation in the building so that operational things come down. Okay. Which is the most focus area right now, and that is why the subject was sustainability in the Indian context. While there are other countries who are also sailing in the same boat like India, but there are some other countries who have already solved the operational carbon problem. So you go to the developed countries like England and the USA, some parts of their countries have already solved the operational carbon problem. They don't have that issue that we are not solving the U value, we are not solving the air permeability issue. They have already solved that. So what they are working on is in the main design phase, and as well as at the recycling phase. Okay, because they might have some buildings, but obviously no one has more, because 50 years back, a lot of facades were done by wood and aluminum was used less. Okay, so while we know that operational carbon is required, okay, saving operational carbon is much necessary. It remains an important thing. But what we can actually support you in the designing phase the right from the planning till it is supplied to the site, and using materials which are consuming less CO2, giving solutions which will give you less heat conduction inside. Okay, so Shuko's carbon control initiative is to plan and think about the design, what we can do to achieve better results into the carbon cycle of a building. So we have actually divided into 4 parts how we support the customers. First is design to decarb. So design in such a way that you use the least carbon. So optimum designing of the product, we help you in that. Then it is built to decarb. Along with the customer, we can build a facade which can help you in other elements saving the carbon. Same way it is operate to decarb. How you operate? Let's say if we solve the first 2, we are obviously solving the third one. And recycle to decarb. This for India is not so much required, but yes, one day we will have a very good solution because other countries might have already tried it, and we just steal with pride the ways to do it. So the 3 areas of focus which we will maintain in our designing are 3 major points to actually support any customer in reducing the carbon emissions. And reducing the carbon emissions is directly proportional to reducing your power consumption as well. So if actually the sustainability is sounding as it is expensive. So at the long run, it won't be expensive if you actually pay attention to the right points. So it is the 3 big major points is U value, air tightness, okay, and material consumption, okay. So I'll first focus on U value by giving an example of a project which we are executing recently. So the project is an Adani Energy House. They are coming up with 2 towers at the Shantigram, Ahmedabad, and the consultants are Fencon and architects are Arch Group. Okay. So the challenge we were posed is that even after having so many aluminum fins and everything, the U value of the facade has to remain below 2. And they asked us, the tender mentioned 2, they asked us to maintain at 2.9 because at 1.9, because if I end up at 1.9 after the flashings and the enclosures at the sides, they will again come back to 2. That's why I was asked to maintain it 1.9. So it was challenging for us because the facade had fins and a lot of the facade design was not too wide. There were too many aluminum on that. So we actually took this challenge by reducing operational carbon. We had thing in point that how do we reduce the space cooling and all that. So we provided a solution by giving thermal break barriers, and by which we had planned to actually change the geometry of the profile, and we designed a new profile for them and use the right material selection. So we all know that polyamide is a costly resource, okay? And if you change an aluminum to polyamide, it becomes costly. So that challenge was also solved, because also getting solved in India, because the more and more customers will start taking polyamide, we will have a better polyamide over here. Currently, we imported the polyamide over here for this project, and we achieved, by using the right geometry of the profile, making completely new dies, we achieved 1.87 watt per meter square Kelvin. So we were asked to maintain at 1.9, we achieved it below 1.9. And how did we do it is, we just didn't use any thermal break barriers. We used thermal break barriers, but we suggested the customer to have a lot of membranes in some area, like fin connecting areas, to stop the heat conduction, use the right mineral wool to stop the heat conduction from the spandrel area, and so on. So it was a complete joint effort, and we took almost 3 to 4 times we calculated, taking the part elevation and everything, and this U value which was calculated was for the complete project. So given said that, if we discuss about Pune, we have only 1 or 2 projects who had ever discussed with us about U value, and this concerns us because we have too much of heat over here in Pune, and we are spending too much in the glass. I'm seeing my clients are spending too much in the glass, buying the right glass. But if you're not designing the facade system or not considering the facade system at right, considering that its weightage is very less, it might not turn up well in the long run because the aluminum profiles will work as a heating coil. And a lot of projects are now using fins, so that fins will conduct more energy inside. So right planning is required. Currently, the trend is the tender has been shooted out and you are negotiating. And no one wants to negotiate with a professor who is advocating for sustainability. So, like, when I have to choose between sales and teaching someone, okay, then the teaching will go out of window because obviously we are all here to make business. So the second project after the U value one, second project I would discuss is the air permeability. Okay, how do we achieve the right air tightness? So by example, I'm giving you this example of a project ATS Pragya. Okay, this is Pragya 2 tower at the Gift City. This is the first tower of the Gift City 2.0 and the fastest tower till date in Gift City, which was completed. So 31st, I'll say 26th December last year, the first lot of 800 panels was supplied, and 15th March, the execution was completed. This is the recent photo. Some execution at the top is pending due to some signage issues, but I would like to bring back to the point that we were challenged here for the air permeability. Now, normally the industry standard or a lot of generic tender asks us for 27 meter cube of air allowance. Okay, and that is 300 Pascal water air tightness is generally okay with a lot of people. So what the consultant had asked us to keep it at 600 Pascal water tightness. We could have easily kept it at 600 Pascal water tightness, keeping it at class 3. So if you see on the table over here, if EN class 1 allows 50 meter cube of air, 150 Pascal water tightness, which no one accepts in India, except or mostly the projects which are under consultants, they never accept 150. So first EN class 1 is, we will not consider that. The EN class 2, which is widely accepted, that 300 Pascal water tightness with 27 meter cube of air. But if you, the major case is between the class 3 and 4. The class 3 also mentions 600 Pascal and the class 4 also mentions 600 Pascal. But the catch is in the air permeability. The class 3 allows 9 meter cube and the class 4 allows 3 meter cube. Now it looks the difference of 6, but actually the difference is when we have to solve the problem, there is too much of things we have to do into that. We're designing the right gasket and the right system. So we designed the system completely new for this project. We extruded the profiles for this. We made new dies and we solved the problem by changing the geometry using the right gaskets and keeping it below 3. We didn't get time to test this project because we were awarded in October end. We had to supply the first lot in mid of December, which we did, and we are happy that this may be one of the buildings where we supplied on time and the building completed on time. Otherwise, it's always reverse. Either you supply on time and the building doesn't finish, or else the building is on time and you don't supply on time. So that question is not the case these days. We are ready and we did this. This is an example in front of all of us. The third is what we said is the U value, okay, the air permeability, and the third point was material optimization. So this is about the material optimization. So this project at Hyderabad is almost a 30,000 square meter facade requirement project, and it required facade at a good wind load over there. So what we had to do is we had to design a facade which was fitting to the budget and using the right material consumption. Also, it should the weight of the facade should be less. So and the U value wasn't the concern over there because the facade panels were quite wide, but we had to maintain the weight of the facade down. So our engineering team worked on it, and we achieved. And along with along with our design team, and there were few professors from IITs also involved. Along with them, it was planned, and the new facade design was new design of a profile was made. We extruded that, and the execution is still going on. This is a very recent thing, and I'm sorry. The facade consultant for the project is RSM Designs. By mistake, I wrote that. So I'm sorry if I'm mistaken, sir. So this was an error, typographical error. So what we did in that, the geometry and the load sharing of the profiles with the transoms and the mullions, we actually calculated it once again, and we vetted it through some professors of the IITs who were friends with the customer, and we achieved a design which was lower. And how do we do that? We have a tool into, Schuko has a virtual construction lab in Germany, and the virtual construction lab helps us to analyze a lot of things virtually. And they have developed a tool which can actually design the profile by optimizing the geometry, the shape of the profile. So if we see here how the tool works is using the right depth, right material requirement, right thickness at the right places, and solving the problem. So it is solving the problem that it is helping you in reducing the weight and giving you the right strength. So I have seen some generic tenders who mention that we want 2.5 mm wall thickness. Okay, fine, you can take it, but you have to pay for it. So actually, giving same thickness around the profile is not smart. You have to use the thickness on the profile only on the structural areas, and the non-structural areas can be reduced. Sometimes it is not possible in extrusion, but sometimes it is. And that is where the designers come into picture, who actually get no credit while designing, because everything boils down to what are you offering. So everyone who designs actually thinks over a lot of things which the customer actually don't know or do not understand, and some of them are very learned, they also know it. So this is where we urge to people that for planning bigger projects, we need to sit together and plan a design at time. And that is why few of our great consultants actually give us a concept, that I am not imposing my design on you, I am giving you a concept, please come up with the best design. And that is what we do. And we like the approach that we can give our design, and we have a freedom to actually talk and make the thickness accordingly. So, okay. Now, these are the points where we can actually work on and reduce the impact on the carbon emissions. By actually, the first thing is form and shape of the building. Okay, if we work on that, some problem can be solved. Then influencing the facade elements, as I discussed when we work on that, and we discussed together, and a lot of problems can be solved at start. So what we can do is, if we solve the planning stage, the phase A1 to A5, the construction phase, that is the design to decarb. If we design to decarb, and we actually design it such a way that it reduces the operation carbon, we can save a lot of carbon emissions. And if we save the operational carbon by the consumption of energy, it will actually in the long run give you saving in the power consumption. Okay, so choosing the right system solution, using the right thing, it cannot be possible that you use a system which doesn't have the right amount of gasket, doesn't have the air permeability, and you've used the optimum aluminum, because it has to be a proper system. Everything has to work hand in hand, and the customer's intention about the design, about the reducing the operating carbon, also has to be in line with what we are thinking, so that we can come up with a system, and we are enthusiastic about supporting you in that. Optimizing the material. Optimizing the material is what I discussed, like, we can actually optimize the thickness, optimize the transoms where they come, optimize the size of openables, and so on, which can actually reduce the impact on the energy consumption in the building. So that's what I had to say. I had a very short presentation, and thank you, and you can actually talk to me when I'm out. Thank you so much.
Thank you, Pradeep, for your presentation, discussing the various tools that you use for improving the sustainability of your projects. But now is the moment we've been waiting for. We have the keynote speaker of the day, Mr. Shival Machanda from ENIA Architects, who's going to talk about his work on several different institutional projects he's worked on, such as the Pune Airport and the Pune Metro Station.
Hello, thank you. Thank you for the introduction. So I'm going to present here majorly transport infrastructure project. We have been working a lot on these projects, and 3 projects which I have included. One is the Pune Airport. So that's a slightly longer presentation because we want to take you through how the concepts were developed and how it changed over a period of time. And then the next one is a metro station at Nagpur, Kasturchand Park, in a heritage context, and the project of railway station, some glimpse of railway station projects in across India. So there are a lot of railway station projects going on. The Pune Airport project, it was conceived in 2017-18 approximately, and that was a time when airport sector was growing a lot and there was no space at Pune Airport. Pune Airport is guided by defense. The property belongs to defense and there is hardly any space at Pune Airport. So as a stopgap arrangement, it was decided to build a terminal next to it just to expand to take care of few years. In fact, the existing Pune terminal is already overflowing. And there was a time when it was growing with around 20-25 percent per annum. It already touched around 8 million passengers before COVID. After COVID, it has already touched around 6 million, then 9 million. The new airport terminal is designed to cater for 19 million. It will be an integrated terminal. The site is allotted next to it. Existing building is around 23,000 square meter. The new building is around 35,000 square meter, including the inline baggage system. So, things keeps on changing. If you see the old building itself is a combination of 2 buildings. There is an old RCC building, which was built in 1780s when the airports were constructed in RCC. And then there was a building which was constructed around it in PEB. And then now there is a new site and the systems have changed. The aero bridges have come in. If you see this old picture, there are only 2 aero bridges. But now they have already built 5, and the new terminal will have another 5. So the project site was allotted right to the existing terminal because that was the only land. There was a discussion between the left side or right side, but the project was given as a right side. There are some parking plots across, which was also a part of the control of AI, and certain hangars built on the site. Now, and then there is a forecourt in which the majority of the flow of vehicles happen. So part of the study obviously is to do how the existing airport is working, to see where the departure and arrival is happening, and to work out the flows and try to divide it into an pictorial representation that this is how the airport is working. Pune Airport is also an international airport, so there is an international departure and arrival. At that point in time, there were only 3 flights, 2 to Germany, 1 to Gulf. But requirement was also to subdivide the airport into parts so that you can operate it separately, domestic and airport operations. Domestic operations were really stretched because I think morning 7:30 to 10:30, there are no flying which happens, no takeoff landing because airport is kind of taken over by defense and they do a lot of Air Force flying. So as you see, the section shows the old RCC terminal, which was the original terminal. The new terminal was built around it, and when you go to Pune terminal, you will find there are a lot of various funny levels. You go from one place to another, go down and up. So it was very, very complicated even to do the survey. And the complexity increased because there were multiple plots which client was still arguing whether we take plot 1, 2, 3, 4, 5, 6, what do we do? Which plot to, we were not sure at that one time, except for plot 1, that which plot to happen. So they asked us to do concepts, considering that there will be some plot which might not be there, there will be some plot which will be there. So first response to the project was to have a new terminal next to the existing terminal, have a cargo terminal shifted next to it on the right-hand side, create a unified forecourt. The idea was to have an integrated terminal in front and utilize the other plots for MLCPs or commercial setup or parking or cargo truck park, etc. But that would mean a conflict in the passenger traffic and cargo traffic. Because the road layout is also complicated. There is a old airport road, then there is a new airport road which is coming. There is a proposed Sunset Boulevard also which is there. So all this complexity add, and we said, can we look at some additional plot and see whether a part of those plots can be utilized to shift cargo on the left-hand side, can we convert hangars into cargo and create a cargo dock area, thereby reducing the conflicts between the passenger traffic and cargo traffic, and create a new entrance and new road, and have a very unified, forecourt in front of the integrated terminal. So this was very, very prelim layout at that point of time, but they asked us to do various studies, whether to have cargo on the east side or west side, whether to have plot number 6 or not to have plot number 6. So various schematic studies were done just to do the site setting. But principally, one thing was very clear, that the the terminal has to be on the right-hand side. The other complexity was the vertical arrangement of the terminal. The earlier terminal had a very low roof, which starts with a very less facade. It rises high in the center and goes low. New terminal, we try to work out options between same grade entry and exit, or to have a flyover. But the flyover was not possible because of conflict with the existing terminal. And also there is no space to put a flyover and the ramps to climb up. So after doing all these studies, there was an intention by the airport authority to even look for the local art and culture and to integrate that into architecture. So we looked at various built forms of Pune, various cultural and material heritage of Pune and Maharashtra, and I tried to get inspiration from these projects and try to see what can be done in the station project. So these are some of the pictures while we were doing, we did around a week of research, going around various places in and around Pune, visit all those areas and try to get some kind of an inspiration from these heritage. So finally, a master plan was developed in which we proposed the cargo on one side, and then we came to know that plot number 6 is not available, so we have to remove that, and we were still discussing between to have a multi-level car parking or commercial or what, all those things were there. So the integrated terminal will be around 400 meter long with a forecourt in front. I am not sure that cargo is still on the left-hand side. They have still not broken the cargo. I think that decision is still pending because they have now constructed a new footover bridge connecting to this commercial plot. So these discussions are so fluid that it keeps on changing. It keeps on changing with the change of minister and change of bureaucracy, everything. Then we moved to the second step of the project, which is facade and volumetric options. So we presented 3 options. First option was the twin curve, which was kind of creating a counter curve in front of the existing curve of the airport terminal. The second was what we called as the welcoming arch, which kind of employs a very, very familiar figure, which was very institutional, and it was kind of a stable form. And the third option was to have a great veranda. First 2 options were made keeping in mind that in future they might break the existing terminal and the new terminal will be replicated in front of existing terminal. So that was the idea while making first 2 options. So if you see, the existing terminal has this arch, so we kind of made the roof in a reverse counter arch shaped. This arch helped us in many ways because it creates a volume in front which is more welcoming, it is more upward and creates a more opening on the front side where the drop-off and pickup is going to happen. And the facade also gives us an opportunity, the colonnade gives us an opportunity to incorporate local art and culture in form of some visual panels on the facade to tell the story about Pune and Chhatrapati Shivaji Maharaj. So this was one of the concepts. The second concept was to have a very stable looking terminal with what we called as the welcoming arch, and the facade incorporated a familiar figure which was already existing in Pune in historical context, and create that in form of colonnade, create those figures in form of skylights above to bring in more natural light, and then create a drop-off and pickup area. Create a garden in front of this form, very similar to the gardens at Shaniwar Bagwada. So these and kind of this overlooking onto the garden, this concept. This was the second concept, and the third concept was to have a one unified terminal because we were still not sure whether they will break existing terminal 1 or terminal or not. And we said that best is to have a unified front in front of the entire terminal. and to create a veranda, which we call it as Great Veranda, irrespective of the shape of the roofs behind it. We have a new facade in front of the entire terminal, the unified terminal. So this concept again has, we got this frame, and the facade kind of has this kind of a printed fabric on the facade, which again is used to display a lot of local art and culture. The skylights were again, the shape was taken literally from the Shaniwar Bagwada, the landscape garden, and tried to put it on the skylight. So this was the other facade. The garden in front is again inspired from the gardens of Shaniwar Bagwada. And as I said, the printed high tensile fabric on the facade to display local art and culture. So after we did all this, obviously client has a lot of this thing. They went into huddle, and then there were a lot of comments. So finally, a final master plan was prepared, in which there will be one single drop-off pickup, the front garden, the new existing terminal, old terminal. There were only 2 plots, MLCP and commercial, which is already built. The right-hand side plot will have some utilities and some retail component also. Overall length of the terminal will be around 250 meter long once it is integrated and built together. Right now, we are only operating on left side. The right side is still not open. It is still, I think they are still doing the dry runs on the security, etc. The layout plans were done to have an integrated terminal which can divide space according to domestic and international arrivals also. So there were separate spaces for, for example, this baggage belt was divided into parts to have domestic arrival separate and international arrival separate. Similarly, on upper side, we have security hold area above for domestic, and this is for international. The security hold is on, the security check is on upper level, on the first floor level. This is how the flow is happening once we enter and go up. We enter into, so regularly, how the airport works. We have a check-in area, then security area and security hold area and then we have a basement with inline baggage system. So this was new because in the existing terminal it is not there. So inline baggage system allows automatic, receipt and dispatch of baggage. During the project, however, they raised the height of the new terminal because they were really concerned about the lesser height of the existing terminal. So one of the thing was to have a terminal which has more facade areas, so that once you are in on the first floor, on the security hold area, you are able to even see outside. The phasing, as we said, we are right now completed only phase 1, which means constructing this terminal. Phase 2 will be the demolition, part demolition or full demolition. That we still don't know. I think that will be phase 2. It will be launched as a separate construction tender, and then reconstruction of either the part terminal or the full terminal. And what we proposed is, in case you have to do a part reconstruction, we break the central part, which is an RCC, cover it up with a new roof and new floor spaces to have a complete terminal built at the single level. So these were the final images. Few things changed. We changed the facade with certain vertical louvers made out of aluminum extrusion with the prints of local, art and culture on the facade. Majority of the other claddings are aluminum claddings. The front garden in front of in the forecourt area is a literal translation of Shaniwar Bagwada. These are some of the views from the air side. So total 10 gates, contact gates. This is the garden in the front, the forecourt area. And then few images of, the drop-off areas where the drop-off and pickup is happening. So we made this skylight also a literal, taking the shape literally, but I think during the construction they were not able to achieve that, and they changed it to hexagonal shaped skylights. But yes, it is quite close. In fact, later on, I think instead of this block, they have also, built some arches. Again, taken from the forts of Pune region. These are some of the images for the departing passengers and arriving passengers, the arrival corridor and departing corridor. The general color and hues of the project was kept very, very warm. Again, taking, hues from the local hues which are available in Pune. And these are some of the, site construction pics which I just compiled. So the main structure was RCC structure, column, and steel trusses covered with aluminum standing seam roof. This is the double height area. So yes, the volume has increased because the terminal is lifted, the roof is lifted, the shape is slightly changed. So inside the volume is bigger. This is the forecourt area in the front. This is the skylight which I was talking about. So they changed it to hexagonal skylight. This is the construction of the front facade, where they have to put the panel. And in the end, they never used the louvers, aluminum extruded louvers. So they printed some, panels and put it on facade. These are some of the interiors so we don't have full pictures also because we were not allowed to take the pictures. But some pictures we got for this thing. I think they're still doing the dry run and the security testings on the site. The second project which I'm going to present is Kasturchand Park Metro Station. This is in Nagpur. So this particular station was in a heritage context, and we did this entire line from the interchange station Sitabardi up till Automotive Square. So this was the third station on the northern side, and it was part of a place where there were a lot of old buildings, heritage buildings. The Kasturchand Park Chhatri, which is a Grade 1 monument, which is right across in this triangular park. And there are Reserve Bank of India. So this is a Grade 1 Chhatri, which is in a fair condition. It's of 19th century. It is made in Rajasthan architectural style, kind of a pavilion. Then we have Allahabad Bank, which is a Grade 2 structure, not in a very good condition, built in late 19th century. The main Winter Assembly of Maharashtra, which is in a good condition because because of its upkeep, and there's the Reserve Bank of India. So there were these 4 heritage plots. Of our first response to the project site was that it is important that while you climb up the station, we should see these projects, and they should create a dialogue between the old and the new. And how to do that was to create some new viewing points from the station to look at those monuments and to have that transparency in a way that you are able to look at it. So we looked at certain international references. This was one of the references, Acropolis Museum. Another reference in France, where a very new glass facade is built in front of an old heritage building in a way that it kind of reflects the old building onto the new facade, and it gives very, very, different and new, perspective to people. The contrasting material and geometry was very, very interesting in this kind of projects, and we said that, okay, let's try to use it. So one of the elements which we wanted to use was to create points from where we are able to look from various points while climbing, while at the concourse, and while at the station. So we have all these elements wherein at the street level, from the concourse and platform, we created those viewpoints so that we are able to reveal the neighborhood in terms of, while the passenger is climbing, they are able to see various, parts of this heritage. So one of the element was to create this large overhanging roof over the top of the station, just like, the Chhatris. And it was a key element. And the next was to create because the concourse is the area from where people can have the maximum view. So we created the central area where the people are climbing up through the escalator staircase and have an opening. And this opening can have a literal, text written about the various heritage component. And then the rest of the facade will have customized metal cladding, perforated metal cladding, which can again generate some pattern, interesting pattern. But as things turned out to be, so this was our, the concept at that point of time. And as things turned out to be, there was a defense plot next to it. And then there was a gadget notification. You cannot overlook onto the defense plot. It was not really a defense establishment. It was a small defense office. So instead of now, our concepts turned upside down. Instead of looking outside, we said that how do we create the building in a way that it looks more solid? It should feel that, nobody is looking and, prying onto the opening and still have that sense of, connectivity to this heritage. So we start looking at the project in a different manner. We started getting inspired from the Chhatri itself, and we said, okay, if we look at those frames, architectural frames of the arches and take that frame as a key element, and then we picked up a pattern from this and converted that into a jali, and we tried to use it, jali, in a manner that the station itself looks very, very solid and it looks kind of opaque, but it has still that element of transparency. And since most of these stations are non-air conditioned, so it's also required that it should allow, winds to pass through so that it is naturally ventilated. So in the end, we come to this facade, which is basically a double skin facade. So we have all the internal walls and windows of concourse and the solid walls of the technical rooms area, which is not seen. And it kind of, becomes a new screen, a new background to the Chhatri. And in fact, Maharashtra Heritage Conservation Committee wanted us to put one screen in which you can kind of display about the Kasturchand Park, Chhatri, etc. So those places were done. So these are the final pictures. So what was the past? What is the present? And that time it was not there. Now this has come up in the background, the future. So we don't know what is going to be. It's I think, a residential property which is coming up. So these jali are PVDF coated aluminum, CNC cut aluminum sheets made to design and put it on facade. Again, the entire concept of a very, very modular, it kind of keeps on repeating itself. So these are just some of the pictures of the finished project. Because unlike other metro stations, traditionally, if you see the metro stations which started in Delhi were very, very basic use of Kota stone and blue color roof. I think just by force, because of heritage conservation and those kind of aspects, we were able to do a little bit, facade on this. I'm not sure how other stations are coming, but slowly I think there is an inclination of client to have, facades which can express about the location, about the station. So currently also we are doing a few more stations in Nagpur and Mumbai. So we are trying to bring in new facades for that. Just a glimpse of certain railway station projects. It's a big program by Government of India. They are spending almost like more than 1 lakh crore rupees on upgradation of around 1,400 stations, 200 major upgradation projects and around 1,200 small upgradation projects. So we won this competition for the Nagpur railway station, which was again a grade 1 heritage structure built by British, protected. And then there is a metro on the other side. And we were fortunate to have worked on not only on the master plan, but also on the road project, extension of Ram Jhula, and the metro station also. So in a way, this entire sector, whatever you see buildings are kind of designed and are being done. So this project is under construction. So we break everything what was next to the heritage building, and we build this new roof plaza, which is 27-meter wide inclined and 8 meter in the center, which is the new area for housing passengers, waiting passengers, and then arrival and departure concourse on northern side and southern side, all connected, interconnected, so that the flow of passengers is nicely managed to achieve a level of service which is required for the project. So this is under construction. Some portion of the eastern side is, I think these buildings are already coming up. This building is coming up. Once these buildings come up, they will start demolishing all this area and the rest of the project will come up. Some construction on the platforms have also started. These are some of the views from the outside and from the inside. Another project which we are doing is Asansol Railway Station. Again, there was an old building by British. It was not protected, but there is kind of what we call it as emotional value to it, because everybody who is in railways kind of relate to it and they say, no, we can't break. So, there is a segment of client who says we can break it, but majority of the segment of client says we should not break it. because, you know, there is also matter of that it will create hue and cry in the local media and public. So we chose to again retain it, but convert it to a very, very premium, you know, retail come waiting area for passengers, thereby making the new building for the departure and arrival of people, having a 108-meter elevated concourse covered with a roof, which is airy, open from all the sides, and naturally ventilated, and connected to the north side by having a new building even on the northern side also. So these are just some of the glimpses of the project by having this I-shape skylight on the top. And this is the elevated concourse over the tracks and platforms, which is going to come up. So both of these projects have been awarded now to the contractor. I think Nagpur project is awarded a couple of years back. So there is a lot of progress. Asansol was awarded just last year. So that's it. Thank you. Thank you very much.
Thank you, Mr. Machanda, for a very nice, informative presentation about the various works that you've been carrying out over here in Pune. We have over here our last session before the lunch. I'm sure all of you guys are hungry, but it's just one last little session we have over here. We have a panel discussion, and it's going to be led by Mr. Milind Sorkhande. Milind, can you please come up on stage? Milind, if you can introduce the panelists who are going to be on board with you for this discussion, it will be great.
Hi, good afternoon. Myself Milind Sorkhande from Enclosure Facade, and we will have Sushant Varpe from Trida Design, Vishal Sutar from Dhruv Facade, Anshu Shukla from Gera Developers, Swapnil Patil from Swapnil Patil Partners, and Satyajit Limay from Limay PMC, and Ms. Pallavi from Gagan Developers. Good afternoon, everyone. And you know, the topic of the discussion is about the sustainable design. Mr. Pratik from Shuko actually gave a very nice presentation. Pratik, thank you for the sustainable facade design topic. As everyone aware about the topic, how we are going to design the facade in a sustainable way. So I want to just ask few questions and to start the discussion for the architects, that exactly what are the performance criteria which you take into the consideration while designing the facade, which can be sustainable also.
So, sustainable options are obviously the passive options like shading devices and controlling the microclimate around the building. Those kind of features are of course used. And other than that, like the double screens and obviously glass facades when we are using, we are trying to use materials that are more, have a lower U value and more energy efficient.
But to achieve the net zero carbon, what are the things which can fit in our budget? Okay, because the budget is something where the facade design, from the design point to the finalization, there are many stages, the cost cutting, value engineering. So exactly when we are thinking about the sustainable facade, which can fit into our budget. So as an architect and as a developer point of view, how you look into it?
See, when budget comes into picture, the game changes a lot. But otherwise, I mean, we can have more plantation, we can have green walls if possible, those kind of things, and then use solar energy as much as possible for use energy efficiency of the building. That kind of thing can be used.
Yeah, Anshu, you want to throw some light?
Yeah, well, I would want to represent the developer side. I think we've got good number of architects who've been there practicing.
So from the developer point of view, the budget and the sustainable facade.
See, somehow from a developer's perspective, we get locked with the limitations of the plot where we have to build, right? The first approach for anyone when we're looking at designing or we're looking at developing a project would be to try and see how we are able to do a passive design in terms of making it as sustainable as possible. We do have challenges because the requirement comes first, and obviously the sustainability follows because the need is to meet the customers whom we are working for. Having said that, there's a limitation to which we can get into passive design. Eventually, to mitigate the situation is where we look at other modes of facade design, like in terms of what kind of glazing we're looking at, what's the elevation treatment that we are trying to do. I mean, obviously the purpose of the building comes into picture. We can't have solid facades onto a building which is going to be commercial when we're having small office spaces looking outwards. So things like that. So there are those challenges that we do have. But it's very important that as developer, we collaborate as much with the architects and the facade consultants early on to give them some brief in terms of, what's the kind of project we want to look at, what's our budget that we have in mind. It's not that, you need to have a very high budget to make a project sustainable. It's going to be, you get all the stakeholders early on in a project, collaborate with them much earlier to make sure that, it all works in the budget. And I don't think so it's like a not possible task. It's practically, having the will to do and make it happen.
Yeah, I agree with your point that all stakeholders has to be come on early stages so we can design a proper project. Swapnil, you can have your opinion on this.
I'm Swapnil.
Yeah.
Should he respond or I should respond?
Yeah, Swapnil.
Okay. You want me to respond to the same thing?
Yeah.
See, for me, I mean, I'm going to really approach this from a 30,000 feet bird's eye view and sort of have a very generic perspective towards the whole facade, because facade is really that interface between the interior and the exterior environment. It sort of creates that, it's a dynamic system that really needs to balance, the functional requirements as well as performance objectives. So just to give you an example, as an architect, when we engage on a project, there are a variety of parameters that we start to look at. First of all, let's say in Indian context, solar gain becomes very important consideration because, we are essentially a country that is blessed with sun. So, how do you sort of look at that? Because of the solar gain, there's a sort of thermal insulation that needs to be taken care of. There's a daylighting that becomes another objective, how do you enhance that? And then the airflow movement. I'm just like really dumbing it down to very simple 3 or 4 objectives or parameters that we sort of need to address. And once those are in place, then we can start to devise active or passive design strategies to start to address each one of them. So for instance, if it's solar gain, then what kind of sun shading devices we are going to use? If you're talking about thermal insulation, what sort of materials that we are going to use which will give us reduced U value? So on and so forth. If it's daylighting, then how do we work fenestration patterns and window sizes and openings that will sort of optimize the daylight and give a better quality of daylight, because daylight is not just daylight. Is it glare free? So there are all these scientific parameters that you start to weave into the whole narrative that becomes equally important when we approach the facade design. So to me, as much as I know this is a facade conference, but building design and facade go hand in hand. It's not an afterthought that you start to look at it at a later stage. It's sort of something that is weaved into narrative together, and it's art and science. Yes, sure, there are aesthetic aspirations that go with the whole facade design, but then how it performs, that also becomes equally important. So for me, these two elements are integrated, and right from day one, like Anshu said, and it's a pure coincidence that we two are here on the same dais, but I've been working with her on doing a net zero school building, which is one of the first by a developer that I've heard of. I think we've started a very robust empirical process where we are engaged from step one, and it's not an afterthought. So I think if I have to put in my perspective, the whole narrative needs to be woven together at a very early stage, and then we can achieve the objectives of not only facade, but also building something that is sustainable and more responsible, environmentally speaking.
Yeah, there is one point where Shuko Pratik mentioned about the insulation of the system. This is a point where actually in many projects in and around Pune or in Mumbai, there are some prime projects where the facade system insulation is something taken care of. But in the other projects, the facade system insulation is nobody thinks. Everybody only thinks about the glass U value. Nobody thinks about what is a system U value.
Yeah.
Okay, so there are some thermal break systems. We can incorporate the polyamide to reduce the thermal thermal transmission through the system and all. But then this kind of the small nitty-gritty, when it comes to the project, from the facade consultant point of view, how the facade consultants are taking into the account. Because when architect is talking about, client is talking about the sustainable design, so how facade consultants helps to incorporate all these small points. That insulation is a very important point, and the daylight, that what kind of a daylight, because as you said, the glare free. You look around all the commercial projects in and around Mumbai, Hyderabad, Delhi, Gurgaon, and everywhere you will see we choose the glass where we have some high VLTs transmitting, but then we see people are using the blinds and then cutting off those daylights, and then they are using your normal
air conditioners.
Yeah. So I feel that the whole point is defeated. So Sushant, what is your take on this?
Like, for me, it's not only environmental, I say, like it is like holistic thing. It's a wide term actually. Sustainability is environmental, social, and economical also. And the parameters what we are talking about and all, like it changes. Like, somebody's like a developer criteria is something different than the residential or like a government office, government agency, or for that matter, hospitality. So the parameters when we are talking about, like a basic parameters, he spelled it out, but sound can be a parameter also. So when I was doing a hotel at airport vicinity, or like next to the terminal, except in Bombay, Terminal 1C. So their noise level reduction was like a very big parameter in that design. So if you see a dB meter or something, when landing and takeoff happens, it reaches to 100 dB level. And a hospitality, a luxury hospitality hotel project and all, you need something around 40 dB or something in room. So that kind of parameter also is required, because if you don't work other than the solar and thermal and other kind of parameters, you have to, this is also a prime important parameter. So to achieve that, you need, like from the basic or like a very early stage, you have to do a designing and a planning of it.
This is a very important point actually.
Yeah.
For side rise, Srinivas, I was telling him that other than the fire, you have to talk about the sound insulation.
Sound
also.
insulation,
This acoustic insulation of the facade
Yeah.
is another actually neglected topic. In the commercial buildings, nobody thinks about it, that how much sound transmission we are talking.
Yeah.
But then that is all about the well-being. But when it comes to the sustainable facade, other than incorporating the daylight and the thermal transmissions, photovoltaic, incorporation of the photovoltaic into the facade.
Yeah.
This is something in few of the projects we try to incorporate, but then when it comes to the cost, the budget is something where that goes for a toss, and then we go with our normal facade.
Right. So yeah, again, incorporation of photovoltaic panels and all into the facade and all. Again, like people come to a point where what is the efficacy also. Of course, the costing of it, but the efficiency, like what you achieve compared to the regular solar panels and all. So when you do the comparison and all, in Indian context and all, people again come to a point that is not in the budget and all, and they like mostly they discard it. This this is my experience. I've been seeing it. But yeah, you want to add something?
I think PV panels, I'm talking more from a glazing standpoint, is something whose time has come. And I understand that, I mean, it's not currently an affordable solution in a wider context. But actually, if we look at what's happening from a development perspective, because of the UDCPR and so many other things, we've started to grow vertically.
Yeah.
As a result, our building footprint is getting reduced, which obviously reduces the surface area where I can capture the solar solar radiation and generate the energy. So now, because the footprint is reducing, it is the facade that's starting to get enlarged. So in very many ways, it's a chicken and egg kind of situation where, yes, it is unaffordable at the moment, but if we make it more scalable, then, maybe the prices would sort of start to drop. And like I said, it's an idea whose time has come, because we're seeing a lot of these commercial buildings, IT-driven buildings, where glass is slapped on all four sides, and makes it very incredibly energy inefficient. So if we start to use certain options like PV, and that's where, forums like ZAC could start to push on that idea, because I'll just frankly admit, if I have to do it in India, I don't even know who's the vendor, who's doing what. So there's such a low level of awareness that is in this particular domain.
Yeah.
And I'm seeing a lot of traction on other aspects of facades, but when it comes to PV panels, there's not enough traction that's being generated as yet.
Yeah, I think I want to add something into it. Like said, integration of PV is really required. If you see the whole policy of government policy and all, those integration, or like usage of solar panels into the building and all, we are, I think, short of that target. I think 40 gigawatt or like something, that target was there, and we somewhere achieved 10 gigawatt only through the solar panels and all. And of course, like solar, like a roof solar panels or something only adds, gives the 1% or 2% of energy requirement. But there are a lot of, can be offsetting then. And facade is another, part of a building where you can integrate, and a lot of scope is there. But of course, affordability need to be there and can be used.
I think, somewhere we should get from this mindset from one size fits all kind of a logic, wherein an office building would typically mean just glass, or maybe going tall just means glass,
Yeah.
and then you do the same kind of treatment on all the sides of the building. I remember when we were talking about the sound insulation for one of the projects that I was working, this office building is very close to the station and the railway track. So we actually realized that the glazing for all the four sides had to be different. So while you have extra insulation to be taken care for the railway track side, the other side needs to have more of dead walls rather than more of glass, considering the heat gain and all of that. So we literally had all the four sides which were designed differently in terms of facade design. But then that's when the role of the architect comes to see how we integrate all the four sides. And I remember, what we were doing for the school was another thing, when we realized that we have some 4-6 sides of the school building, and all of them have to be differently responsive.
Yeah.
How do you tie them together to have a unified look is where, it needs to be more of a collaborative role between the facade consultant and the architects working together.
I think that optimization come here, like, when you are saying, like, I need a one look all around the building, it is not really, optimizing the material or the system to it. Like, whatever it is required to that side, you are, giving that treatment, facade treatment and all, and then you optimize that one. It is, of course, it is required like that way. The approach is needed.
This comes to a point where materials, when you design a project, in the very beginning, you know that what kind of a material you are going to use it. But when it comes to the facade consultant, how facade consultants helps the architect to choose the right material? Because many times architects have decided, okay, they want to use this kind of a material, and when the facade consultant comes on board, then there is a possibility that the materials which has been chosen by the architect, sometimes it doesn't fit in the budget, sometimes there is practically it is not possible to use. So, Vishal, can you throw some light?
Yeah, talking from the sustainability point of view, when choosing of materials comes into play, at that time certain parameters regarding the green building have to be followed. Like when it comes to
When it comes to the glazing part, the sealants, the membranes, etc., those have to be selected judiciously, wherein the VOC emissions of those particular materials have to be in control and have to be in, the allotted parameters. So, as a facade consultant, we look into that factors like adopting that kind of materials which are suitable for a greener building, for a sustainable building. We recommend those kind of materials in that.
Yeah. Satyajit, as a PMC, when you are coming into the picture from the architect point of view and then the consultants and then appointing the contractors, so what are the challenges you face tying all these loose ends together for the execution?
I think once you start the project, the project starts with a very good education. Everybody has dreams of going through the education and completing that project based on that. But what we see on the other side is the budget is already fixed. The developer knows his budget. He knows that this facade is going to cost him this much. But then you start integrating all the other things as was earlier mentioned that with regards to energy efficient buildings, having the right systems getting integrated, with regards to safety. With a lot of compliances coming in, you also have to make sure that those are also integrated. And we have to nurture and make the project in such a way that all these things are getting implemented. So you don't work reverse for it, that we have a facade, we start getting into the details, we get a budget which is way too high, and then we start cutting down corners everywhere. And in the end, what we get is, trying to compromise in a lot of cases. So, getting the right materials, finalizing the budget at the start, right accreditations, looking into the complexity of the project with the facade consultant and the architect, and implementing the regulations is the right approach to go about. Getting the end product that was, dreamt by the architect and
This is actually a very interesting point, which I would like to discuss openly, that from the concept, design, tender, and then the value engineering process to cut down the cost. Means in India, actually, to cutting down the cost, we gave a very nice name as a value engineering. So that value engineering, how that is affecting the whole basic design.
To be honest, value engineering is important because we have to be realistic also somewhere. We have an end cost, we have dreams, we need to have a project which is going to be an iconic project. So we have to come to some means where without compromising on the materials or the intent of the whole facade and without compromising on the people who going to occupy it, they are also need to give them that quality of workspace, life, or if it's a residence. They need to have quality life. So it has to be taken care of in all these respects when we are planning our future design engineering without analysis.
No, but see, there are the A-lister project, which is everything goes perfect in those projects. But then there are the projects which just looks like a glass box, where we start with a design where all aspect we think about it, but then to cut down the cost, the sustainability takes the backseat. So my question is that why we don't put all our thoughts in the very beginning? See, I understand that every project cannot be the A-lister, but then in every project we can at least try something to achieve the sustainability. Because this is my personal experience, I don't want to offend anyone, but I always feel that when project comes into the action, everything goes backseat. Only the cost is the matter.
But didn't I add to this? The initial project that we did, the facade was the issue. There was no fire sealant, there was no spandrels, and everybody knew everything. From there to where we are getting to, with proper issues glass, with performance glass, by having energy
work of analysis, like the right system to be implemented. I think so we are going towards that. And slowly we will be going way forward. So it's not that it's not happening, they are happening and the intent to do a better job or better product is there and innovate.
No, it is happening, Satyajit, it is happening, but then the space of that change is very slow.
See, somewhere specifically with the Indian mindset, which you might call it like a legacy mindset that we have, is that when we're looking at buildings, you have these international companies, they're coming to your projects and they know that they want to, occupy a sustainable building. When we're talking about developers, and I'm talking about residential apartments, buildings, and masses at large, it's very difficult to try and convince each and every individual, each and every buyer of the apartment to say that, this is sustainable and this is going to be benefiting you. Typically, the masses do think that, residential building sustainable means it's environmental friendly. So this is good, right? It's basically taking the step towards making aware. So like, for example, we've started making sure that all our projects, whether it's residential or commercial, we will work towards making them at least the basic IGBC kind of, certified buildings as a step ahead to let the customers know, let the buyers know that these are going to be the benefits that you would see now, not now, but as you occupy. It's going to be a first step wherein, as people start living, they see the benefits and then they realize the value of living in a sustainable project. I think it's going to be a very slow stage of, improvement, but I think we're going slow and steady, we're going there. It'll take time. It'll take time. It's not going to be as faster. We've got a lot of bigger population to deal with also.
Yeah. So again, when like you're talking about in the name of value engineering, people really sustainability aspects or something take a backseat. So it doesn't happen everywhere. Like maybe it's a rare case or something. But when the objective is clear. Of a client and all. So I'm not talking a particular developer, like a builder, something who is just taking care of the residential or the commercial. But there is other clientele like a corporate or government and all. The objective is clear to have achieved that much of rating or something. It's not only for the sake of rating, but in a long term also. Like if I'm making a ONGC headquarter or something, their objective is clear. I want to earn that platinum rating, and it will be beneficial for the longer run also. So like operational costs and everything. So objective is clear. Of course, the value engineering happens there. It doesn't take take away the whole aspect of sustainability. This is what my experience is.
Yeah. This rating system, actually, I always feel that because of this rating system, it gives a broader idea. But most of the times while choosing a material or choosing for a design, the properties of the material, everybody starts depending on how much points we are getting, whether we are going for a gold rating, we are going for a platinum rating. There is one incident recently I encountered where the architect was adamant of using a material which is made in USA. And I was trying to convince him, sir, if you are going with this material, then if you see the carbon footprint, the importing, first of all, it is super expensive material. We are importing this, getting the sizes and everything is difficult, and it is not something is helping us. Yeah, it allows a daylight, everything fine, but then the sustainability, the ratings and all, it will affect. He clearly said, keep sustainability debate aside. I want this material. You tell me whether you are getting it or not. So these are the experiences actually, discourages us to suggest some local material. Means how we can assure that we are using a local material. Means not every time we can go to China and source the clay and terracotta tiles. So how we can think about choosing a local material which is available in a short distance, so our carbon footprints, sourcing a material is less.
Yeah, so can I add to that?
Yeah, you can add.
So when we are saying like, like we should use the local material and all, and maybe in a broader picture, like we should not think like, using the material, like local material as a whole. Yeah, it can be used as a composite. So like I think I was just looking at the slide and all, like the GFRC, the cladding was happening there, and they used seashells into that material. The composition happened. So similar matter, like like we can think, you can use a basalt or like bamboos and all. Maybe it's a bagasse from the sugar factories and all. You can use this as a composite material. And that works actually in a facade, in a building, and every aspect of the building construction. Yeah, and like a willingness to spend time into R&D, a bit R&D and all.
See, time and again, it's the market forces that will determine what kind of choices we make. To be very specific, I think we need to really create a very strong distinction between necessity and aspiration. To build it in a certain way, to source a material from certain, like you mentioned, USA, that's more of an aspirational. To get certain points, that more of an aspirational want. But as a necessity, I think, for instance, we are having this very elitist discussion around facades, but they need to be mainstream. Every single building, be it a developer-driven, a residential, or a house, has a facade, right? I mean, it need not just have like fancy things in place. So how do we address that? I mean, if you look at yesteryears, simple things like cavity walls, that gave a very high performance. We are not talking about that. Doesn't require a lot, I mean, that same 300 thick AAC wall can be split into two and you create a little cavity that will give you a high performance. So somewhere, I think, like I said, it needs to be mainstream. It needs to come down to, and actually for me, the battleground is housing. The battleground is real estate projects, because that's where we can make difference, and that's where the economies of scale can be achieved. Few iconic buildings here and there, is going to really create that Dubai syndrome. I mean, you have all these fancy buildings, but let me tell you, none of them are high performance, because it purely comes from a very aspirational, Instagrammable perspective. But if you look at day-to-day buildings, or what I call as everyday architecture, what are the steps that we are taking there to create high-performance environment? I think that's where the battleground is. If we're really talking about holistically from a sustainability standpoint, if it's a greenwash, if it's just accruing the points for platinum or whatever rating you're looking for, I think that's straightforward. That can easily be achieved. But without going for these, how can we make the difference is the really key question here.
That's the day-to-day architecture. That line, that most of the buildings we are only creating the glass box. Nobody is thinking other than the glass, what are the other materials we can explore and how we can make a composite building using the different materials to reduce the cost, to get the energy efficient building. So this is where something I feel that architects and client has to take a step forward. And instead of creating the glass box, we have to think out of the box to create a more sustainable buildings.
Yeah.
So, somebody.
When you're talking about facade, why are you saying only glass? Right? Or commercial buildings. Look at residential buildings. We are doing all high-rise buildings. All are RCC walls. There's a heavy production of heat. And that has to be addressed in the way of facade design. Because going forward, if you look at the temperature rising outside right now, you have all this heat is captured, that's left at night, the roofs get hot, you increase the AC condition. We are just talking about commercial buildings, glass, and how we can address those. There's a lot to facade, not just about commercial.
There are glass buildings coming up as a residential buildings also, Satyajit. Those high-end residential buildings have so much glass content. Okay, this means the terminology of I'm saying about a glass box, it is coming, means day to day our residential buildings, these are RCC buildings, but there are the high-end glass buildings also, There we are using high performance glasses and all, but when it comes the temperature rising and the uses of a AC, that is taking another toll.
I think when we are saying only glass, so again, like, like people abuse the material. Like, like some time back, there's like a concretization was there. Only a concrete block. Like if you see a Pedder Road architecture, like, from the Bombay term, it's like a Pedder Road architecture. It's an abuse of concrete. Like people don't use, like, like the way, Tadavandu use a concrete and the others use, like, it's like a readily available, let's make it in a concrete. So now it's like a glass is like a easily available, faster construction, like, maintainable and all. So like everybody uses it. But there are layering to it with the, objective of having a proper daylight and all, more views and all can be achieved with the glass. But now you need a layering to it, like, having a fence, a right angle, right direction, the shading devices and all. With that, keeping a glass building also, you can achieve the sustainability. This is what I'm saying. People just, takes up the another skin, another layer of it. Just putting a glass is not enough. You can have a glass, but the shading devices are required. Some other mechanical systems are required, as, like a direction, the different directions require a different treatment. That required. People forget about that. Just use slabs and just, enclose it with the glass. That's not the way of doing it. And everybody says like a term set glass is bad. So I think like, we should stay away from, just discarding the, word of, glass usage is a bad or something. That as a system we have to think.
About a ventilation. This glass box buildings, what we are creating actually somewhere, I feel that we are not even paying enough attention for the natural ventilation also, most of the times. So
again, it sort of loops back into two theories I have, which is like the awareness and the process. What I mean specifically is that, like I said, if there is an aspiration to do a high performance building, it cannot be just an afterthought when all the planning is done. Right from its conception and initial stage, if all the stakeholders, be it a PMC or architect or consultants and the client, if together we huddle around, do a workshop or whatever it is, and try and spell out what are the options that we have, then, out of that process, an incredible outcome can be achieved. Whereas, if I come in just as a facade consultant, then I'm just giving 1, 2, 3 options, and, you kind of end up using that. So glass, and somebody might just come up with 3 options of glass. What about the other options? There are so many other things that I could end up using traditional materials and techniques. And by traditional, I don't mean essentially bamboo and mud and this thing, because that's not a scalable material. I can do a farmhouse with it, but I cannot do a 100-meter residential building with that. So if I have to do that, then it's very important that I engage, create heightened sense of awareness, have enough empirical data along with that to come up with variety of choices and solutions that can be implemented. So I think if we really have to address them, then at the heart of it is creating that awareness, having a very profound discussion around the subject, and then there can be a will from every stakeholder who's part of that entire process. That's what I feel. So it's not going to be glass or aluminum. That's a debate and discussion that happens later down the line. What do we want to achieve, the objectives? They need to start right at the beginning in the boardroom. I think that's where the differentiator would be achieved.
Yeah, like today, like in Morphogenesis presentation, we saw the Ahmedabad project, and they've achieved quite a good value, in all respects, not just material use, but for controlling energy efficiency also. So it is achievable if all stakeholders are involved and, willing to have the same goal.
choosing the right materials.
Choosing right materials, choosing right elements also, not just materials.
Yeah.
Right system, rather, I would say, rather system. Because, two material, like, when one material acts different with the, context of another material. So having a system is really important than just choosing the right one material.
When we were working on the school project with Swapnil, And typically we consider aluminium as not a very great material to work on for facades. But I recollect when we were talking to the sustainable consultant, he actually mentioned that, if you do the same aluminium as louvers, it's going to be reflecting the heat coming inside your glass, and it's going to be kind of beneficial in terms of ensuring that there's not as much of heat gain happening inside the classrooms. So the same material possibly used or interpreted different places could have different impact. I think we consider aluminum is equal to putting it flat on the building wall. Using the material right, maybe the wood or even terracotta or all of these, where you're choosing them to use them is becoming very critical. I remember when we were looking for this residential building that we were working on, and I was talking to the facade consultant in terms of, saying that, let's have smaller size of glasses and have, so that the cost of glass would be lesser. And in fact, he mentioned that, if we're going that tall, let's do the wind analysis and assess maybe the cost of aluminum is going to go higher than the glass. So maybe, then we need to do the study and assess what kind of facade system actually works. So it's again thinking about what we want to do where, on which phase. And again, it's about making sure all the experts work together rather than, taking one expert at a time, saying that this is done, and then get the next one to say that, okay, this is done. That piecemeal basis working doesn't help in the project in the long run.
Vishal, being from the structure background, what is your take on this choosing the materials and the grid size? What actually in Shuko presentation also they were talking about the bigger the panel sizes, the lesser the consumption, and as now she discussed about this, the building is higher, the wind loads and the system design. So can you elaborate on this?
Yeah, as Ms. Anshu rightly said, we as facade consultants at the beginning itself take into consideration the modulation which is actually interpreted by the architects and work on what the consumption is for that particular modulation. And we come up with solutions wherein the aluminum consumption would be optimal, and even the glass optimization when it comes to the glazing, it's up to the mark. So we try to achieve a combination of glass optimization along with the aluminum consumption in control as well.
So Satyajit, the final verdict, as a PMC, what are the challenges you face when the execution, because see, from the design, everything, when it goes to the execution, we feel that tying all these loose ends and getting it executed on timeline.
Yeah, so I think so the initial intent of the project, to understand that is very important before we get into the execution stage. Because there are a lot of parameters, like it's a complex design, we have to look into the testing part, has to be looked into what kind of structure we are going for. Material sourcing, it's a long area material. Sorry, I'm not referring to plastic.
No, materials, everything.
Yes, so those factors have to be catered into right from the initial stage, or installation procedures, something can be very complex. So we have a very early collaboration and maybe workshops at the start, considering the fact that what is the end product that you're looking into and work in a reverse way. I think so the timelines and everything can be managed very well, because as we are proceeding and as we were discussing earlier, the materials keep on changing based on the cost optimization or value engineering, and again to source material from close by or from where the material is coming. What are its factors that affect the structural stability? Because see, if you're going for a GRC and like a colonial kind of a project, those elements have to be added into the structural part right from day one, and you cannot rely on it before. So we did a very interesting project where we did a optical frame which was inside, outside, columnless, and was cladded with bricks. Bricks not being a non-acoustical material, the architect was pretty sure that he wanted bricks anyhow. without compromising on the acoustics or the aesthetics. So we did a lot of research on it, a lot of, we contacted labs, government labs, where we gave the material, did all the analysis, changed the acoustic materials to make sure that we could achieve the intent of the architect. In the end, we bent with brakes by changing the acoustical parameters. So this took nearly 6 months. So because it was planned well in advance, we finished as per the deadline given to us by the government. So starting early is very important.
So the collaboration has to be from the beginning of the project.
Absolutely.
Absolutely right.
So as the architect and structural consultants are on the project right from the start, we also need to have the facade consultant right from the start. Very important for the project. Because he comes at a very later date and then, with his valuable inputs, the suggestions that are given, gets it back onto the drawing board.
This I faced in many projects where the facade consultants comes in a very later stage. By the time architect and the client has finalized the building design, and only consultant has the role of preparing the detailing drawings and the BOQ and specifications. Yeah. And these are such a challenging situations where you have to deliver in a shorter time and you don't have a time to experiment. Means many times we have some ideas where we can suggest a better material, better technology, how we can make it as a better project, but then the time runs against us, budget, the tight budget. So this is somewhere actually as a client and an architect, if you insist to have all the stakeholders right from the beginning of the project in the planning stage only. So I think we can help to achieve the sustainable buildings with a net zero, achieving the Mr. Modi's target of net zero carbon.
Sorry?
Yeah,
precisely. Yeah, it's,
I think he has set that target, and it's a time we have to wrap it up, and I thanks personally to everyone sparing time and giving your valuable feedbacks. Thank you.
Thank you. Thank you.
Thank you very much, ladies and gentlemen. If the panelists can please stay back, because we have at the moderator, of course, as well. Good afternoon, ladies and gentlemen. Welcome back. I hope you're all had a nice meal, but I hope you're not. I hope the lactic acid isn't building up and you guys aren't falling asleep over there. So, good afternoon, everyone. Good afternoon. Excellent, excellent. Can we try that one more time? Good afternoon, everyone. Good afternoon. Excellent. Right. So we have a nice our third session of the day coming up, and we have an interesting session. We have to start off. We have an architect. A local Pune architect over here who is well known to most of you here in the audience. We have Pritika Manjrekar of Moko Designs, who's presenting Unmasking the Facade.
Good afternoon, everyone. So here I am today presenting to you actually a deep dive journey that I started called the Unmasking of the Facade. A few months ago, I got a call, or one of my team members got a call, Jankna, from the ZAC team, and they said, we would like for you to come and speak. And as long as you're talking about something to do with the facade, we're happy for you to take a topic of your choice. And so that got me thinking, what am I going to speak about? But the word facade kept bringing me back. And I asked myself, to get started, a simple question. What does this word facade mean to me? And today I'm going to involve all of you on this journey with me. So let's start this journey together. And a question to you guys is that, what does facade mean to each one of you? So simple question. What is the first 2 or 3 words that comes up? No right or wrong answers here. When I say facade, what do you think of? What are the synonyms? So Tushar is going to help me here. We have a Menti board. If you can just zoom in with your cameras. and scan the QR code, I'm told that the Mentiboard doesn't put the same answers over and over again. So if you're putting facade as face, then maybe you can put face-SM, just maybe your initials or something, so we can get a lot of similar answers with an initial in it. Love to hear what most of you think. Oh, first impression, interesting. Mask, dress, layer, building skin, identity. That's beautiful. Envelope of a building, personality, so many. Somebody should take a photo of this. Head turner, sustainable signages. Love it. So beautiful. Thank you, everyone, for all of these answers. And so when in doubt, you go to Google or you go to your dictionary. And when I went to Oxford Dictionary, and I said, what does facade mean? It gave me two descriptions. One was principal front of a building, quite simple, that faces the front of a street. But then the second one said a deceptive outward appearance. And that really got me thinking. And I said, it even had an example. Her flawless public facade masked her personal despair or private despair. And I asked myself, well, does facade of a building is only number one and is two also for facades? Or is it only for humans? And what if I was missing something here? What if the second definition also applies to building facade? Have I missed it? Is there something I haven't read as a subtext? And I said, okay, let's do a quick, simple fill in the blanks. So if her flawless public facade masked private despair, then is the building's flawless public facade also masking something that I'm not seeing? And if I were to see this for myself, then I ask myself that when I see her, whoever the her is, then when I see her flawless facade, do I see the despair? Do I see what she's hiding? Or for that matter, when I see beautiful facades that all of us are talking about here, do I see something else that they're saying or not saying? And that started the journey. A deep journey of inquiry and understanding. And in front of you here, it's a lot of work. We did a deep dive, 5,000 years of history, right from the pyramids to our modern day. I decided to look at these a little closely. These beautiful buildings that we have built and celebrated over the years for their magnificence. They represent so much, art and artisans over the years, local materials, a proof of advancement of technology. And also, I've learned so much about these as a student of architecture. They taught me the architectural significances. And as a student of political history, they taught me a lot of stories that were behind these. Starting with my favorite, the Roman, the Greek structures. I've always been a big fan of these. In fact, I've always looked at these proportions, used them in many of my designs, especially institutional buildings, because I thought that they stood for structure, they stood for order. But was I seeing everything? Was I allowing myself to be distracted by these beautiful Ionic, Doric, and Corinthian beauties, and yet having the knowledge and not seeing that this was built by slaves? The labor for this very own building came from captives of wars, and probably slaves that were deprived basic human rights. The breathtaking Colosseum. We all talk about Romans as master architects. And I'm still amazed by the acoustics that this facade engineered so many years ago. But yet again, does this awe-inspiring facade make it easier for me to forget or not see the darker narrative of conquest, exploitation, inequality, and mostly imperial ambition? The timeless beauty of Hagia Sophia, celebrated for its enormous dome and delicate mosaics. But am I able to remember? Am I able to unmask and remember that this used to be a church? A celebration of the Byzantine architecture and art before the fall of Constantinople, what we now know as Istanbul. Am I able to see that these minarets are only a much later addition to what was once the world's largest cathedral. And interestingly, a very different, yet a very similar example, a beautiful cathedral, Notre Dame. I was 16 years old when I first visited Notre Dame. I was smitten by its form, its glory, its intricate details, the flying buttresses, the perfect stained glass windows. But I was completely also unaware of the deep, complex history that stood behind it. Gallo-Roman temple dedicated to god Jupiter. A pagan temple stood at the same site before the advent of Christianity in France. The construction of Notre Dame also is a yet another manifestation of religious power and dominance. Qutb Minar. Even today, this architecture marvel at 72.5 meters is the tallest brick minaret in the world. But while this Victory Tower celebrates the Delhi Sultanate glory, doesn't it also help me mask the mass destruction, the bloodshed, the uprooting of thousands of households, both on the Rajputana and the other side? And then when the Dark Ages got over, a fresh breath of air came in, the Renaissance period. We all know Florence Cathedral is one of the best Renaissance period architecture, celebrated for a conscious revival of ancient Greek and Roman thought, art and culture. The highlight of this era was it took the highlight back from religion to science and art and culture and education. In fact, they gave us Galileo, they gave us Da Vinci, they gave us Michelangelo. But am I missing certain aftermaths? Is it easier to not see the aftermaths? Florence Cathedral that we just saw here was a very expensive building, and it probably created the bigger divide between the rich and the poor, made the rich richer, made the poor poorer. The taxes were levied on the commoners, probably caused financial burden, and they came from rich patrons, making them the seat of power. Ultimately, probably, perhaps, these disparities led to the revolutions that followed later. Closer to home, the Taj Mahal, an architectural masterpiece, stands for its beauty, intricate marble inlay work, timeless aura of elegance. And they say it's a symbol of love. But am I able to see what lies at the foundation of this symbol of love? Or are they just urban myths? Somebody once said that Shah Jahan chipped off the thumbs of the artisans so that they couldn't create a masterpiece yet again. Perhaps it's a myth, but perhaps it also is telling me to unmask and see that for 22 years, 22,000 of slaves labor, worked long hours in harsh conditions to give us this beautiful delight. The United States Capitol building. It's called the Temple of Freedom. When I first saw this neoclassical structure, I felt it represented the architecture of the superpower of the free world. How beautiful is it? This was probably one of my most surprising unmasking when I got on this journey. The Capitol building was built in 1793, went on all the way to 1865. And interestingly, slavery was only abolished in 1862, which means a lot of documentation points that there was use of African American slaves for the construction of this Temple of Freedom. Yes, the irony is hard-hitting, but unmasking is seeing the full truth. And there's also a beautiful truth in here too. 146 years later, in the same building, Barack Obama was sworn in as a president. Gateway of India. A beautiful blend of architecture makes this eclectic Indo-Saracenic style truly, truly unique. If you look closely, it has combinations of Gothic, Indian, and Islamic motifs in it. Here the unmasking was a little different and gave me a fresh outlook. can architecture then also be used as an example of how it is possible to create something beautiful, taking the best of all influences that come in it? While we know we have a sensitive political history with the colonization by the British and also the partition, but this architectural jewel perhaps shows us that if we work with each other's strengths, we can achieve harmony, and perhaps we can also achieve a gateway to new beginnings. I've always celebrated Dubai for being a man-made wonder. Soaring skyscrapers, excellence in facade and technology, stunning showcase of just human and building innovations. But the unmasking has brought my attention back to a topic of migrant labors and an issue that we all saw gain so much attention during the pandemic. The reports claiming that migrant labor is consistently being treated unfairly, perhaps passports being controlled, or other restrictions have led the speculations of the kafala system being an example sometimes of modern-day slavery. One of my favorite cities in the whole wide world. I've always seen New York as a perfect city. Look at it. It gives you the vistas of Central Park and so many other parks and the backdrop of this stunning skyline. But perhaps even I did not realize that the weight of over 1 million skyscrapers that stand on this island is weighing New York City down. It weighs 1.7 trillion pounds, and researchers are saying that the city is sinking every year by 1 to 2 mm. And like most metropolis, New York, 75% of city's carbon emissions come from the city's skyscrapers. I have an interesting animation here. It shows us one hour's emission of New York City, 1 day's emission of New York City, and 1 year's emission of the city of New York. Our very own Mumbai skyline. It boasts of so many unique, charming buildings. Each skyscraper has a story to tell of the city's resilience, of its innovation, and dynamic spirit, making the skyline not just a site, but a reflection of city's rich culture and ecosystem. Here, I did not have to unmask anything. I just had to zoom out. And when you zoom out, you see the reality that these beautiful buildings sometimes do make it easier to mask. Disparities and urban challenges. Yes, these buildings are something to be very, very proud of and to be aspired by, but they're also helping me distract from the striking duality and even the irony that perhaps most of the labor that built these skyscrapers live in the slums. The truth here is that when we do the unmasking, it's not to take away from the glory and the beauty and the magnificence of all of these facades and how hard we all work to make these facades happen. We do live in a capitalist world where growth is the focus, and we do have a stark contrasting truth around us. Poverty, social stigmas, political domination, power and money domination. This is our current reality. When I mask, then I forget, or I tend to forget, and I lose awareness. But when I unmask, I can design with much more awareness. Rather than suppressing or distracting myself from the contrast, we can embrace this contrast and learn to design in harmony with it. But sometimes, even being an aware or a sensitive designer is not enough. In 2017, I designed a building very close to my heart, ABZ. I chose to use an art installation which would help me hide the parking behind and tell a beautiful story. Tell a story of a topic very close to my heart, one of gender fluidity, gender stereotypes, age typecasting, body and skin tone shaming, and I was so proud of it that it stood for inclusivity. And then one day, while browsing on social media, I came across an image of my very own building through the lens of a photographer that I had never met. He had beautifully captured in his lens this photo that tells the story of modern India. And for me, that was unmasking of my very own design. Contrast life, he said. And I realized that this beautiful lady in this beautiful Nawari sari looked at my inclusive building and perhaps did not feel included at all. Because even my exposure of inclusivity is so urban. And that led me to understanding that there's more to do. There is more to design for as a sensitive architecture. And we do that every day through our approach to sustainability, through our approach to carbon emission. And yeah, this has reminded me to take that moment to reflect, introspect, and ask me, what is this going to make me as an architect, as a designer, as a citizen, as an onlooker, as a traveler? And next time I look at a facade, perhaps I don't have to be only mesmerized by its beauty, and I can unmask and see more. So thank you, Zach, for giving me this journey and helping me go inward and look more. Thanks.
Thank you very much for a wonderful presentation. I think it's probably in the last 147 ZAC editions, this is probably the most different presentation that we've come across. I think Ahad can speak more about that later, but that was absolutely wonderful. It was so different and something that we're not quite used to as an audience in the facade community, and I thought that was really touching. Thank you. Right, so next we have Mr. Rakesh Murudkar of RSM Designs, who's going to make his presentation. Rakesh, please.
Good evening, everyone, and Namaskar, Pune. Thanks to ZAC team to giving me opportunity to present today in Pune, and this was much needed in Pune, actually. Thank you. Today, my topic is in a planning stage, how to design a facade in a pre-construction stage, basically. Second point is consider the sustainable facade in terms of fire and smoke mitigation. And the third topic is aspects to observe to prevent air and water ingress inside the building. So these are my topics, quality, which just now I explained. So, to design any facade, ideally we need to integrate with the architectural and engineering process. This definitely ensures during the planning stage when we do any facade design, structural integrity, safety, and requirements and the functional needs, basically. So use of casting channel. So the use of casting channel, before starting my casting channel presentation, what is happening when we are using a conventional system of doing with the anchors. So this is the problem. This is the problem where you can see there are two anchors fixed in one line. Two anchors fixed in a bracket. but alignment of the bracket is side by side. This is due to it is fouling with the rebar. And the third image, you can see the anchor, how it has been drilled to the RCC. So these are the problems when we do the anchoring activities basically. So this is misaligned due to the rebar fouling and fixing in the skewed improper way. This is the fixing of the anchor in the post-tension slab. The red line, what you see, it is a post-tension line where the bracket sizes increases due to as per the requirement, near the post-tension slab, the anchor should not be fixed. So that is why this variation happens in the project due to these issues. So that is why we need to have to do the plan in a very planning stage, the fixing of the casting channels. So this is in a conventional slab what we generally, the method which is done. The stepwise it is given, the anchors are fixed to the rebars with that wire and welded also. Then the pouring of the concrete is done. This is the fourth step where the removing of, there will be a cover on the casting channel so that no dust or will get collected in that channel. Next is the T-bolt which get installed, and then the brackets are installed in a three directional movement. In this we get the tolerances basically. And the bracket is ready for the installation for the panels. So this is how we construction phase. This is in the post tension slab. You can able to see the tension tendon lines, and beside that casting channel has been placed. Now the importance, this is during the planning, because we right now know where the casting tendon lines are coming, so we can adjust the tendon line between our grids. So there where this is very much necessary during the casting of the slab. The casting channels can be laid easily. So this is how the measurement what we do, how to checking whether it has done in a correct way or not. This is for the deck slab or the steel buildings. This is something different type of casting channel they use, but it is possible in a steel buildings also. In a deck slab we can able to do the casting channel provision. This is a typical detail where you can able to see how the casting channel is installed. We have X, Y and Z direction given. So we have the tolerances in this. Accordingly we can adjust our facade grids. These are the difference comparison between the anchors and the casting channel. The edge distance for the anchors is due to the concrete slab finish. Hence, it causes cracks in the concrete basically. Edge distance can be maintained during the slab casting basically. And ETA certification of 90 minutes loading capacity is in case of fire. In casting channel we have 120 minutes. Here we need to spend a lot of time in drilling holes to achieve the requirement embedment of the depth in the concrete. In the casting channel we require a very less depth for the casting channel. Then it is a green building certified product. So this can be definitely help us in executing the facade. High mechanical properties, less facade grids can be freeze during the construction phase itself. The benefit of this, if a building is of 25 floors and it has been completed till the 12 or 10th floor, we can start our facade simultaneously, the facade and the construction can take can be enclosed together. This is just a video how the installation of casting channel is done. Sorry. So conclusion, the project cost control is there, quality is maintained, and better facade work. It is better to do the facade work to be carried out 80% at the factory and 10 to 20% at the site. Execution methodology and the sequences can be freeze to achieve the project targets. Next is our integrity of fire and smoke mitigation measures. The sustainable facade design requires careful consideration, ensure that both safety and environmental objects are met. Selecting the fire resistant glazing materials with fire safety requirements mandatory at the refuge area as per the NBC norms. Opt the material of the non-combustible and toxicity levels to minimize the risks in fire spread and smoke emission. So these are the points which we need to address. Slab edge fire stops and smoke seal at the floor seal. Then fire stops panel protection to avoid the leapfrog effect as per the IBC, that is International Building Codes, which will be soon implemented in the NBC. Vertical barriers and horizontal barriers at the partition locations. Cavity barriers at the passive fire protection. And fire resistant glazing at the refuge area. So this is one model what we I have created to understand how the compartmentalization and the passive fire protection is done. So this is the different facade elements what I have highlighted. Like ventilated facade, refuge area, office facade, VRV location, office facades, and the ventilated facade basically. So this is the location where the refuge area where we see the fire rated glazing is mandatory as per the NBC. These are the spandrel, fire stop spandrel protection. Then slab edge fire stop smoke seal. We have vertical barriers and the horizontal barriers underneath of the balconies. This is a cavity barrier. So if you see the passive fire protection at the ventilated facade location, fire resistant glazing at the refuge area, and compartmentalization at the office location where the fire is completely compartmentalized. So this is the vertical barriers what we need to have between the dead wall and the office area. This is as per EN ASTM standard and UL 2079. This is between office and VRV locations. This is the jam location. So this is a spandrel, typical spandrel location where the smoke seal is shown. This is as per EN IS standard 8190, EN standard 13664, and ASTM standard E2307. It should be at least 120 minutes. Movement cycling for fire starts should be performed. Same specimens should be tested for the resistance of the fire performance. Air leakage should be at least 1 CFM. Then we have the spandrel fire stop protection, where if you see the dimension, it is 914, which is been tested internationally as per IBC. And the right side, what you see, the spandrel treatment, which is a non-tested spandrel treatment, the leaf frog effect is directly passing to the upper office level. And the spandrel treatment, what at the upper video, which you can see, where the leaf frog effect is not there. This is a cavity barrier. This is generally used in a ventilated facade location. You can see the green color insulation, where and in the front of it there is a intumescent sealant which is applied. When the fire passes through this, so when the fire come into the contact, the intumescent sealant, the gap which is 25 mm, that is covered, and the fire will stops at that particular location, and it doesn't pass to the upper levels. Doing the right work first time, it's irrespective of being observed, being checked later. Actually, there should be a clear communication between facade consultants, stakeholders, then architects, facade fabricators. Methodology, statement, sequence, and facing of the facade element installation should be addressed properly. Quality assurance plan to be placed and followed strictly. Use of skilled workforce, preventive measures, important document as built to be comprehensive. This is two cases what I would like to discuss from the. This is a detail of a coping. On the right side, when you see, we had observed the coping when we opened it. There were no framings, no primary GI seals, no bison board. This is the point where the facade, the leakage can enter through the top surface, and the complete system will get leaked due to these issues. On the left side, you can see we have shown a detail of a coping with GI primary seal with having a bison board. Why bison board? Because anyone stamps on it or during the maintenance point of view, this sheet should not be bent. And plus at the guru locations, we do apply the cover so that no water or even the silicone which is eaten by the birds, so through that the water gets penetrated into the facade. So this detail needs to be taken care. This is the most important detail. Next detail is a detail of miter joint. If you can see a small gap in between the miter joints. This is the poor workmanship which will lead to water leakages from the windows frames due to the miter joints are not done very properly. So this is a small video which I want to show what can. This is just a gap. This is just a poor workmanship. What due to this, plus not a proper hardware which has been used. Not the gaskets are wear out. Then frames are not in aligned way it has been done. So these are the problems which can be faced. So these are the two locations which I had highlighted needs to be taken care. So one can minimize the work delays, cost overruns, ensure durability of the facade. Thank you.
Yeah. So thank you, Mr. Rakesh. Again, A very contrasting presentation from what we had first. From Pritika and now from Mr. Rakesh. So this is what I meant by storytelling this morning. Everyone has a different story to tell. Pritika's was more nimble, was more about how we look at facades, and now Mr. Rakesh was more practical in terms of what issues we are currently facing. So I think it's the best of both worlds. Next one is our event host. I thought he didn't want to introduce himself, so I thought I'll introduce him. Rohan Keswani from Aluplex would be presenting. This is my personal favorite topic, which is basically how do you glaze residential buildings. There's always been a concern of privacy, of integrating balconies, sliders in a high-rise residential tower. That's picking up residential construction. Glazed residential construction is picking up. I think Rohan is going to deep dive into the same. So ladies and gentlemen, Rohan Keswani from Aluplex.
Check. Thank you, Ahad. Thank you for the nice introduction and giving me an opportunity to present here today. So actually this topic I thought about actually when I was at the last ZAC conference. I think it was in Bangalore, and there was a panel discussion going on the dais over here, and there were people talking about facades in residentials, and somebody said, what do you mean facades in residentials? We don't have facades in residentials, it just has windows and that's what it is. How do you actually apply facade? I'm like, okay, fine. This is something that people aren't quite aware of, on a broader scale. So I thought, let me just present about that. So today I'm just going to present a few case studies of the several different kinds of facades that we have worked on in residential buildings specifically. As a company, we at Aluplex have been around since 1981, having completed more than 400 projects all across the country, right from Srinagar in Kashmir to all the way down to Kerala. So, from Calcutta to Mumbai, all over the country. We've done IT buildings, we've done commercial buildings, institutional buildings, and obviously residential buildings as well. The idea of, sort of incorporating facades into residential buildings stems from the idea that, as we grow taller, as buildings are, first we were talking about a 20-story building would be a high-rise building, and then it became 40 stories buildings, and today we're building 80-story buildings in Mumbai. And as you grow taller, it's very important to continue to maintain the facade. Having sort of patchy paintwork which sort of fades away after 10 years or 15 years, and getting to repaint that building in that stage. You can't erect a scaffolding on a 70-story building or an 80-story building. It has to be easy to maintain, it should be easily cleaned. And these are the kind of challenges that we have. Also, installing a facade on a high-rise building, it's very challenging to sort of paint that building. You can't scaffold a whole building. You can't have mast climbers all around, and then at the locations of the mast climbers, then how do you remove them? How do you paint it there? You can't have suspended rope. You can't have platforms over there. Can't have gondolas there, because end of the day, you experience very, very high wind loads under installation, and it can get dangerous. So these are the kind of facades, these are the kind of broad topics I'm going to talk about, some of the projects that we've done. So starting off with Omkar 1973, which is a high-rise development in Mumbai. This was designed by Foster and Partners. And very interestingly, what we have in this project is we have every element of the facade. If I just go back 1 second, is you don't see any element of any sort of painted surface on the facade. Every element of it, whether it's the curved glazed balcony, or whether it's the long balcony with the curved edges, or whether it's the columns, they're all sort of cladded with fire-resistant materials, such as A2 grade cladding panels, or whether it is, and the rest of all the balustrades, as you can see in this, are all unitized panels. So we incorporate, as you can see over here, that's the plan section and elevation of what a typical glazed balcony looks like. We incorporated the use of a unitized panel to to glaze this particular balcony. The reason we use unitized is, we didn't need to have any access from the outside. We had a bracket which was incorporated on top of the slab. We had a bracket on the underside of the slab, and each unitized panel was prefabricated in the factory. We had to sort of obviously bend the glass to a particular radius. We had to ensure that that the transims, which are the horizontal members of the panels, had to be bent to exactly the same radius without any tolerances in bending for either the glass or the aluminum, which was challenging in itself. And we went on to win a ZAC award actually, I think 3 years ago for this project. So these are a few of the pictures of installation of how the panels were being installed internally. You just had to install the brackets, and the panels would just hook on onto the assembly, and we had these glazed balconies that were installed accordingly. This is what it looks like now. You can see that you have columns, you have a, you have a window wall system behind, either sliding or a side hung casement door, a window wall system behind. And we have glazed balconies that were accordingly built with a unitized system. The column cladding over there had to be installed with the gondola though. But end of the day, the reason it was as such is because we wanted it to be removable, because there were actually rainwater pipes that were behind that, so it should be accessible in case of future maintenance. The next project I would like to talk about is Lodha Park in Mumbai. This is actually the tallest building in Mumbai in terms of that is completely received OC in terms of number of floors, because it's actually 81 floors that this building has, that actually in terms of number of floors is the tallest. The floor to floor I think is approximately 3.4 or 3.3 meters. So in this building, we used a unitized system, and in this unitized system, something that we did at that time, which was very different from the kind of systems available in the market, was that the side-hung casement window which was there in that was seamless. By seamless, I mean that you don't have a plant-on openable. You don't have an outer frame which is fixed to your mullion. So basically, we are talking about how does this work? Yeah. So basically, normally you normally you'd have a separate outer frame, and your sash would sit on that outer frame. But over here, you see it's all aligned, so you don't actually see a particular perimeter across your operable when you look at it from the inside. This is, obviously keeping in mind what the inhabitants really want in the building, right? So that's something that we did over there. However, the problem, which, most people complain about residents in this building, is that even though it's a high-rise building, they say, my operables, they are only open 200 millimeters or 150 millimeters because that's what's safe, right? You can't have operables that are opening completely 90 degrees in a residential building specifically. And so you have restrictor arms, and then you have customers who remove the restrictor arms because they want that sort of ventilation. They're used to having that kind of ventilation. Something else we really did interesting in this project is we incorporated passive ventilators. So below the operable panel, we incorporated this particular passive ventilator, which was this assembly, which had a particular open and close mechanism by which we could have air pass through without actually opening the window when you wanted ventilation, because you have very, very high wind load, especially during the monsoon season, and you don't want very, very high wind pressures actually affecting the inhabitants of the building when you're opening the window and you have things flying away. So you want the natural ventilation. At the same time, you don't want to open your window. So we incorporated this thing called the passive ventilator, which was below there's a transom which is below your operable, and a transom which is, so this is the whole detail which makes it very complicated, where we had a whole sunshade which was fixed right on top of, to cover these particular passive ventilators to ensure that there's no leakage that goes through. But I think Suresh was also slightly involved in this project at some stage during the handing over stage. So yeah, it's a very interesting project, but moving on from there. This is a project that we started, I think, a couple of years ago, post-COVID. This is the Trump Tower in Calcutta, and the brief from the client and the architect was very simple. Morphogenesis that was actually involved in this project, their Mumbai office, and was that they wanted a completely glazed building. They wanted to have a look and feel of a proper glass building, yet they wanted the inhabitants to have good ventilation. They didn't want a system where you had your kind of system where you couldn't quite open your windows, they didn't quite have the natural ventilation you would otherwise have. And on the dead walls, they didn't want any paint. They didn't want to see any sort of paint on the external wall anywhere whatsoever. They wanted to be finished in a particular cladding element or a mesh or a glazing element. So this is a partial part of one of the flats, and as you can see that even where you have dead walls, they were cladded with glass. We didn't use a unitized system there to save cost. We used a ventilated rain screen system where we had glass as the infill panel in a rain screen system. It wasn't using sort of a cladding material, it wasn't using terracotta or Fundamax or something of that sort. We actually used glass as the rain screen element on the dead wall areas. And in the vision areas, obviously we had glass as well. And we had something which was very important to the architect at the time, was that they did not want any sort of framework, aluminum framework visible to the even at the location of the sliding windows. So we developed this detail, which was very different at the time, is where we had a structurally glazed sliding shutter. I think that was the first time that anyone in India had at least used a structurally glazed sliding shutter. So what we incorporated there was, as you can see, on the left is the interlock profile, where within the unitized panel, you could see on the left-hand side, you have the fixed panel, which is a regular glazed panel. And on the inside, which is where you have your track, is where we had a sliding shutter. And the sliding shutter was also structurally glazed. In the sectional detail that you can see on your right, you'll see that there is a transom. And that transom was also, because of the high wind pressures and the performance that we needed, we built an inbuilt drainage within that particular transom itself, so that the water would drain out through the groove of the glass, rather than having to drain out from the top of the track. And also we had to use the step glass over here, as you can see. But that's what created that kind of look and feel where, you can see the building now, a few sliding shutters are open, the rest are closed. You can see how seamless it looks. You can't quite see any framing members whatsoever to give you that complete glass feel. This is a project which is over here in Pune called Voyage to the Stars. This is at the process of, currently they've done a few towers and a few towers are under installation. Very interesting project over here. Over here, what we had is we had a sliding system, sliding doors incorporated within the unitized system. This is the stack joint at the floor level, as you can see. But we had a railing which is on the outside. So a glass railing incorporated on the outside. And the way it worked is that we had a particular drainage, the gutter section, which is your head profile of your unitized system, incorporated the tracks. And those tracks had the necessary weep holes, drainage slots to drain out back into the gutter profile of the stack joint to drain out regularly from there, so you wouldn't have any sort of leakage issues whatsoever. That's the sort of, you saw earlier, that was the sectional detail of the stack joint at the floor level. And over here, as you can see, is we have a very interesting system where we had, where these tracks were at the back, as you can see these tracks over here. So between each unitized panel where you would normally splice, we had a connection track, kind of a splicing connection track, which was also sealed, like a splice connection, which would allow your shutter to roll over from one panel to the other. So that would allow you to slide your shutter from one panel to the next, without having to have a larger unitized panel and having it slide. So this project is, nearing completion. I think few towers are done. I think 1 or 2 towers are left to complete. This is a project which is very close to my heart, and this is a project that we've recently, on the verge of handed over one tower, a second tower on the, on the verge of handing over, and the third tower is just about to commence. Rustomjee Crown is a project in Mumbai and Lower Parel, and this came at a time when post-COVID, etc., and people were at home, etc., and they weren't quite able to get that sort of natural ventilation that they wanted in these high-rise buildings like Lodha Park, as I mentioned earlier, or India Bulls, or whatever else existed at the time, especially after the new DCR rules came in, which they weren't allowed to have balconies, or it was very expensive to have balconies, so they stopped having balconies. And what they incorporated over here, what we incorporated here is a very interesting system where we had this spandrel panel that was installed at the beam level first, independently. And then we had a very, very large unitized panel. We had some small vision panels on the left and right, as you can see over here, these vision panels. And when we had a very large unitized panel, which is approximately at most, the largest was approximately 7 meters in length, which was by height of 3 meters, which is only the vision area. So there were 2 stack joints that were installed in every unitized panel. One stack joint coming on top of your slab, and one stack joint coming on the underside of your slab. And then once the panels were, the vision panel was installed, which was your track panel, the sliding shutters were put in place. And then we kept going forward, moving onwards like that. And then we had an internal railing, which was then installed internally. So this is what the stack joint detail looks like over there. As you can see, this is your floor level. And we had a very interesting design where we had a sill. The sill profile had the tracks installed. And as you can see is, this part is where your sliding shutter would slide. And over here, as you can see, is this is stuck. Oops, back. Right. And as you can see over here, we have a fixed glass, which was installed at the, one second, yeah. You had a fixed glass, which was installed over here, as you can see, right? And then you had the tracks, which were installed over here. The idea was very simple, is that, it had excellent drainage. We tested it. And I have a little that's the basically, I have a little video to show you. We made a case study on this, and you're going to have a look at that.
Aluplex has been at the forefront of the facade and fenestration industry over the last 40 plus years, and we've completed over 400 plus projects to date. And I take this opportunity to thank the building fraternity for all your support over the years. With the advent of urbanization and the scarcity of land, we at Aluplex are happy to share with all of you that we've completed over 10 towers, 250-meter high. In fact, at this moment, we are working the facade project of the Rustomjee Crown.
So Rustomjee Crown is one of the most premium projects in Mumbai. It's a super high-rise project. The most unique feature of this project is the facade. In the West, the high-rise facade system have greater reliance on artificial ventilation and limited natural ventilation. It was Mr. Irani's idea to give a continuous facade which is openable to give that feeling of openness like a deck or an open terrace. This is something that has not been done in India.
This was made possible by innovation in design, engineering and construction by incorporating large sliding doors without compromising on the high performance of the unitized glazing facade. This has never been done before and posed a unique challenge. This bespoke design facade system was tested in a performance testing laboratory rigorously. The largest panel on site was 6.5 meters wide and 3 meters in height, and that was a logistical challenge. Aluplex organized the production, the dispatch, the unloading, the vertical movement, and subsequent installation to work all in sync to ensure there was a continuous flow of throughput. In case a bottleneck was identified, we ensured they were eliminated by adding additional resources of manpower and machinery to them. We had more than 350 labor working at various locations for the project.
I'm glad that we were able to finish this facade in a record-breaking time. With the teamwork between the Rustomjee team and the Aluplex team, we worked together to ensure that we were able to deliver a superlative product.
Thank you very much, ladies and gentlemen, for your time. I ensure that I was on time because I need to ensure that we're on time. Right. Thank you, ladies and gentlemen. And we have next Mr. Faisal Ali Dastagir from Viva Composites going to talk about his product. Thank you.
Good evening, Pune. Hello. Good evening, Pune. You can give me a better good evening. Good evening, Pune. One man sounds louder than the crowd. Okay, so today I'll be presenting on moving towards sustainable facades. That's my topic. But the core area of focus is going to be on what we are looking at, innovations in metal cladding. So if you look at the topics today, we have coil coating standards and paint technology. We'll understand a little bit about it. We'll not deep dive into it. We have customization of shades and textures and exciting sustainable products. That's the topics that we're going to discuss today. Before I start into the topic, a brief introduction about the brand I represent. I represent Viva Composite Panel as National Head Projects. We started our journey in 2003 as a trading company, and in 2014 is when we got into manufacturing. Today we have 20 warehouses pan-India, and we have offices internationally in the US, in Qatar, in Dubai. We are represented in Sri Lanka, South Africa, East Africa as well. We make high quality ACP fire resistant, antibacterial self-cleaning. That are the value additions we do to ACP. And we have Asia's largest plant with 12 million square meter of production. As you all know, ACP is basically a material that has been in the industry for a long time now. All stakeholders here will agree that you've been using ACP for the last 15, 20 years. It's a good product. It's a sustainable product. It is highly durable, easy to install, cost effective. Today it is safe to use, I can say, with all the fire certification that we've done. It is maintenance free, it's versatile, it is customizable as well. Customizable in what ways? I will also explain on that. Today Viva proudly but very humbly says that we have 12 production lines and 3 coating lines in Umargaon, Gujarat. And we are among the 5 largest facilities of metal composite panel manufacturing in Asia. if you even consider China to be a part of Asia. If you remove China, then we are the largest metal composite manufacturing facility in Asia. We have a great variety of shades and textures that we have, that is 300 plus. If you come to our booth, you can have a look at it. A great network of 500 plus dealers, distributors internationally as well. And cutting edge technology, and what is the technologies that I'm going to be explaining in today's presentation. Let's understand a little bit about the basics of coating. Coating for external application or for application in facade is governed by a standard called AMA 2605. I'm sure most of you sitting here are aware of AMA 2605. If you're not, I'll just explain. AMA 2605 is a standard that governs coating on surfaces for external application. Just putting the slide on hold, I would just like to explain a bit about what happens when you coat a metal surface and you expose it to an external facade. Let's understand that. Let's presume there's a building that is facing east. So the sun rises in the east and it sets in the west. So your cladding material is taking in a lot of UV. UV that reaches the planet is only 2% of the UV that the sun emits. But that 2% of UV is enough to tarnish your metal or to deteriorate your metal. Now, if you drive around a city and you find that there is a lot of metal cladding that has faded over a period of time, and it is not at the real color it is, the reason is primarily because a paint that is not UV resistant has been used. I'm not trying to mention any paint, but I'm just saying a paint that is not UV resistant has been used. If a paint that was UV resistant was used, the metal, the coating on the metal would have not faded. Meaning which, if you use a polyester paint, polyester is a great paint. Polyester or super durable polyester is a great paint. But the molecular structure of polyester doesn't allow it to be UV resistant on a pure external facade application. Meaning which, on a mullion, if you do a polyester coating, it is fine, it will sustain because it's not directly exposed to sunlight. But when you do it on a facade, it is bound to deteriorate over a period of time. Let's all understand this. UV is the main villain. If I portray in a cinematic expression, then UV being the main villain along with smoke, dust, pollution, salt, all factor into the deterioration of a paint. So if you buy a red car doesn't remain red, it deteriorates. The red tends to become pale after a period of time. So the coating demonstrates an exceptional resistance to color fading, chalking, gloss loss. So these are the things that AMA 2605 very clearly goes into. And it recommends, it recommends the use of PVDF paint or Lumiflon paint. PVDF is polyvinyl difluoride and Lumiflon is FEV, which is vinyl ether. So these paints have a molecular structure to take on UV resistance. So if you basically understand coil coating in terms of ACP, when we say a 10-year warranty product on ACP or any BOQ mentions 10-year, that means you're talking about a 25 micron coating, which is 2 coat and 2 bake. Please understand, any coating that is put on a metal surface has to be coated. Once it is coated, it has to be cured. When I mean bake, it has to be cured at a precise temperature. So when we do a 0.5 coil, when we bake at 251 degrees Celsius. It's a precise temperature. Excess of temperature leads to chalking, lesser in temperature leads to flaking. So you have to be very precise. Now when you say 15-year warranty, we mean 32 micron, 2 coat, 2 bake. When I say 20-year warranty, it means 35 micron, 25, 40 micron. So it is very precise. But Viva, as an innovator, now we are trying to do a 15-year warranty in 2 coat, 2 bake. Previously, it was 3 coat, 3 bake. Again, an innovation. This has led to a lot of new series that we have in our collection today. We have things like Natural Stone. We have Metal Abstract series. We have Tarnished Metallum, that is metal finishes. And we recently launched this textured tile finish called Santa Fe series. We also have a new series that is called D Madeira. You can see some samples which are textured veneer ACP again, which is very new to the industry. I'm not touching on FR certification or FR certificates this time because I've spoken a lot about it in my previous ZAC presentation, so I said I'm going to keep away from it. But one point which I like to highlight is, when you look at an FR product, please check on these two things: that is your product certified or is your product tested? Be it any standard, be it an EN standard, NFPA 285 or an ASTM E84, please ensure that the product is certified and the plant producing the product is under an audit. This is a very important checkpoint for all stakeholders sitting here who want to use fire retardant material. Okay, let's get into innovation now. So the first innovation we started was ACCP, corrugated core panel, where we replaced the mineral core from a fire retardant ACP to make it 100% non-combustible. So when you have 3 layers of aluminum, like it's shown here, the product is basically non-combustible, completely non-combustible. This was the first innovation. Second, we started making honeycomb panels, 12 mm and 25 mm, which are high performance cladding panels, which have a thermal saving as well. At the time, they also dampen sound as well. The most important innovation that we are coming is basically called solid aluminum sheet. You all must have used a lot of solid aluminum sheet in your projects, but this is something else. When you use a solid aluminum sheet, you basically make a tray and then you coat it. So it's a vertical coating process. But what we are going to do is we are going to coat and then bend. So in the month of August, we'll be out with this product. We all in the process of commissioning a line that is almost 350 meter in length and 60 meter in height, that is going to coat 2 mm and 3 mm solid panels horizontally. We can go for any shade, any texture, any finish, and we will coat and then bend. So we're getting the entire setup. So when we give the product, we'll give it to you as a ready-to-fix panel at site with whatever measurements you have. So the very exciting product that is coming up in the month of August, we'll be in a position to supply. Again, a very interesting collaboration today we have with the world leader called Aloxide. They are the world leaders in making anodized coils. So what I was speaking about is PVDF. I was talking about Lumiflon. But this is anodized coils where the coils undergo anodization. So basically, if you go to Aloxide website, they will mention it as a lifetime warranty product. They don't say 40 years, 30 years. They say lifetime. So this is a lifetime product. We're buying the coils from Aloxide and we'll be making ACP out of it. This comes with a default alloy of 5000 series, which is a marine grade alloy. Next, zinc composite panels. Today is becoming a trend. You're seeing a lot of airports, a lot of public spaces, large buildings having zinc composite panels. Rohan presented the ARC. I think so ARC also had zinc composite panels in it. We tied up with L-Zinc, the leaders in zinc composite panels from Spain. We're buying the coils from them. The advantage what L-Zinc has over other people is that they make coils with 1220 and 1320. Vis-a-vis zinc composite, zinc coils come on only 1000 mm. So L-Zinc has a special size of 1220 and 1320. Again, very interesting product we have here. This is a product that we age like zinc. This is a copper solid sheet of 1 mm, 2 mm and 3 mm. We call it faces because it has a face of aging. It starts as copper and ends up as patina over a period of time. This is a 1 mm or 2 mm solid sheet which has 10% of the top layer as real copper. A very interesting product which can be used in a lot of hospitality projects. You can use it on your facade if you want something that you want to age with. This is where all the magic happens. This is our plant at Umargaon in Gujarat near Vapi. It's an IGBC certified plant. You can see we generate solar power as well. We have a paint mixing unit. So all the paint, textures, shades, what you see on our products are all formulated in our plant. We closely work with all leading paint manufacturers to achieve what we achieve. 3 coating lines. This is the first of it. Second, 5 feet coating line. One of its kind in India. And this is truly one of its kind in India because it's a 3-coat, 3-bake system. One of the most advanced coating lines in Asia. 4 lamination lines for making FR. 1 lamination line that makes A2, A2+, 12 mm honeycomb, 25 mm honeycomb, a specialized line making specialized products. This is version 2.0 of Viva, where we have 2 coating lines, 2 lamination lines, and an A2 core line for the first time in India coming up. This is a land parcel of not 42 acres, it's 52 acres now. We've taken another 10 acres. And this will be developed phase by phase. The solid aluminum coating line is going to be housed in one of those sheds which you see there. Some interesting projects what we have done till now, and this is one of our oldest projects we did with Glasswall in the year 2021. This is at Koinur Tower where we used A2 Plus corrugated co-panel, innovative product. This is a nice project which we've done in Mumbai with FR Class B. This is one of our large projects in Pune for Rahejas. We do pan-India. This is 30,000 square meter and growing. IT Comozone. Global Street Mall in Pune, again a very nice looking project. This is one of our challenging projects where we had a zinc field created on ACP. So this is not real zinc. This is a zinc field that has been created on ACP. Because of shortage of time, lead time, the clients wanted zinc. So we had that challenge, but we took it up and came out successful. We're now doing the 3 towers adjoining to this, which is almost 23,000 square meter of additional cladding. This is 10,000. One of our oldest projects we did in Pune, our initial projects we did in Pune, Westport, which has our metal abstract series, cotton steel series, magnificent looking building. This is a challenging project we did with corrugated co-panel in Nasik. A large project where we customize the base shade. What you see is a customization of a particular shade as the developer wanted that shade for Phoenix Turner Group in Hyderabad. A couple of projects which we have done, we've done many now in Qatar. We've done the F1 Lusail Circuit, we've done the Hamad International, but I featured 2 projects which we did initially in Qatar. And an interesting case study before I finish my presentation. This is a panda enclosure at the Al Khur Zoo in Qatar. So we were given this challenge by big architects from New York. They wanted us to develop a bamboo shade, which you see here. This is the specification that they had given us. So we took up the challenge. We had no confirmation of the job. We did a prototype. So please understand, whenever we do a prototype, we have to quote thousands meters of coil before we run a prototype. So a lot of money investment into it. We took it up. We had no surety it would get approved. But eventually it did, and we supplied the project. So thank you so much for being a wonderful audience. Thank you.
Thank you. Next we have Mr. Jun Miyazona from Panasonic KMEW.
Thank you all. I've just arrived to Pune the day before yesterday. Not today, not yesterday, but the day before yesterday. Because I'm Japanese, so very punctual, so I cannot be late, okay? And now in Japan, it's very long holiday, like 10 days called Golden Week. So yeah, everyone is taking rest. But I have to work because I'm typical Japanese, okay? So today I'm going to give a presentation about innovative options for building facade in India. My name is Jun Miyazono, and the company name is KMEW. K stands for Kubota, which is a Japanese agricultural machine company. And M stands for Matsushita. Actually, Panasonic's founder name is Matsushita. That's why we have 2 parent company, Kubota and Matsushita, which means Panasonic. And E stands for exterior, and W means works. So KMEW. It's very difficult to pronounce, so please just call me Jun. So nobody like this kind of situation, like fading and stains, okay? Of course. Then last time I came to India for the first time, I really got surprised and impressed because, you know, there are lots of beautiful and wonderful exterior products. So I really got surprised. But I think our function of photocatalytic coating will be maybe benefit for you guys, it's kind of unique feature. So again, Panasonic cladding with photocatalytic and ceramic coating. So this is kind of summary of our products. Our product is made of cement and fiber cement, and we have colored layer like blue, black, gray, something like that. And after that, we apply ceramic coating, which is for UV resistant, weather resistant, and after that, photocatalytic coating. So that dirt decomposition and something like that. So there is a movie about photocatalytic coating. So just let's take a look. Oh, just a moment. So, okay.
Have you ever heard of photocatalysts? This powerful accelerant drives a chemical reaction that causes dirt and grime to detach from a treated surface with sunlight and rainwater alone. Let's take a closer look at the secret of photocatalysis. Dirt decomposition. When ultraviolet rays strike titanium dioxide, electrons are ejected from its surface. The ejected electrons combine with oxygen to form the reactive oxygen species, superoxide anions. As a result, the holes on the treated surface through which electrons are ejected become positively charged and strip electrons from water in the air. H2O molecules deprived of electrons become highly reactive hydroxyl radicals. These superoxide anions and hydroxyl radicals work together to strongly oxidize and decompose dirt and pollutants, as well as bacteria, while weakening the adhesive bonds holding the oxidized and decomposed substances to the coating layer. Superhydrophilia. When titanium dioxide is exposed to light, it reacts with H2O in the air to form a film of highly hydrophilic hydroxy group on the coating surface. These hydrophilic groups are easily absorbed by water, including rain. Water makes its way under the dirt and lifts it up, powerfully washing it away. Antiviral, antibacterial properties. When ultraviolet rays strike the photocatalyst, the free radicals that are generated decompose viruses and bacteria that adhere to the surface. Air purification. Furthermore, the decomposing power of the photocatalyst detoxifies exhaust gases and other harmful substances in the air. Let's compare cleaning effectiveness for a surface with a photocatalytic coating versus ordinary wall material. Dirt is difficult to remove from conventional wall material. But when a photocatalytic coating is present, cleaning is much easier. Photocatalysts are being used globally, such as the Glass Pyramid at the Louvre Museum and the AT&T Stadium in Arlington, Texas.
So, as you see the video, photocatalytic has some features like dirt decomposition, superhydrophilia, and antiviral, antibacterial properties, and air purification also. So next topic is about ceramic coating. So as I said to you guys, it has a UV resistant. So if organic coating, like even in Japan, a lot of products are applied with organic coating, we have to paint again every 10 years like this. But our coating is have long-lasting beauty, like more than 30 years. This is just data, but we also have evidence about this. This is actual case. The left part is new build, and the right part is 14 years later. Looks same. And this one is new build and 31 years later. This is typical Japanese old style, so not sophisticated right now, but it's just evidence, okay? And 25 years later, 24 years later. So, plus we have some portfolio all over the world. Let's take a look. This is apartment building. This was also apartment building. Those are US market, from US market. So we can install horizontally and vertically also. This one is commercial. No, offices. This one is multi-purpose facility. This one is detached house in Japan. So actually in Japan, now until today, we are focused on detached house. Now we are changing to commercial and high building. This is also Japanese house. So we have a lot of textures and shades, like texture, like stone, like cement and wood, something. We have more than 500 shades we have. This one is called Fierté. This one is #1 sales in Japan, this product. So you can see over there, outside later. This one is also detached house. This one is also commercial. And we have an interior design also. So, but now we are focusing on more facade because this event is facade event, okay? So this is kind of last style. So we are Panasonic cladding and innovative options for building facade in India. I think in Japan, it has long history, like more than 40 years. But when it comes to India, it's still new. So I think our product will be the competitive for you guys, maybe. So please just remember our product, Panasonic cladding. So I just added this slide last week because last month we passed EPD also, Environmental Product Declaration. So, okay, that's it for today. Thank you so much. Thank you.
Kinglong, Dakshil Bhavsar from Kinglong.
And all. So this is my first time to present at here. And first, I would like to say thanks to the team of ZAC, World of Facade, those who have arranged this event and in Pune itself to bring a networking at higher side and do a business with our Pune clients, right? So I'm from the Kinlong, working as an area sales manager and taking care of the Pune region for past 4 years. So today I will be cover the topics like diversity in the facades, like what are the hybrid structure we are working and we are Kinlong are dealing in the market. Next, advancement in the facade system and current market trend which are available in the globally as well as for the Pune market, right? So before to go my topic, I would like to give a brief introduction about the Kinlong. Kinlong is basically from the Chinese company. This is the first Chinese company who is dealing in the market with their own brand. Like in the globally, we are present about in the 65 plus countries. And if we talk about the India, we are having 25 plus offices in the pan India and total 5 plus warehouses in the India. So how we did this because of our product strength as well as the support from our clients. So basically, this is the lab which we found in 2003 in the China. Step by step, we have started to increase and learn from the market. So in 2019, we got the first NCA approved lab, and nowadays we are the world largest lab in the field of construction hardware. So test certificate, see, whichever the products we are manufacture, it's required some test certificate that we call the MTC. But somehow public are not providing or some are providing. But if you can deal with the Kinlong and you people are going to buy something from the Kinlong, it might be a screw. Still you will get the MTC from us. Now we are having the MTC, like we are having the test certificate, is the national test house from the government of India. NCA lab, that is it's our own lab testing. And if the projects required to do a third party test at the site, we are flexible to do that too at your place. So Kinlong called as a one-stop solution. Why? So basically we having the products range for your interior, for your facade, for your door and window, for your each and every products. So actually Kinlong have a 20,000 plus products range for the articulated solutions. So come to my topics. In the curtain wall system, the basic structure or the system which we knows about, that is stone cladding, metal cladding, glass, ceramic plates, and photovoltaic. I will basically talk about the glass because we are the main supplier for the glass hardware, right? So in the glass, we just know that is steel structure, fin structure, and cable and mixed structure. So if we see in the market, what is the traditional products or what is the traditional curtain wall systems. So first is the spider with the MS structure, right? So in which, what will be happen? Your visibility will get reduced due to the MS structure. Curtain cantilever structure, like if you are going with the fin structure, it again reduced your limitation to make height about 4.2 meters. Suspended fin structure, it's affect your fin size and the thickness of the fin. ACP is the normal one which we are dealing. And last one, curtain wall with the fish mount structure. So basic parameter, what we suggest, what we Kinlong people suggest, when you are going to select your curtain wall or the facade. So there are the two stages. First, if your existing or slab has been done, or the stage you are at the ground. So we suggest you have to finalize your facade or curtain wall at the ground itself. But still in the market, it's not happening. So to deal with this, we suggest you have to at least focus on this particular 9 parts, which are that supporting structure, distance between the two glass and the main structure, why it's required. So we have to check that part. Then what is the size of your glass vertically and horizontally? Is your glass thickness is actually passing the technical parameters or not? That we have to check. So if you can check, I have mentioned this 3 diagram. It's made up in the SAP. So we Kinlong suggest whatever you are dealing, you just share to us. We'll update you or we'll let you know, is your design or is your curtain wall structure is safe or not? If your facade is safe or not? So we just calculate the reaction stress, which at point your facade will get fail. So I would like to discuss more about the hybrid structure which we have, in which we deals in the cables facade, right? So in this we have to confirm that is tension element which can use the tension to your facade. See, if you go with the facade tension cable, so there should be, you can manage your deflection in the your facade as well. Next, support structure. The point which we are supporting these cables, it's the main part. And the last one is material durability, which we are giving to you. So if you can check, I would like to say, we are just proposing these cables to your facade. This structure can be fitted behind our whatever the facade you are going to develop. This is the production line which we have, and under which we are just manufacture the cable maximum diameter about 160 mm and the tension rod with 220 mm diameter. So one of the case study I would like to discuss here. This is the Venus Stratum project, which is located in the Ahmedabad. We have did this project. The height of this curtain wall is about 28 plus meter and width is 15 plus meter. So if you can check, this is the back side of our facade. So it's very sleek. If you go with another curtain wall or anything, that width has been longer one. So that's why we suggest you can go with these products. Next, what is the best benefit of this part? See, if you can check that clamp, right? So while you are using your spider structure, you have to cut out the holes at the corner of your glass at every point. But here, you don't need to do any glass process. You just have to rest your glass on this surface and tighten it. So let's move to next. What is the future ahead to us, right? So advancement in the facade, I would like to just show you. That is the dynamic facade, right? See, we have just utilized the dynamic wind pressure, which is naturally available, and it gives a leaves to your facade. So if you can check, every part is moving and giving the best view of your facade. So what is the concept behind it? So it's just simple concept, like there are panels, clamps, and holding devices. It's just simple like this. So if you can check, before wind pressure, all the panels are settled down. Once the wind pressure starts, all the panels get started to move. So I just talked, that is panels, flat plate, clamps, which used to revolve this panel, and a support structure, that is cable support. It's the base part, but sometimes according to project requirements, we have to suggest either cable or either steel structure. So in the panel, we having a lots of process, like we having some panels with the flat, with perforated panel, and some irregular shapes we can do in this. Next, that is the metal lure. This is also one of the new product for the facade. It gives the full aesthetic view and makes your building a beauty. What is the next level of the digitalization in the facade? See, this era and this decade are wholly depends on and utilize the digitalization part, right? So if you can check, we having this facade glass as well as some to utilize behind your existing facade. So what will be happen? In this video, you can check, you will get some advertisement, as well as you can run any videos at here, and also there will be the transparency behind exterior as well as your interior. So this is the next level of the facade which we King Long have. This is the currently trend in the Europe as well as in the China itself. And basically, I would like to say only the two companies are there in Asian market, those who are manufacturing this kind of system. One from this, one is the King Long. So this product is the very feasible, easy to install and workable as well. So we suggest 25 years of warranty for our LED displays for this. So what is this actually? So this is the 3D SMT technology which Nextnova has been did, and we have invested our lots of money and efforts to design this to give a best performance pixel to your facade. So how this technology can be worked? See, RGB LEDs. RGB is the red, green, and blue. These three colors are the basic which can make any kind of color whatever we require. Just what we need to set the specific intensity, what we have to make, or what is the output we needed from this, right? So, see, whatever the distance, now the question mark comes in this digitalization, how can we decide this pixel size, or how many pixels are required, the grid size of our panel? Lot of the questions comes in your mind. It depends on the structure, or it depends on from how long you are looking to view and how feasible or how visible view you want to show up, right? So basically, it's a part of pixel. Next, in the Topang, see, I would like to come up back with our trending market, that is unitized glazing, right? So I think so, whatever I have did and I have worked up in the market, Kin Long only the company which having the 30 inches friction edge, who's having the 200 plus kg capacity. And recently we have did the project of 2.6 meter height and 1.5 meter of width. And the total weight of the panel is about 170 kg. So, if you go with the parallel hung, nowadays in our Pune market, this parallel hung window is coming a lot of new requirements to us. So, for the parallel hung window, we are having a 42-inch hinge with 200 kg of the capacity. Sorry, 160 kg of the capacity. Next, again, I would like to introduce to your existing, what is the trend. We are just traditional facade. For the traditional facade, we are again help you to go for the smarter window, right? So, we are helps to you to do your window as much smart as possible. So recently we have did one project and we have just finalized with L&T to say, to serve them 500 plus smart Topang window, in which you just operate by its remotely. So I would like to mention some projects which Kin Long has been done in Pune. So as sir informed, this is the ARC in NIBM, Solitaire World, then Amar Tech Park, KWT, most popular project at the Swargate, that is Avante by ABIL Group. With our clamp system, we have did one project in Hinjewadi Phase 3 near to Yash Technology, that is ACZ projects. What the society work Kin Long is doing, right? So as a part, we would like to say Kin Long is dealing with a good with society as well. So we are having a Hope School in India, in the PAN country as well. So this year we are planning to do a 10 plus Kin Long Hope School in the PAN India. So thank you so much. Thank you.
Thank you very much, ladies and gentlemen. We have our last and final networking break right now, coffee break, before we recommence for the final session, which has a very interesting panel discussion with some eminent speakers, some eminent panelists who are architects, facade consultants, developers. So everyone, 50 minutes is our networking break and coffee break. So welcome back, ladies and gentlemen. This is the last session of the day, where we have one presentation and we have an excellent and interesting panel discussion. We have Mr. Manish Bankar from Tau Architects, who's going to deliver his presentation first, followed by a panel discussion which is going to be moderated by Mr. Shyam Raghunandan of Shuko. But to kickstart the session, Mr. Manish Bankar of Tau Architects.
Hello, good afternoon. I'm sure you all had a wonderful day so far, and I'm glad to be in front of all of you here with a wonderful audience. I heard a lot about what has gone so far during a day. A few things I missed out in the morning, which I'm sorry to Zach, but I'm very glad to right now come across here and put some of the thoughts on the facade. I mean, of course, Zach covers the facade, so it's primarily the subject, but there are a lot of things which are connected with the facade, and especially when, as an architect, when you see facade, how do you see that? That is something which I said, that will be the subject called facade seen from outside, but experienced from inside. So this is a topic which I'm going to cover up. Just to sum up, what has gone so far, I'm not much aware about it, but I'll see that we touch upon some sensitive aspects of facade. So anyway, this is, I'll just quickly introduce myself because I don't know whether everybody knows, but I passed out from Gujarat as a IED, that's the Institute of Environmental Design College, and I did my thesis on organic architecture. I studied works of Frank Lloyd Wright, and during that studies on organic architecture as my thesis, I came across architect Nari Gandhi, and he somehow guided me to push my limits and see that I read a lot and come across some of the good work. And in the end, from Gujarat, after having my thesis complete and a degree, I came to Pune, settled down in Pune, attended the Osho Community International for 3 years as my apprenticeship over there among many architects, engineers, and designers who were working, there as a part of Osho Community International, which was getting developed at that time in 91 to 94. And my hobby is, of course, of sketches. I travel a lot and somehow try to learn as an observer while doing the travel and sketching and photography and stuff like that. And I enjoy learning through observing. And whatever you see outside is something or other as a facade, either the people or the building or the streets. And you are constantly among facades through which you walk, and you enjoy seeing things a lot more in detail. And this is something which we are fortunately trained as architects. And sketching is one of the best tools to really learn. Like this is one of the streets which we actually observe. And this is the first building we designed in 95 as to start our practice. Almost now 30 is about to go. This is my studio where we actually combine our efforts and generate some interesting processes of work. And some of our quick projects which we are actually engaged with. So we do architecture, interiors, we do hospitality, we do institutional, corporate, residential towers, and some of the high-end villas. But today is a day for the facade, so I'm very glad to really touch upon that subject, which even I did not think. Thanks to Zach that, we architects are constantly engaged with the project in large, but to touch upon the facade was very interesting, to see as a... Okay, I don't know how many of you see this, or you might have come across this diagram, drawing. It's a building, but upside down. It is right under the ground. So there is no facade, okay? But the building exists. So I thought today I'll pick up this picture as the step well, which is very much in Gujarat, where I grew as a child around this place and always got fascinated about architecture without seeing the building. But you enter into the little step well and experience the beauty of the construction, the technology, the climatology, how everything got integrated into the building. And what you see inside is the inner facade, not the outer facade. And it's something which always fascinated me, that the buildings are a lot more to do with the indoors. And this is how I felt that every architecture, especially in the historical buildings, when you see, the facades are simply the outcome of what you are, what is the purpose of building, which is being served inside. So, to me, facade is simply an outer expression of what is happening inside. And that is, suppose this is the Himachal project, okay? And it's a very old structure. If you look at it, the buildings are designed to meet the climatic conditions. They are much more thermally insulated. They're made of the mud bricks, the wood, and the kind of, it looks like it's a very insulated place. And you can feel what is inside happening. I mean, of course, it's actually to its nature, and the overhanging roof, because there they have snow, how the snow will melt, the drip, it will not touch the building surface, facades. So the facades are well taken care of and thought of. Other extreme, when you see the coastal areas, that you see the buildings which are having long overhangs. You don't see the facade of a building except the roof. But that is meant to be that way to actually attain how the heavy rains would hit the building and still protect the spaces inside. And in the desert, you have another kind of facade, which is also true to its nature. It is built, meant to serve the purpose where they have jalis, so the light filters, air filters, the temperature filters, and somehow keeps the inner spaces much more cohesive. So facades are not only the mask, they are rather the expression of what is actually being built inside. And this is what I see as a character of facade which we need to get absorbed with. For instance, on the left-hand side, what you see is the Sonam Wangchuk, who's doing experiments with the structures in Ladakh, which is a very cool areas, and how the buildings are being developed. In the section, when you see the south side where the sun rays, it retains the heat inside and doesn't allow, basically it gets allowed the heat to get trapped inside, and insulation is done on the side so that the heat would not just simply come out. And this is how the buildings are being built with the mud technology. So the facade is, to me, what you see here is the engineering aspects integrated with the building design. On the other side, the structure which is there as this is by Gerard in Goa. So it's again a very coastal area, a lot of rains. The structures are designed to actually meet, though they are contemporary, but they actually meet the standards which you require to protect the building from the heavy rains. It's a lot more open for the humidity, so the cross ventilation happens, and a simple RCC and brickwork structures. So facades are simply, again, not something which is layered on the top, but it is built in. And the last structure which I am showing is something which is done from our own studio, which is in Jodhpur, a house we built almost about 10 years back. And it was again experimented with a kind of a passive cooling system integrated along with the design. So I'll go a lot more in detail with that. So this is the structure which we had designed. Again, if you look at the Jodhpur and their own structures, how they reflect, into the elevation of a building. How the formation of the building has happened is nothing but simply building the stack ventilation towers, passive cooling system towers put there, and then each massing is somehow segregated, by each other. The plan simply reflects how the building facade is going to take a shape. So it is not something which is added later on, but it is being integrated along with the design. And the facades are simply, again, and why I'm saying this, because this, though it's a very small structure, I know that nowadays, we dealing with the high-rise structures and all, but the prima facie, the integrated approach to design is something which says, like, see the facade here, are purely the outcome of how the building forms are being developed. and the formation of each in every little form, the segregation by the jalis, somehow beat, the heat of, the weather in Jodhpur. The glasses are right inserted inside so that the direct sunlight does not hit any glass surface. So the walls are becoming a lot more protective and thermally insulated. And the facades are not only outside. I see the facades are as well inside. Facades are very much integral part of every good building, whatever you see, even from the historical perspective. Like here, the wall simply comes in. So again, it's something which is a lot more integrated, with its own formation. And of course, in the night, facade also has its own story to say. So facades, again, as I have been telling, that it's something which is a byproduct of how you design the building. This is another building which, again, is been inspired, by these step well. The spaces, when you see, within the building, they are interactive in the section. And there's always scope for inner facade to be experienced and made. So this is a section of our own design studio which we built in Mundwa area during COVID time. And this is the building which I would like to show that how the facade here is also in a very interactive way, where it flows inside and outside. So again, it's inspired from the step well, where you have inner facades. You see that the kind of furniture and the walkways. So there are lobbies, through which you walk and see. That you are never cut off from what is actually happening outside. So you are constantly in the same spirit of what is happening outside. Like here we have allowed, see if you see this thing, that the blue line basically allows cool air to enter in, and the yellow line is simply reflecting that how the light penetrates within the building. And there's a constant exchange of light and air happening, which keeps the building environment inside a lot more lucrative for human to move, and so you're not a lot more dependent on the mechanical air conditionings and artificial lights. And this is what I see, that the facade need to be intelligent enough to be so percolative, to actually use the natural light and ventilation, which is constantly happening around, along with the view outside. And it brings a lot of life, what is happening outside, to the inside. So facades, to me, are meant to experience from inside. And like here, we have adopted a material called cotton steel, which has been perforated, corrugated, and used as a facade surface. So it's a breathing skin, which actually helps to building to breathe with the light and ventilation. So they are again inspired by the, the old jali patterns, which we normally see in our old structures, when they did not have a glass, they did not have a lot more technology, but how they met the aspects of climatic conditions to actually deal with. And the spaces inside, also you see, I see that there is inner facade, which has been used as a furniture, acts as a library, acts as a shafts for cooling ventilation system. It acts as a screen to project, hang artworks. So I don't see the facade which are only outside are limited from outside. They also enter inside. And this is how the perforated panels, which looks quite solid during daytime, appears transparent, during the night time. And to me, facade is not only restricted to the four sides. It is the fifth side, which is the top side. And the roofs are equally important. They also help you to gain a lot of natural light. Use solar panels to create the energy efficient buildings. And there are a lot more happening on the top, which can also be act as a facade. This is another building which we designed about 7 years back It is on Nagar Road. It's a corporate house of a Nyathi group, and it has been one of the very interesting, formation of a building which client wanted to have a kind of a facade which speaks about their group and about their progressive growth as a company. So we chose this subject of a tree which is symbolic, to the growth. And that's how the building, So this is the kind of an idea by which we developed the idea. If you look at it, the building has been divided into two sections. One is the corporate wing, one is the commercial wing. And we had to distinguish, through the facade. See, I think the facade also has its own expression. How you divide and how you segregate, that each function, what is happening inside is somehow segregated and used in their own way to talk and let the facade speak on every aspect what is happening inside. So if you see the green part are the terraces, okay. And what we thought is that all the terraces were cantilevering out. If we use structures which would create an interesting facade, but at the same time help to support those cantilevering terraces and make the building a lot more interesting, and allow and stretch people out from the carpet area to the terrace areas and let them be part of a facade as a kind of a space to interact with the outdoor as well as being a lot more connected with the indoors. And you see those cantilevering balconies somehow started branching out, those spaces, and made the facade a lot more interactive with the outdoors. And that building overlooks to the river and the long distant Sahyadri Hills. And very interesting view you get from the top. And that the whole idea of the facade extends to the club area, the kind of the plaza we could create, and somehow got inserted into this building to cover up, that also enters into the indoors. I see that the connection of the building continues when you see the elements which are used in the facade actually wraps around even in the interior facades. The lobbies also have we would like the architects to keep the designs in a way that you're wrapping around a building. You are just simply moving and the space continues. The spaces inside also has an impact of what is happening. Even we could bring the shadow of those branches falling into the carpet area. So there is this kind of a link where you are constantly connected, with what facade means. And facade is a story to me. It's not just a surface or a mask. And see that the kind of this space is extending out of the facade. So you are living with the facade. Facade is not something which you can't reach out. When you integrate it with the terraces, with the places where your plants are there, the greenery comes, it creates a kind of a little buffer between what is extreme condition on the outer environment and the inside and interior environment. And there's a buffer required among all the buildings to actually ensure that climatically the insulated spaces are kept more air conditioned, where we use plants and gardens as a buffer for people to go at any level. Like this is the terrace on maybe on the 12th floor, helps you to overlook the greenery. And then this is another corporate office we developed. Now, how the facade can actually act as a scripture. The facade has a kind of a huge surface. It has a dead surface, it has a translucent surface, it has a transparent surface. Like in this case, we could tap the surface area which is available to actually talk about the branding of the company. This is a Suhana Masala. They are into the spice making, and they have very well developed engineered products in terms of, giving us the best taste of the masalas which Indian food is well known for. So we use this surface. Of course, there are windows and there are things, but we wanted to see that we use a surface like so on the lower floor where we had a lot of glass. We could put the icons, and we call it Suhani icons. So we had hired, rather integrated the design from Elephant Design. Probably you might be knowing they are very good graphic designers, and they came up with some of the icons, and they got embedded onto the facade. So the facade became sculptures. And whatever icons what you see are somehow related with the history of Suhana as a corporate house. And then that flows within the interiors also. So our office actually develops a very integrated, seamless design which flows from inside to outside and somehow links the various surfaces. And as I see that, there are surfaces which are very well flowing. The material which is outside use comes inside, and somehow there is a flow of surfaces, and the color palette and the textural palettes somehow doesn't break you from inside to outside, but rather helps you to be there. And again, the Suhani icons hanging, placed on the wall, continues, the experience when one likes to enriched, while moving in and out of the office. The transparent facade becomes another story where the trees which are just connected, outdoors, actually almost becomes a part of the indoors. Again, the buffer zones between indoor and outdoor, the kind of a garden, the natural light coming in, the atrium gets filled with the natural light. We also use the system of passive cooling system to ensure that all atrium and the common areas are well integrated with the passive cooling in order to reduce the load on energy consumption, but at the same time brings a lot of life which is just immediately outdoor comes in. To me, facade is an outward expression to inner nature, contrary to the mask. Thank you very much.
So, ladies and gentlemen, this is the last session, thank you very much.
Thank you, sir.
So, ladies and gentlemen, this is the last panel discussion of the day. That was the last presentation. And to close out the ceremony, we have Mr. Shyam Raghunandan, who's going to moderate this panel discussion. Shyam, if I may ask you to introduce the panelists.
So my clock already says minus 2:32. So basically we can consider the session finished. So congratulations, we can all go home. I'd like to really welcome, I think, a very distinguished panel. I'll start with the investor community. Ms. Pallavi Matkari, business head for Runwal. She can join us on the stage. Architect Rupali Nimbalkar from the Malpani Group. Architect Amit Kembavi, consulting architect with DSP. Shitesh Agarwal from Sankalp Designers. Mr. Avinash Navte from Team ANA, the chairman and founder. Mr. Nilesh Ladad, managing director for Planage Consultants. And Mr. Madhav, who has, I think we are lucky, he's the designer of the building that we are sitting in. So really a privileged panel. And to introduce the topic, this is a, I think, topic where everybody is interested, wants something, but somehow I think the industry, we have not moved the needle on this topic of digitalization. So we will, I think, gain the experience of the investor community, architect, PMC, all of us here, and try to shed some light on what is digitization? What does it mean for us? What is in the way of gaining the full potential of digitalization? And what do we need to do as an industry? What support can we all provide to push the needle forward? So we'll dive into that topic as we go. Yeah, so maybe what I'll do is I just go around the panel. I think one of the problems with this topic of BIM digitalization is I think it means different things to different people. So I'd just like to open up, first of all, to each of you, in each of your companies, from your workflows, what does it mean for you? And where do you see the biggest benefit? Because there is quality, there is productivity, there is timely completion, there's a lot of benefits. So in your company, what does it mean? And where do you see the biggest benefit? And then we'll jump in to more detail. Yeah, please.
Hi everyone. I am architect Shitesh Agrawal. So basically, we are working on BIM since last 5 years now. And I think BIM is the future, because if you see in most of the European countries, in Singapore and all other countries, they have totally converted their studios to BIM. Most of them are working on Revit. And so we also adopted for our office. And so basically what is happening is the entire building is getting ready virtually in your computer, including every nut and bolt, and which makes the entire product to visualize it is in front of you. And a flawless kind of execution can take place. Very precise kind of output is what we can get. So I think from every perspective, working in BIM, and just that there are a lot of challenges. So we have faced a lot of challenges to come up with the final solution when it comes to BIM, because the coordination, all the consultants working on the same model. But I've realized that where we were 5 years back when we started, and now how it's become much smoother a journey now. So I think in India, more and more people are getting now used to working on BIM, and that is the future. So sooner or later, we all have to adopt it.
Yeah. Hi everyone, this is Nilesh Laddad. I'm from Planet Consultants. We are into project management services. I guess on the stage here, I am the only engineer. All of them are the architects. And what BIM really helps us as engineers do is the great people sitting around imagine wonderful buildings, and to really understand their concepts and to put it on ground. Manish just showed us some beautiful elevations to understand how to put it on ground. BIM really helps us model that. BIM integrates the detailing very well and helps us imagine. So when we actually see the BIM model, we are able to define how to build that structure. So many times there is one design and there's constructability of the design. And BIM helps us identify that better, is where I put it.
The way I look at BIM is basically construction is a process which has a lot of moving parts. And finally, the collaboration of all of that put together builds a building. So once you build a virtual building first, it helps you to see things through. You know what the potential problems are, and it solves those first. Predominantly in our office, we don't really use BIM for residential parcels. But when it comes to commercial or any of your malls or your basements of the residential, where a lot of services come and they need to move horizontally. For example, plumbing, which requires a slope and therefore creates a lot of problems for everybody. That is where the resolution is much better. You have already seen what is supposed to come, and the engineer can also understand what he's supposed to see when he sees it, when it happens in reality.
Good evening. I'm architect Avilash Nawathe. What is BIM? Let me borrow a quote from Lika Abuzier. It makes good easy and bad, difficult. We as an architect, when we do whatever structure and architecture intent, many times get compromised with all the inputs subsequently done by many people. I mean, of course, I'm not complaining, but this, of course, happens. And having that visualization on the very first day about every nitty-gritty of the construction actually helps each and every person, right from architect. I think architects are the one who benefits it most, to the developer and in the end, the end user. Thanks.
My name is Madhav Joshi. I'll stretch the analogy of BIM back into the past. Even if, it makes me to think that Michelangelo was BIM himself, because he was expert in all the skills that architect or engineer needs, even as an artist or a sculptor. Now, with the advent of technology, there has been numerous specializations. And some of the typologies of the building that we design and build require a lot of expertise of a particular field, particularly from the engineering side as well. So most of the buildings these days, you can see they need to be pre-engineered. So a lot needs to be sort of visualized, assembled together on the screen itself, so that no time is wasted, no material is wasted on the site, and the buildings can be finished on a timely manner and a budget or whatever. That's the whole purpose of integrating all the components, resolve the conflicts on the screen, and then get on with the work on the site. So in that sense, BIM is a very handy tool, and as Ritesh said, there's no way out, but we have to adopt and get used to these new tools. Thanks.
Yeah, I think so.
We have this one.
Yeah, I have it. Hello. Yeah. Hello, everyone. I look at BIM for two major points. One is timely completion, and the other is quality assurance. Doing things right the first time, I believe in that, because I think BIM gives you a very good concept of communication, visualization, and coordination. It's a very powerful design management tool which effectively involves not just the architects but all the engineers. We're doing 3 projects at Malpani in BIM, where the execution stakeholders are early in the process involved in the entire coordination. This helps a lot on the project, and I think if digital tools take care of the document control and the 3D visualization, we have a lot of time in hand where, based on our past experiences, we can actually do a right quality assessment.
My name is Amit Kimbavi. Thank you, Zach, for inviting us for such a wonderful panel discussion. For us, we have been into implementing BIM since quite a few years. The constant thing that what we are thriving is, when we started, it was more of 1D, 2D, 3D. So at our office, we are trying to take this level to the next level in terms of making it into more of 5D, 6D kind of a thing, where how we as architects can be able, or probably can become a catalyst to help developers or to help the contractors in order to understand, and probably even for us also to understand what the 5D and 6D can contribute into the efficient tracking of the systems, efficient tracking of the time, and obviously to maintain the a proper check on the sustainability and thus the inventory management as well. So this is something that what we are actively looking onto it, and plus what we are consciously implementing is taking the BIM to a very great level in the fit outs also. So as architects and interior designers, so we are now implementing BIM for the fit outs, which actually helps, like in the same way like what Sitesh said and Nilesh said, that it helps a lot of saving of time, because normally fit outs are very fast. But all in all, I think if we get good and proper time, only then BIM will be successful. Otherwise, it is always a fire and ice situation. BIM only works when you have time. So otherwise, in firefighting, it doesn't work.
So
I know from where
Exactly.
Amit is
And I
coming.
think-
We work
Yeah,
jointly
right.
on a project.
So
and
I
know
think
how-
to just, if I
what he's relating to.
summarize, I think there's a distillation around visualization so that people can see what is going to get built and identify conflicts and problems early. I think there's a discussion around coordination so that multiple trades can coordinate. That makes maybe completing on time faster. And there's a discussion on quality assurance that at least you know what is your benchmark and you can measure against that benchmark and finish. Those are the, I think, topics that came up. I think everybody is waiting to jump into the why, if there are so many benefits, we are not living in a virtual world with digital twin buildings and swimming through AI models. So let me start with I think a story. I think when I talk to a lot of our fabricator partners, we are in the facade business. We see the workflow coming from the investor. They're fully motivated to use BIM. I think the architect community also gets into BIM. The consultants get into BIM. The tender is released, and then BIM is buried somewhere. Because now I have 3 contractors who are either L1 or L2 who have no interest in BIM. Then it comes to the job site, and then somebody from the investor is walking around with an iPad, and the contractor is writing on paper, and somewhere it meets a swift end. That is the challenge I think we see, and from Shuko's point, we are trying to address that and see how we can bridge that gap, because that seems to be the bridge to cross. But I think let's come to the topic of other challenges. Why is it that we are not, everybody can see the future, the UK is doing it, US is doing it, Singapore is doing it. Where are we stuck? What is stopping India from living in paradise?
So I think he touched the pain point that the biggest challenge is we don't have time, we don't get time.
That's because the moment we have our land parcels cleared and the moment we have our approvals, we just want to start excavation.
Absolutely. That's what I wanted to say, that developer will purchase a land and the next day he wants the project to be started on site. So, as you said, BIM requires a lot of time, because eventually when we are saying that a virtually building has to be made in computer, but that virtual making requires a lot of time, a lot of coordination. Everybody has to come on one page. Everybody has to work on the same model, every consultant, and all this detailing which requires a lot of time. So I think that time management somewhere has to be considered, and developers will have to start considering that before we get to that final model or final extraction of drawing, there is a huge exercise that goes behind this. But I'll tell you another part of the story, that, for example, we are working with Godrej Properties or Mahindra Lab Space. So these kind of corporates, they have already started implementing this, that they are giving good 3 to 4 months just to make a BIM model and to come to that conclusion, and then only they start with the project. And I think if we just schedule it well, it is very much possible doing, because there is environment clearance which is required, which takes good 3-4 months at least. So we can utilize all that time to make BIM models and all the drawings. And I think another challenge is that there is a lot of uncertainty when it comes to our projects, because things keep changing. And when we are adopting BIM, you can't afford to do that. So there has to be a lot of certainty in your brief, in your program, what you want to make, how you want to make it. If that is very clear, for example, if you talk about facades, then there should be a lot of clarity that what is the kind of budgets are there, what is the kind of system you want to adopt. So it becomes very easy and very clear that then you can go for implementation of BIM.
So let me, I think, target this first to, because I think the root cause is always the investor community. Maybe I have talked to you and Ashish sir, I think the Runwal team. How do you approach from the investor side this topic of planning, preparing for the contract. How do you set up the project for success from this perspective? What are your perspectives on this? I just wanted to ask and then I'll get to the architects, because from the investor it goes to the architects and then the waterfall.
So basically, if you look at the project life cycle, there are certain steps that need to be followed. Yes, I agree that when a land is purchased, the first thing that comes to mind is, okay, fine, वो सब छोड़ दो, पहले उसको खोद डालो और फटाफट construction चालू करो. That's a mindset that people start with. But at the same time, if you really look at it, usually excavation takes a good 2 months, 2.5 months, especially in Pune where you have hard rock everywhere. It takes a lot more, days. When you have that time and you're actually sorting things out in a manner in which you meet every week and make sure that one milestone at a time is cleared off, it is quite possible to do things. Of course, there are constraints, there are costs which are attached, or finance which is attached, and then the interest costs. Therefore, I think it's quite possible to give the excavation plan, because excavation is going to be a big black hole types. And beyond that, I think a good 3 months, if you are investing yourself, you can work out the entire coordination, because the first biggest coordination is your structure and your architecture, while taking inputs from the MEP. Of course, the MEP comes a little bit later. If you plan it out like that, rather than try and do the entire thing on day one, I think it's quite possible, and we've done it in the past, where you do structure and architectural coordination. By the time you give the foundation start off, it is enough time to get MEP on board. Of course, the quantity takeoffs and those will not come in place on day one, but that's a decision that you have to make, and we've been doing that in the past.
No, I already have. Okay, first of all, coming back to what are the challenges? We have already discussed. Challenge is, of course, having all the people adopting to that particular methodology. What we have faced is, like Siddesh, we are also into Revit for last almost 7-8 years. And recently we have completed in toto, that whole thing. One of the things which I would beg to disagree with you is, even the MEP fire consultant has to be there right from day one. You have many inlays even in the rough foundation. So, visiting that subsequently doesn't make sense. I know what you mean, that like a rock cutting, nowadays we go 10 meter, 20 meters, so maybe it takes at least 6-7 or a year, depending on the strata, and that is the time which you can, utilize it properly. But one of the things which I would say is that one of the challenge is getting, all the people not having inertia are ready to really go ahead with the Revit drawings, and having that coordination, dedicating the team and the time for making it happen. The second challenge, most of the time we feel, like you have said, that the facade consultant. Now, suppose you get a structure consultant and the MEP fire, and of course the architect who are already doing the things on the Revit. But when it comes to other vendors, it really gets problematic. And the facade is one of the major component of the whole building. And nowadays, there are 3-4 projects which we have completed, and it was we got the AutoCAD drawings and converted it into Revit ourselves, with the approval of the thing. Now, if you really look into it, there are at least 5-10 different people, maybe illumination guy, maybe a landscape person, and so many people, consultant, who just refuse to be on Revit. Now, that is the biggest challenge, one of the things. Now, one of the reason, second reason is that, if I may say so, the investor actually don't pay, they don't appreciate. Even if they pay, they do not pay in terms of the percentage, because on the very first day we are completed with the whole bunch. Now, when there was an AutoCAD thing, we used to give it in a piecemeal wise. So we used to give the drawing as per the progress of the work. So that was okay with us. We don't invest. Now in AutoCAD, as an architect, we invest 100% of our resources and give you a complete set. And then we get the money in a piecemeal wise, doesn't make sense. So that was another thing which I think the investor has to really look into. So these are the basic challenges, I would say.
I just would like to clarify one thing. That when I said that you can get your structure and your MEP coordinated, I did not mean if I came out like that. I'm just going to clarify. You need to have all your consultants on board on day one.
Yeah,
so what
absolutely.
we do is we get all our MEP consultant, security consultant, fire consultant, whoever the consultant is on board on day one. So at the concept stage of the architect, coming to a sign off of concept, we already know who's going to be the MEP, who's going to be the structure.
That's great.
So what happens is, if you know the broad perspectives and you have the inputs from them, it becomes easier, because that's when the details start off. So you know what is coming where, and from there you can take it on.
Very true. So I'd rather misunderstood. Sorry.
Yeah.
I'd want to add something here. Avinash sir just mentioned about the initial inertia. I think BIM from engineer's perspective is a necessity. Everyone sitting here is agreeing. But I don't see a lot of architects making it mandatory. So sir, it starts from you, where I will work only on BIM. I will have only Revit models. I know it will take time and of course resources and money. Investors will have to agree to it. But if we make change of that initial inertia, so the architects start, because that's the starting point, then the other consultants adopt it. And when it comes to the engineer's table, it comes in a BIM 3D coordinated model. And we start from quantity takeoff, quality control, order placement, everything comes on BIM. And then somehow we will have to provide the infrastructure for the engineers to do that. How many engineers really work on tabs? I'm not sure. How many site engineers have the right computers in the site offices has to be checked. So providing the infrastructure is what really is stopping the BIM adoption. And actually the cost of that infrastructure is marginal as compared to the cost of the buildings being built. So I think it's more with the inertia, more with the starting point. So I would request all of us sitting here, the starting point should adopt. The end will automatically adopt, is the way I see it. Because for us, if I don't get a BIM architectural model in my office, I'll have to develop it. So developing it takes time. Rather, I get the model starting from the start, is what I look at.
Now here, Tutubimi will always happen. Now you say that it is from the architects. Now, as I said, it is 8 years back that we started. First 4 years was disaster. Because except us, nobody was doing all our conventional consultants were also not ready to be on there. Forget about the...
So it has been a learning curve. Just 8 years for you to start, 5-6 years we started, 5-7 years they started. So all of us have been adopted.
I think that is a summary of the inertia, why we are not in paradise still. So I think you were saying something.
Yeah, I would just like to state that we all speak about consultants being appointed in the first stage. In fact, as we are working, we are also newly working on 3 of our projects that I explained. So there are certain challenges that we are facing every time, and there is more than stipulated time that we are investing on projects. So why are we investing that kind of time? So, you feel BIM, oh my God, I need to get the all drawings in 3 months' time, and that's not happening. So when I delved into the entire process, I felt that one thing lacking is vendors. What we do is we take all consultants on board day one. We don't take vendors on board. So when we do our basements, the STP sizing, if we have a correct vendor on board, the drawing of the basement will not change. If we have a swimming pool vendor, if we have a PT vendor, the slab is designed by the structural consultant for 200. The PT vendor comes in, he does a value engineering, it goes to 175. Boom, goes your model. So every makes a huge difference in BIM. And that's something which I feel to make the implementation, the process, and complete it on time, you need all vendors also day one on
Which
board.
is then a conflict between the commercial and the engineering, because you can't get the vendors till you close the contract.
We have the drawings and the contracts.
Yeah, so based on the schematic drawings, if we have at that stage, then it works very well.
So I think
Just one comment. I think most of us here have been in that phase when people used to have hand-drawn drawings. I'm sure Avinash sir must have done that. Okay. So we were in those phases where everything was hand-drawn drawings, and it took a nice hiccup for things to move from that to AutoCAD. And I think we are at that juncture with respect to BIM. We are all right now at a stage where some of our vendors, I mean, very few of our vendors are not having AutoCAD. Some or the other form of AutoCAD they're using. And I think for that hiccup to get through, it is going to take a few years. And that few years, I think all of us have to bide our time.
A lot happened when this entire project was being designed. I mean, there was a advent of BIM. I'm talking about the story of 2006 when this entire project was conceived. There were too many workshops, too many meetings. There are many teams from overseas, ready to sort of give those services. And there was much discussion happened. This entire project has to happen on BIM. But the time of, equipping everybody with that knowledge and understanding and hands-on engineers team, we were relatively happy because we had enough time to sort of get on with the conventional way of designing, and we were well in place because finally it happened that the most important facet of BIM, which is Revit, that was the only aspect which was put to use eventually. And when the story came to, there are two stories. One, once we the project started, then there was a recession, the entire project stopped. Then there was that Tower B, as we call it, which had to be constructed in a speedy manner. So one contractor set up the entire precast factory, and that's when the facade and the precast component, the entire structural system had to be integrated. Although, we did not indulge in BIM, but we had a very intensive Revit coordination with an external agency who was helping us to resolve the conflict, because the facade has to be same as which was committed on building number A, Tower A and B. So that was the first instance. When it came to the Ritz-Carlton Hotel, the focus we had given, because we had to create the CAD drawings for architecture, coordination between architecture and structure had to happen, which also happened in a conventional manner. And that was given out to the Revit team, who started building the Revit models the way the construction starts, And that model was handy with the MEP team to resolve the conflict. So actually, it was used with a very selective manner, and all the conflict resolution for MEP was much quicker because although the conventional CAD drawings were available from our side and as well as the structural team, the much time, because for hotel there is a lot of very complex services systems. So that's where the time was saved, but rest of the things were much more in a conventional sense. So it was a conscious decision to deploy these tools where they are most needed.
So if we look at the challenges, I think just to summarize, I think one, what you were saying was from that commercial technical, you get all the consultants early, but the final design of the BIM doesn't happen till the vendors are on board. So there's a tension over there.
And there are changes that
Changes
do happen.
and everything has to be redone all over again. So there's some kind of double work that is required.
Just to add, Sham, to the thing what she mentioned, that once when you start the excavation, it's a normal myth that you have 2-3 months of time. And then the further the environmental clearance and all those things, further time. But when we sit with the project team. The moment the excavation starts, the next thing they say is, because now most of the structures are all high-rise, more than 100 meters, so everything is going to be in concrete. So the next immediate milestone is when I'm getting the RCC drawings. So to get the RCC drawings, are our architectural drawings ready? To get the architectural drawing ready is the sign-off from the client is there on each and everything. So it's a backward cascade.
Pressure coming from the deadline.
Yeah, I mean, so though we see that there's a 6 months of time, but actually there is no time. And it actually aggravates more when the project is in phases. They get the RERA registrations one by one. The moment the first building is almost 50-60% sold, immediately the next starts. So one resource, one team working on one project literally is working on 5 projects. So that is where the resource hit also is there in terms of the cash flow from our internals. Unlike commercial buildings where it is a cookie cutter,
Yeah.
most of the things are finalized on day one because they cannot change it unless and until there is a huge business plan change. So there, the things work pretty much smooth. And even maybe neck to neck also, it works very well. But when it comes to residential, unless and until you have time, it doesn't.
So I think the learning here is the opportunity probably lies in commercial buildings. And I think you made a valuable point. You're saying even within commercial, probably something where heavy duty services are required like hotels, BIM adds much more value rather than a cookie cutter office building where it's of course beneficial, but maybe not to that extent. So maybe the low hanging fruit
I would
is
say
a
that it's
hotel.
more easy there in commercial. Sorry, sir.
No, but one thing which I would like to point out, the percentage of commercial versus residential. Now, it is 80%, I would say, is going residential and all are 100-meter buildings. Now, we have, all the tower building nowadays, and that too with such a huge challenge, particularly smaller plot, more FSI, you have, then MAP, and then there is a mixed use and all those things. Very honestly, I wonder how this type of complicated residential buildings can be done without Revit. I mean, it's nowadays people won't imagine how we used to live without mobile 20 years back. So it is like that.
And like you mentioned, the moment is probably, and I wanted to maybe do a quick opinion check here. You mentioned the hiccup. I was talking to a builder, and I think he's one of those builders who's probably 5-10 years ahead of where the average is. And he was very clear. He said, Shyam, I am fully now digital on the job site. My requirement is that every vendor gives me a as-is BIM model back before they get paid. So handover means snags are cut and the as-is BIM model is given back to me. And my mouth was dropping. So I'm like, and maybe I should not say these things in a public forum. Maybe it creates bad ideas. And I thought that was a pretty heavy stick kind of mindset. But to address the point of the hiccup you mentioned, would you think there is a carrot approach? Like is it inner motivation, a carrot or a stick that will get us over this hiccup as an industry? Because this builder has clearly gone for the stick. But I
believe human nature usually works with the stick.
So you're of the stick.
I'm a stick
version. Any other opinions? Is this hiccup going to be crossed with a...
As a consultant, I would say it has to be carrot.
As a carrot, okay.
It's a combination. The expectation which you just said is very high. But there has to be an approach where you will have people adopt to it and there will be some pushing to it. Both will have to go hand in hand.
So just to add, basically when you say...
And they're asking for the mic.
Yeah, you can.
Maybe if you could pass the mic.
So basically, if you really look at it, there's a certain faction for which probably a carrot works. But for that, you really don't have to show the carrot. Okay, the consultant community for that matter. It's the other variety, which is the contractors, the vendors, who actually create the dysfunction in the system.
We are such nice people.
Some of you are, but some of you aren't. Okay, so for those people, you'll have to use the stick, because when it becomes a deterrent, only then people take an action and do some change.
It's a combination somewhat to get the ecosystem.
So I think to a large extent, the consultant community is very aware of the fact that yes, this is helpful. But finally, none of us is going to the actual ground and building it. None of us are vendors. So the vendors finally have to do the construction. If they are not tied in, then it doesn't work.
I think we're just talking about a very small aspect of BIM, but there are other takeaways as well, like getting quantities, a very good quantity takeoff. Then when we hand over the society, or we can hand over the BIM model to them, which becomes easy in maintenance. So there are n number of fruits to it.
For the investor
I think it's slowly, for investors. I think it's slowly catching up, and all of us, see, the vendors, there are very small time vendors who are not doing, but I think the big contractors, so we are working with certain big contractors who are already in the game. And one of our contractors is talking about he's taken the 3D model and he's now developing the 4D. So I think everybody is up on the game now.
one of the most promising thing that is going to come.
Yeah.
Just to add upon what she said, quantity takeoff is going to be one aspect which is very important there. BIM models can be used for asset management and maintenance. If you have the right model, if you hand over the right model to the developer for as-built, the investor, especially for commercial building, can use the entire model for asset management, maintenance, preemptive maintenance is going to come in. With AI added to it, it just makes life easier. But the initial hiccup or the initial inertia has to be overcome, is the point.
So since we are left with the last...
Just to add up to this, we're working with Mahametro for station designs. So entire Mahametro, they adopted BIM 4D, then 5D since inception of Pune Metro. And the entire model of Pune Metro is done in BIM, and virtually trains are running in their control room. So, that's the kind of level of advantages we have.
Actually, that's
I
a
think
perfect
like what
segue.
Nilesh mentioned some time back, that the developers or probably the architects need to say that, okay, we are coming only with the BIM and we work only on the BIM. So likewise, I would suggest that getting digitization into construction industry itself is a big challenge. Obviously, there needs to be a lot of awareness. With probably, I would say that a carrot approach, saying that all the vendors, because most of the consultants by default have to switch to that, but vendors as of now have a certain choice. So if from the investors or the developers, if there is a carrot kind of a system that, you have to work on these things only, then probably there would be some incentives or benefits. So probably I think once everybody starts migrating to digitization, so probably most of our lives becomes much easier.
So that could be one of the criteria for vendor selection.
Vendor selection, exactly.
You can get that.
I think you led into my last question, given the last, you mentioned Mahametro as one of the best practices you have had. I'd just like to invite the panel, in your long experience, which is a project you can think of, which is a shining example of how you would like to work digitally going forward. I'm sure there are enough success stories. And then, that's the hope for all of us. We can all follow you. What would be a project? I think you gave a great example already. Any examples? And Pune, I think the community is tight. Everybody will follow. I think this is an esteemed panel. You have projects in mind. We can look at that as a lighthouse and follow it.
Starting with whom?
So, one of the projects done in Pune, you're meaning?
Or in your experience, so we can all learn from what would be.
Recently I was visiting Switzerland. I was visiting Geberit factories, and the integration of SAP, BIM model, ordering, material requisition on a digital platform. So there's a factory with 12 people actually doing the operations. There's a inventory management, global inventory cell with almost 0 people and 70,000 parts to be handled every day basis, all robotically aligned. So just getting everything digitized, computerized, and robotically handled is something which, so I can show that video sometime, but
That's a best practice.
seeing is believing what they could do. So reaching that extent, Maha Metro, as Shitesh has mentioned, I have some study of it, and they are doing it beautifully. So they are going to asset management. Every branch in Maha Metro will be mapped as what they are trying to reach at. So bench chori ho gaya to malum padega. Diesel khatam ho gaya to bhi malum padega. So that's what they are doing.
So I actually had visited one site in Switzerland many years ago, and I was really, really stunned by their impeccable planning. Because for me, the way of digitization also requires impeccable planning. So this was a place where they were doing 40,000 square meters of slab when it was snowing and the temperatures were really low. And they had 20 people on site. It did not take 5,000 people to do that. And it was not the head count which mattered. And the planning was so impeccable that when they said 9:57, there'll be a concrete mixer which is coming to site. At 9:57, it was there. There were 7 required, 7 were there. So I think that is something we should gun for, the precision. And precision of planning, only then tools are helpful, because all digitization tools are helpful if you use them well.
Time is over.
Any other? Yeah, so I think we are, I'm sure if you have examples you would like to highlight.
I would like to state today morning, if you have seen Abhishek's presentation, there was one project of Malpani's which we are doing, M. Fibonacci. We're doing the entire in BIM. It's 2 million square feet of construction. We've hit the ground and it's humongous. And I think with little, we did have initially little snags and snips out here and there, but it's been very effectively implemented.
Oh, great. So I think looking at the clock turning red and we are in the way of everybody getting home, I think want to first of all thank the panel for such a nice discussion. I think we can do this discussion for another 1 hour easily.
Very true.
There's a lot more to discuss, which we'll do now in Delhi and Bombay. I am the messenger carrying it from city to city. But thank you for those inputs. And my personal request is to the community and to especially the investor community. I think honestly the burden lies on you to push the industry forward, set the tone, set the carrot and the stick combination. Then the architects, I think, taking the responsibility, pushing it through, because your visions are sitting in the BIM. And then, well-behaved vendors like us have to fall in line. And then the contractor communities and everybody has to fall in line. And then we live in paradise. So, yeah. And thank you very much for your time.
Yeah.
I'm sorry we had such a short amount of time to talk.
Thank you.
Thank you.
Thank you.
So thank you very much, ladies and gentlemen. That was a wonderful panel. Thank you, Shyam. I think that was something which was very informative, and everyone on the panel, I think there was nobody over here who got bored because it's so relevant to the work we're doing. If you all